Knowing how to design, tune, and optimize SQL Server really level up your skills as a database admin. Let's look at DB design, including table design, views, and change tracking. Then look at performance tuning and optimization, including indexes and statistics, as well as isolation levels and execution plans. Welcome to our lesson on understanding and designing SQL Server tables. In order to properly manage a database, it helps to have an understanding of at least basic database design. This lesson will provide a foundation for database design and aims to give you an understanding of various table types and structures, as well as a glimpse into tracking changes in tables. This lesson covers a review of table design, understanding special table types, creating views, using change data tracking, and change data capture. Let's get started. So in this lesson, I want to talk just very briefly about database design and how data is stored in a relational database management system such as SQL Server. Now, there's hours and hours of videos and classes and pages of books on SQL Server design and database design in general. So by no means is this an exhaustive discussion, but I think it's helpful to have this information, especially as a database administrator, to have at least a peek into database design. And you might be doing both. So hopefully this information can help you in your administrative duties as well as database design duties. So databases are made up of tables, and throughout many of the lessons in this series, we'll have played with tables and we're using queries to get data in and out of them. But let's look at a table specifically and talk through what a table really is. So we'll make a new query, and we'll select some data from, there should be, a schema called application, and we'll go to .people. So this is a good table because it really shows sort of a relationship of attributes and records. So in a table, and a table by itself, you could think of as a spreadsheet as well, because that's really all a table is. It's a collection of rows and a collection of columns, okay? So in database parlance, a row all the way across in a particular table tends to refer to a single entity or a single record. In this case, a single person. So this row I have selected here is for Kayla Woodcock, and all the data in this row relates to her. Her login, if I scroll over, you'll see her hashed password is stored. Is she a system user? No. Is she an employee? Yes. Is she a salesperson? Yes. What theme preference she prefers in her app? Her phone number, her email address, on and on and on. You even have a column here for photo, other languages they speak. All that information is stored here. But the unique thing about that is all that information in that one row, that one record, all relates back to that one person. And that's very important. And when you start talking about referential integrity and database design, you want to maintain that relationship. So if I look at the orders table, I should see a similar pattern occurring. If I just go to my sales.orders table and run that, you'll notice that each row in here corresponds to one order. Now it does point to a customer because the order was for a customer and it was taken by a particular salesperson, but this whole row corresponds to one order. So that's step one in tables. A table should be a collection of like records, and each record should relate to one thing, one entity that table is trying to model. Now across the table, and we'll go back to the application people table for this, the columns define attributes of those things. So as we saw, we had full name, we had search name, we had email address, we had is employee. Each of those things divvied up in all these columns are attributes or properties. And the properties are common to every record in this table. So everyone in this application people table has a full name. They have a login. They have an email address. They have whatever. And in some cases, it's empty. So you'll see some people don't have hashed passwords, and nobody at the moment has a photo, and not everybody has a phone number. But that's more of a reflection on that particular entity. Maybe that person doesn't have a fax number, therefore we don't store one. But everybody in the table has the opportunity to have all the properties. If there's a property or an attribute that only applies to a couple people, you probably don't want to store it in this table. That would probably belong somewhere else, okay? But in general, that's sort of how a table's laid out. Rows are records, columns are properties that relate to those records. Now, a table that's just a bunch of data like this is called a heap. It's literally data thrown into a heap. It's not indexed. It's just random data. We'll talk about indexes in a different lesson, and we'll talk about how you can store data and get at the data and how those help you. But data in a table is just kind of tossed in as a heap, but it all does relate to that same entity type, in this case, person. Now, I talked about orders and how they had orders for people that were customers, and they were people that were salesmen on that particular order. And that's the next sort of level of a relational database management system. So this is the stuff that you transcend spreadsheets. So you get out of spreadsheets and you get into relational data. And to understand how that works, I'm just going to show you a quick join statement in here. So I'll go back to my sales order table, and I'll just select it all so you can see it as we're writing this up. And if I want to know which salesman this order was taken by, all I have here is a number. Well, you'll notice this number here corresponds to the number in application.people. In fact, let me just select from both so you can see. This number here corresponds to one of these people IDs, this person ID. This person ID and this order ID and order are what's known as a primary key. That is very important, and again, that takes you a step above a spreadsheet and more into a table. A primary key is a column or columns that, if I know the value of, will uniquely identify one row in a table, okay? So I'll say that one more time. A column or columns whose value will uniquely identify a row in a table. So think about, in the real world example, you're assigned a social security number if you're in the US. That number uniquely identifies you and only you. Your driver's license ID, your passport ID, any of those things are real-life primary keys because they identify you. And we use primary keys in databases to identify rows in other tables that might relate to my data. So because person ID 2 is always this Kayla Woodcock person, we know anytime we see person ID 2 in any other table, it's referring back to this row, and I don't have to duplicate this. If I was doing this in a spreadsheet, think about using an old school Excel spreadsheet to track orders, I would type in the order number and it would ask me for my salesperson, and what am I going to type? I'm probably going to type that person's full name. But what if I mistype it on one order and then the other? So in one, instead of Kayla, I add an extra Y. It's K-A-Y-Y. Now when I try to find all the orders from Kayla, I'm going to miss one because there was a misspelling, okay? Using a database and using relationships and using primary keys alleviates that problem. So I can do a join statement here where I select all my sales orders, right? And then I just type join. And the table I want to join is this one right here, application.people. So I'll just copy that down here. And then I have to tell it what to join on. So in this case, the join is going to be on from my orders table. And I can keep typing sales.orders.whatever. Or I can put in a little shortcut. And to do that, all you do is put a space and give it a letter or some other word like order or something short. I'm going to say O. And for my people table, I'm going to do that too and just put P. And then I can say join this people table by looking at my orders table, O, and look at the salesperson ID right there and find me all the records where that matches the P dot person ID record. Now, when I do the select star, this is going to select everything from orders and from person ID all the way across because it's going to give me the order, and then it's going to use this salesperson ID to fill in the blanks to get my salesperson ID. So I can go ahead and run that. And you'll see now I have everything from my orders table here. And if I scroll over, eventually I start to see here's the data from my person table. Now, I don't need to pull everything in, so I could choose to get individual pieces. So instead of star, I can say from my order table, which is O, get my order ID, and also get my order date. And then from my person table, get the full name. And now if I run this, I'll only get these 3 columns across these 2 tables, and that gets me my order ID, my order date, and my full name. Again, I'm getting into a little bit more T-SQL here, but why not? It's helpful information, I think, that can help you out. I don't know from looking at this result set that full name is my salesperson's ID. I know here I joined on salesperson ID, so I know it's salesperson. But how would anybody who's looking at this data set know that that's salesperson? So after full name, just like I did with table, I can hit space and give this column an alias. And I can just say salesperson. And now when I run this query, you'll see that column name says salesperson, and I know that's the salesperson. Now, application people is a kind of an interesting table in this database. It stores all people, and you saw some were employees, some were salespeople, some were customers. They're all stuck in this same table. So if I want to get, say, the customer for this order, I have to join this table, this application people table again. So I'm just going to copy that join, paste it one more time. In this case, though, instead of calling it P for people, I'm going to change both of these aliases, and I'm going to say for this one, call it SP for salespeople, and for this one, call it CUS for customer. Then I have to come up here and change that SP so it knows I want the salesperson's full name. Same with this, so it knows it's getting the salesperson people ID. And then down here, I just need to update this to join on my customer ID. So for orders, I'm going to say customer ID equals customer.person ID. And now I can take this CUS for customer up here, and I can put that in, and I can do full name again. And once again, I wouldn't know what that means. So I'm going to type customer name. And I'm going to run that. And now I have a list that shows me the order, the date, the salesperson, and then the customer ID. So that's just a quick look at how that would work with relations. So when you're talking about tables and how they store data, couple key concepts, and we're going to expand on some of this as we talk about indexes and some other things and other lessons. But you have a table. Each row is a record that relates to a particular thing. The things in that table all tend to be the same. So they're all people, or they're all orders, or they're all cars, or whatever. Each column is an attribute to that thing. And then we use primary keys to identify a record with a unique key. In this case, it's a customer ID or an order ID. And then I'm able to make relationships with what are called foreign keys. So this salesperson ID in order is actually a foreign key that points to the primary key in the other table. So that's how we're able to pull this data together, and that's where relational databases sort of go beyond spreadsheets and go beyond any other data storage. Now, again, there's many, many lessons and video series and books and you name it about database design. And this was by no means meant to be a database design course or a database design lesson. But I wanted to cover these concepts because there are other lessons in this series, such as indexing and a few other things, that having this level knowledge of database design will be useful. So I hope this was informative. And as I said, if there's other things you want to dig into, there's a world of knowledge out there about database and SQL Server database design. So in general, when you're working with SQL databases, you're mostly going to use regular old tables. Now, there are a couple special table types that I want to point out. We're not going to demo each one of these, but I want you to at least understand what they are. So as you're going through and working with SQL, if you encounter them, you know what they are and you know how you could potentially use them for your systems. So as it happens, the Worldwide Importers database has some of these tables already set up in them. And you'll see here, the standard table has this table icon that just sort of looks like grids and rows and columns. Okay, that's a standard table. You also have system version tables, which have this little clock on it right there. And there are some of those, obviously, right here in Worldwide Importers. And essentially what a system version table is, you'll notice if I expand this, I have application.people is the name of my table, but I also have application.people archive. And if you look in there, it has the same columns as the columns that are there for application.people. And what that is it gives you a history. So as things have been changing in the system, you have this archive. So if I select all from application.people and run it, and then I also select from application.people archive and run that, you'll see I still get data, but I only get, in this case, 961 rows of it. As of here, I'll select them both. So I get 961 rows in this archive, and I get 1,111 rows down in this full table. And you'll notice here, for example, if I look at 14 in my real table, it's Lily code, which corresponds to what I'm seeing up here. But what's up here in this archive is an older version of this same record. So something changed, something got modified, and this system version table, which is also called the temporal table, is storing some of the histories and storing some of the old data. So it's a way for you to go back and see how things existed prior to the change in the main table. Whereas normally, data's gone or data's changed and you can't see it anymore. So this kind of gives you a little bit of a history and a little bit of an archive you can go back to. And you'll notice here that 14, there's Lily code again, and I can actually narrow it down. So I'll say where person ID equals 14. We'll just pick on this Lily code person. And you'll see she's in the archive 17 different times. So these are 17 different versions of Lily code. And you can see some of these are like other language changed, whereas it didn't here. And it tells you some valid from data over here. And if you look at regular people, here again, let me do this so we can just see her standard real record as well, side by side. So you'll see as I come over here, some of these valid tos and froms changed, some of these dates changed on her, and that looks like that might have been what changed. A lot of the other data looks the same. But I have 14 different rows, so 14 different histories of Lily code. And that's all stored inside these system versions tables. Now, to make one of those, if you right-click table, you can say new, and then instead of table, which is what we normally do, you say temporal table, and the only version of temporal table that exists is this system version table. And that lets you set up these kind of tables that can store history. You also have some very specific types like ledgers and graphs that I'm not going to really dig into, but those are things that let you set up some different kinds of data. Graph tables essentially give you a way to model many-to-many relationships in SQL Server. So a node is like a table and an edge is like a relationship. And it gives you a many-to-many model. You can do that with regular tables. You can create two tables with a many-to-many joined table in the middle. This just kind of gives you a different way to do that. You also have memory optimized tables, which are great for lookup tables. Portions of these are stored in memory, and they're only hardened to disk every so often, so they're much faster. So they're great for lookup tables, data that you have to reference a ton because you're going to get it from memory and not from hard drive. So it's a little bit quicker. You also have external tables. This is for storing data in external sources such as Azure. And then file tables. So file tables are kind of neat. I'm not going to do a full-blown demo. And I believe there are some in this worldwide importers database if you want to dig into them. But essentially with a file table, I can create what looks like a table in SQL. So it would look like this kind of a table like people or people archive, but it could be called invoice files, for example. And when I read from that, I can actually read a file out of that table and send it down to a client, like read the bytes out of the file, and they now have that file that they can access. But what's really happening is that file table's saving to a directory on the hard drive on SQL Server, and I'm able to use file streaming to move things back and forth. So if I write a file to SQL, it ends up as a copy in this folder on the hard drive. And I can go the other way. So I can copy files to a folder on the hard drive, and then when I query the table, I can actually see those files. So it gives you a connection to be able to store files, quote unquote, store files in SQL Server without actually storing anything in SQL Server. Because you can, and we saw in some other lessons, and in this table in particular here, photo is a column that's available in this application people table. So photo is a file, right? It's a type of file. And if I look at application people and I look at columns, you'll see photo is a var binary max. So I'm essentially streaming binary data into a column and storing it as a photo. Alternatively, I can do these file stream tables or these file tables where I'm actually storing a photo on the hard drive, and then I can just relate from my application people table to that photo rather than streaming it in and out of binary data in a column. So it's just another option for you. So all those are accessible if you right-click table and say new. And again, I'm not going to demo all of these. Again, the purpose of this isn't to really go through database design in a heavy fashion. I just wanted to make sure that you were familiar with all these table types because you're going to bump into them in the sample database, and you might need to use some of these specialty tables as you're starting to design your system. So I just wanted to make you aware of their existence so that you can use that information going forward as you design your database. So if you've gone through any of the other lessons in this series, you'll see that we've often referenced tables and we've pulled data in and out of tables, and they are truly the heart of a database. That is where everything lives. But the other piece of using a database is you're constantly trying to read data in and out of said database, and you want it in a form that is friendly to your users and friendly to your applications. And how it's stored in the tables isn't always designed to be user-friendly. It's more designed to be appropriate for either relational database or for speed if you're setting up a reporting server or whatever the case may be. And often your data is scattered all over multiple tables because that makes sense from a design standpoint, but not necessarily from an access standpoint. So I'm going to show you what a view is and how you can use it to start creating literally just that, views of your data. So I'm just going to start a new query in the Wild World Importers database. And I'm going to select some data from some tables. And this is a fairly common thing that you would have to do. So let's just select all from orders. And it's actually sales schema.orders, so we'll do that. And I want to make a list of all my orders and who the salesperson was and who the customer was, and I want the customer's email address. Okay. So to get that, first I have to start with, well, I want the order ID. That's in this table, order ID. So let's get that. So we'll select order ID. But now I immediately need customer data, which is in another table. So now we have to start doing joins. So I'm going to just break this into a couple lines to make it clear to read. And to get customer data, it's actually in the application dot person table because customers are people. So application dot people. And we'll call this just for short customer. And we're going to join this on sales orders. And we'll just call this ord because I don't want to type sales.orders every time. So we'll join on order dot customer ID equals customer dot person ID. Okay. Now I called that customer and not people or person because I need another person, and the other person is the salesman. So I'll copy this. And I'll also join people again, but I'll call this one sales. And I'll join this on order.salesperson ID equals sales.person ID. So that's right. So now I've joined these other two tables in. It's the same table being joined twice, but that's fine. And I'll get the order ID, which I already have. Let's also just grab the order date. And let's take the salesperson ID. So I need from the sales table I created dot full name. And then I want the customer data. So I'll take customer.full name. And I want the customer email. Okay. Now, two of these are going to come out and say full name in both columns. So I just want to give this a little more detail and say I want the sales person name, and over here I'll call this the customer name. Okay, so now I can run that query and I get what I wanted. It's a list of my orders by date, salesperson name, customer name, email address. If I wanted to further filter this, I could filter for a specific salesperson or a specific customer, or I could look at date ranges. I could do all kinds of stuff with it. But here's the thing. I don't want to have to type all of this every time I want this set of data. This is 3 different tables, technically 2, but I'm using application people twice. So it's 3 different joins, and I'm pulling 5 or 6 different columns. I just want this to exist so that I can query it later. So that's where views come in. Views in SQL Server are stored sets of transact SQL that return data. Okay? So to create a view, I can come up here and I can add the line create view and then give it a name. So I would call this order sales customer list, something like that. And then I just have to say as, that's just the syntax, create view, name, as, and then specify my select statement. Now when I run this, instead of running the select statement like it did before, it's going to create a view that stores the select statement into it. So I'll just hit F5. There you go. And now this view exists. So if I look under views, you'll see I have this order sales customer list that is now under my views folder. And this allows me to just run select star from order sales customer list. That's it. I only have to know that. And when I run it, I get the exact same data that I got from this big, hairy query up here. Okay? So a view lets me encapsulate select data and just rerun it over and over. Now, the nice thing is, as far as the query engine is concerned, and as far as the way you write T-SQL code, this select statement still returning me data. This select statement could still be a table. So nothing stops me from saying, what if I have this order ID and I also want to see the order lines? Well, right from this view, I can join sales.order lines on, and I would need this whole view name if I want to type it in, which is fine. And I can say on this order ID equals, and I'll just shortcut this because, again, I don't like typing, OL for order line, dot order ID. And now I've joined order lines directly to this sales order view, and then I can run that. And now you'll see I get my first 5 columns. That's what comes from order sales customer list, right, through this email address. And then right here, because I have star, I get all the data in my order lines table. So I could further narrow that down and say I only want to see the stock item and the description and the quantity, just like I did with my other select, but I can join right to that view. So views return data that look like tables, but the data is coming from somewhere. It's coming from underlying tables. And then that data is bubbling up, being saved, and now it's basically a stored query that just runs every time I call that view. Now, there's a few pieces and parts that are a little more complicated with views as far as security and how they access underlying tables. And I'm not going to get into too much of that. But what's interesting with views and tables is as long as you have what's called ownership chaining on, and in this database, it should be, so I'll just show you this real quick, worldwide importers, properties, options. So you'll have cross-database ownership chaining, and then you'll have cross-database ownership chaining is false. So I can't go cross-database with this because it's not enabled, but I can internally. And what ownership chaining means is if this view and these tables all exist and have the same owners, and in this case they don't because this is DBO and these tables are in their own schemas. One's in sales, one's in application. If they all have the same owners, all I need access to is the view, and I can still query the data. I won't be able to access the tables directly because I don't have access to them. But because I have access to the view and they have the same owner, I can still see the database, the tables, the data in them. Now, if they have different owners, as is the case here, access to this view, read access to the view will not be enough. I'll also need access to these tables. I don't want to get bogged down in that in this lesson. I just wanted to bring it up because as you start creating views and as you start storing queries in them, you might run into that if you start giving people access to your views and you don't have chaining set up in a way that they can access the tables. So it's called ownership chaining. It's a concept you might have to dig up as you start creating views. Again, a little out of the scope of this lesson, but I just did want to mention that while we were here. So that's pretty much it. Views are just stored select statements. You don't have to create them with a script. In fact, there's an OK GUI that exists. If you right click and say new view, you actually get kind of a graphical interface. So I could do the same thing I just did with script in here by going down, getting my orders table. So I selected that one and selecting my people table. Those two are now selected, orders and people, and then I can hit add. And then you can see it actually starts graphically to show you every place that these have joined. So this person ID actually points to the salesperson, the picked by person, the contact person, the customer ID, and something else down here, last edited by. So there's lots of opportunity for this to point back to the people table. And then I can start dragging things together. So I can say I want my order ID, I want my full name of my salesman. I can drag that in, and I can just start to really drag all this out, and then eventually you'll see it's building this query for me. And alternatively, I could just paste my query in down here. It doesn't show up nice in the graphical interface, but I can just paste my query down there and hit save. So this allows you to sort of build a view, and there it went. So it did update finally, the graphical interface. So this allows you to graphically sort of build these tables, and you can see here when I have table sales, alias salesperson name, this sort of gives you a little more info about what information I'm pulling from and how I got things. And if you don't want one of these columns in your output, I can just uncheck that, and you'll see it comes off my statement down here. So I can pick the columns I want. I can start putting sort types and sort orders, and I can do all kinds of other stuff in views. Again, a little out of the scope of what we're doing here. I just wanted you to understand what views are. So I'm going to close that down and not save it. So quick lesson, and really all we were focusing on in this particular lesson is that views allow you to store select statements, and then you can later utilize those views as if they were tables to retrieve data, to join to other tables. You can even insert into them. There's a couple of restrictions around that, and you could update data in views, and all of that then trickles down to the underlying tables, and it just gives you a great shortcut rather than having to type out these long, complicated queries every time. So this lesson, I want to take a brief look at change tracking and how you can implement that on a SQL Server database to sort of get some information on changes that are occurring within that database. So here I have this HR database on my SQL Server instance, and I want to enable change tracking. So to do that, you just right-click on the database, you select Properties, and then here on the Change Tracking tab, you'll see I have Change Tracking False. And it's quite simple. I can turn that to True, and now I can track changes in my database. You'll see there's a couple of settings I get, real simple. Retention period, how long will you keep this tracked data? And then the units, so in this case, that's 2 days. I could set that to 2 hours, 2 minutes, 2 weeks, but 2 weeks would be 14 days. But I get days, hours, and minutes, and I can provide a number. Default's 2 days. You'll see I also have this auto cleanup. Auto cleanup is what happens to get rid of the old data. So after 2 days, auto cleanup runs and that data is lost. If I set this to off or to false, then you can ignore retention period. Basically, without auto cleanup, it's going to keep the data forever. Okay, so you set the retention period, and if you do actually want it to clean itself up, you say auto cleanup true, and now it'll clean this stuff up every 2 days. And that's all you have to do to enable change data tracking on a database. So I'll hit OK. Now I have this little script here with some various change data tracking stuff in it. And I'm going to use it to sort of show you how to track some changes and what's enabled and what's not. So let's just start with this first select. There's a system table called Change Tracking Databases. And if you select from that, every database on your system that has change tracking enabled will show up in this query. So you can see right now, the only one I have is database ID 7. Auto cleanup is on. It has a 2-day retention period. And that's basically it. So by seeing that, I know that database 7 is in change tracking. Now, if you want to know which one database 7 is, there's a table called sysdatabases. You can look it up. In this case, the only one I've enabled this on is HR. So that is the HR database. Now, what about tables that are being tracked? So if I look at sys change tracking tables, you can see what tables are being tracked inside this database. And in this case, the answer is none, because we have not set that up yet. So let's take a look at that now. I have a table in here called email list. And at the moment, the only thing in it is one record, and it's my email address. It's actually a fake one because yahoo.net's not real. But I'm not tracking anything in this table. To do that, I have to alter the table and enable change tracking. And that's what this statement here does. So I'm going to alter the table email list, enable change tracking with track columns updated on. So that will enable change tracking and also track any columns that get updated. So I'll just go ahead and hit F5, and it says it cannot track changes because it requires a primary key. So that's a very important thing. In order to track changes on a table, they must have primary keys. Okay, so we can easily add one. This table will support that, the data, and it's just perfect for it. So I'll just go over here, right-click my email list table and hit Design. And I'll just use this ID column as a primary key. So I will unallow nulls, because you can't have nulls on primary keys. And then there's this little teeny key icon that says Set Primary Key that I'll click up top. And you get a little teeny key icon that appears next to ID, which means that'll be the primary key. And then I'll just hit Save. It'll apply the primary key. This is another interesting thing that will happen in SQL Server. They want you to be careful about making changes that require a table to be recreated. Because I'm putting a primary key on, that changes the way tables are stored. So it actually has to drop and recreate this entire table in order to apply this primary key. Okay, so my choices here are to basically ignore this, delete and recreate the table myself, or I can tell SQL Server Management Studio that I don't need it to be quite this picky. So what I'm going to do is I'm going to go ahead and hit cancel here. This will stay open. My change has not been saved. And I'm going to go to Tools, Options, and in here, if you look at the Designers and the Table and Database Designers option, you can see here there's an option for Prevent Saving Changes that require table recreation. I'm going to clear that. This will now allow me to save changes with the designer that require a drop and recreate. In a production environment, you probably want to be a little more careful about this kind of stuff and use well-written scripts or deployment software to make sure you're getting all your stuff deployed and changed and modified in the right way. But this is a very small table, so for this demo, this isn't going to be a big deal. But in order to add this key, it will drop this table and then recreate it and reinsert all the data. If it was a bigger table, this could take a while, but it will not because there's only one row. I now hit Save, and you'll see that just saved, no complaints. So I'll close the designer, and we'll go back and we'll attempt again to alter the table and enable change data tracking. This time you'll see it said it completed successfully. So now if I look, there's a couple different system tables and system functions. These are now functions we're looking at that provide information on things that are in my change data capture universe. If I select change tracking current version, this function just returns me what version is my change tracking on. And right now it's on 0 because it just started. Nothing's really happened. But let's do some stuff to email list. So I'll right click the designer again. And right now it has email, first and last name. And maybe I want another column for phone number. And we'll just make that a varchar 15. And I don't know, maybe I need, for some reason, a zip code. And we'll make that a varchar 10. Now, not the best data types for those things. And we'll turn off allow nulls on a couple of these columns. And email, I want to call, instead of email, I want to call it email underscore address. Okay, so I made a few changes, and I'll hit save. And this is going to get angry at me because there's already data in this table. If anytime I have not allow null on a new column, it can't create that column because the data is not allowed to be null, but it doesn't know what to do with it. So I either have to specify a default or allow nulls for now. So I'll just do that. So I'll go into zip code and I'll allow zip code to be null. So as I save this and it adds the new column, all existing records would get a null zip code. So I'll hit save. Table's been modified. And now if I come back out here and I select from my email list, you'll see very plainly that there's a phone and a zip code. Both are null because they didn't know what to put in there yet. And I could update that and add something in if I wanted to, but no real need. So here, taking a look at those changes, you'll see the two new columns are there, phone and zip code. Let's change some of the data in this table. So I will update my DBO email list, and I will set the phone number equal to 555-555-1234. Oop, these need to be dashes, sorry about that. And basically I'm setting a phone number. I'm not using a where statement, so this would set every row, which I don't care about because I've only got one record in here, but in general you would put a where clause on this. So I'll set the phone equal to that, and I'll set the zip code equal, oops, sorry, I need a comma. So phone equal to that, zip code equal to 12345, and I believe I also made that a varchar, so I got to put quotes around it, and we'll run that update statement. And you'll see there we go, one row affected, and if I look at my email list now, I have a zip code and I have a phone number. Okay, so we've altered the table, we've then messed with it a little bit. Now we want to look at these two functions down here. First one is select the change tracking current version. So what version of stuff is my data on? So if I select this, you'll see I'm currently on version 3. This is a zero-based array. Every time changes are detected, this increments. Okay, not a big deal. This change table function, and you'll see if I show you, basically I want to select from change table any changes to the DBO email list, and this is the version. This 1 is the version. So I can do this for the current tracking version. I can do it for older versions. So we'll go ahead and do it for 3 because that's the current tracking version. And I'll just return this as CT for change tracking. And I'll run that. And you'll see I don't see anything there. So I can also take this all the way back to 0. And you'll see there is a change that occurred at state 0. So it went to syschange version 3. You can also probably look at 1, and you can kind of see these histories as things have changed along the way. But what this is telling me is that during the syschange version 3, you'll see these columns were changed. And this mask, which I'll zoom in on, this is a mask that tells you which columns got changed, okay? And it was 2 of them, right? I updated phone and email. And so you'll see column 5 and column 6 changed. That's pretty much what you get. And if you look at email list here, see the columns, you'll see here's 0, 1, 2, 3, 4, and 5. So these columns changed. It gives you a mask. It tells you which columns were updated. It's not much more than that. So all I know is that in this change, I had a syschange as an update. These columns got updated. That's pretty much the extent of it. So it lets me know that things did change, and it kind of gives me a version as to when they changed. And there's a little more you can pull out with some of these change table functions. But in general, this is what change tracking gets you. Now, if you want to really dig down and see what changed and how, that's where change data capture comes in. And there's a whole other lesson on that. So for a real simple change tracking, you can use this change tracking device and you can track these changes and pull some information out of these system functions. But if you really want some good stuff, look at the lesson on change data capture, which we'll also cover here in this series. So change data capture is a feature in SQL Server that allows you to capture when data changes in your database. So anytime DML statements are run that cause changes, you can track and capture that information to see what's changing and how, and possibly use that for recovery. So I'm going to show you how to enable change data tracking, and we're going to do a simple example of how to look at some capture history. So in our HR database, we have an email list table that we're going to enable change data capture on, and we're going to see how that all lets us see what's going on with the changes. So step one is you have to enable change data capture on the database. Now, there are a bunch of change data capture procedures, and you can look these up in books online. You can also see them if you use IntelliSense. So if I type sys.sp_cdc, you can see all the different CDC procedures you can use for helping jobs, starting jobs, scanning, drops, cleanups, all kinds of stuff, because you can do a little bit more with CDC than what we're going to show here. But I just wanted you to be familiar with the fact that you can do some change data tracking, and then there's more to do, obviously, that you can flush this out and make it what you need for your system. So the first function we're going to run is spcdc enable DB. And we're going to do this in our HR database, which we're already in. So I'll just hit execute. And this goes out, command completed successfully. And now this database is ready to do change data capture. So now I have to tell it what table I want to capture data on. So I'm going to do it on my DBO email list table. And I'll just fire that up here. And this is basically saying what's the schema, DBO, the source name, email list, and I'm doing it for the role CDC. This takes a second, and it goes ahead and it does it, and the jobs are started, the cleanups, everything's ready to go. There's a warning that basically says it can't grant, deny, or revoke permissions to SA, DBO, or the owner. So essentially, it's just saying it couldn't grant me permissions to see the stuff because I basically already have them. So you can ignore that warning if you're running this as a DBO. Next, we can actually run this to see what data or what's set up for the change. So this is like a help function. I can see help, change data capture. I'll just show you what that shows me is objects that I've enabled change data capture for. So you can see here the DBO email list, and I've narrowed it down with these parameters, is set up, and here's a starting LSN, and here's all the create dates and primary keys and some information about the change data capture tables I have. So that kind of shows you that it's set up in kind of a state of where it's in. So you can see the start LSN. These are log sequence numbers that are logged in your database log as you make changes, and this sort of tells you where the state of the table is. Now, I need to get captured columns. So if I run this little guy and hit execute, you'll see here that I don't have any captured columns because there hasn't been any change to anything. Nothing's happened, nothing's changed, right? So what if I make a change to this table? So I will go to the email list table, and I'll hit design, and I'm going to delete this zip code column. I don't want that anymore. And I'll hit save. And now if I come back here and look at the captured columns, I still don't see anything because I haven't modified. So let's do something to the table itself. Let's just edit the table. We'll do it this way rather than run a script. We'll go through and we'll change this phone number to all twos, and maybe I'll add a second person with a made-up email address, and it's me again, and all threes. That's fine. And I'll hit save. Actually, I don't have to hit save. Once you tab out, that saves when you're doing an edit. And we go ahead and we get the history here of this captured thing. You'll see it doesn't have any schema history because nothing's changed. This query shows me the columns that are being captured as part of that table. So if I execute this, you'll see in my email list table, it's tracking all the columns. So all of these columns are captured. And it gives me a little bit of detail about those columns. Now, we make some changes to this table, and we should be able to see those reflected in the change data capture. So if I come in here and I say update email list, and I set the email address equal to my email. And again, this is going to do it for every row in the table. Not a big deal for this demo. And I run that, it affects both the rows in that table, so they both have the same email. But what matters is now if I look at this capture history for the capture instance, and by the way, the capture instance, you can see, here I'll share that real fast, in this help change data capture procedure, the capture instance is right here, and it's made up of the schema and the table name, and you can actually specify your own name for that. It's one of the optional parameters. But right now it's DBO underscore email underscore list. And now I'll get the history for this particular capture instance. So the one other thing you want to take note of in this change data capture result here is the capture instance name. So mine's DBO underscore email underscore list, so it's the schema underscore the table name. And I can then look and see what columns are being captured. So you'll see here, I'm capturing these 5 columns, and that's the stuff that we're looking at when we do this change data. So you'll notice this has 5 columns, and if you look at my table, I have 6 columns. That's because this column was added after I started change data capture on this table. So I can make a second instance of this, and that allows me to continue to capture this particular table with new column histories. I can enable it on this table again, but what I can do this time is I can also specify an capture instance. I believe it's called capture instance. Capture instance. And we can call this email list 2. Comma. Okay, and so I can enable this on the table and I can track it again. So now if I look at this and I see what I'm tracking, it's the same table, I'm tracking it twice, but once I'm tracking it as DBO email list, and the other one, I'm tracking it as email list 2. So that's just an instance of a table being watched. And if I come down here now, and instead of looking at DBO email list, I look at email list 2 with no underscore, I can see what columns I've captured for that table, and now it's all of them. So in one instance I'm watching, here's the captured columns I had, and the other instance I'm watching, it only has everything but zip code. So now what happens, if I edit email list, and I delete this zip code column, and let's say, let's just do that, and I'll hit save. And then maybe I add a different column that's address, and I hit save. I've now made some changes to this table, and so I should have change data capture history, but I'll have it for different instances. So we'll start by looking at DBO email list, which was the first one we set up, which only had 5 columns. And if I run this, you can see there were some alter tables done to this instance. So here, after I started tracking, there was an alter table command, and it added zip code. Then I dropped zip code, and then I added this new column called address. If I look at the other instance, which was email list 2, so I'll just get rid of this and run that, you can see since I started tracking that particular instance, all it saw was the drop of the zip code column and the add of the address column. So they're sort of set at the time that you started watching them, okay? So that's sort of how the change data capture works. So you can see when things were altered, and you can actually see the command that was run to alter the table. You can also see the log LSNs, and you can see the time that this stuff happened. Now again, I pointed out at the beginning that there are a lot of CDC procedures. So again, if you just use IntelliSense here, You can see all the different things you can do, enable and disable tables. You can get some DDL, you can check the DDL history, which we did here. You can scan different jobs, you can scan different tables. There's a whole bunch of other stuff you can do with CDC, but using CDC on top of change tracking, on top of server audits, on top of your log files. I mean, even the query store, which we didn't talk about in this lesson, but the query store stores execution plans. You can really start to get sort of a live look at what's happening in your SQL Server. You know when things are changing, data, when DDL is changing, and all of this information you can sort of use when tuning your database, or if something happens and you need to know when and how something happened, something like change data tracking, I can see where in my log something was altered and then potentially go back to a backup, maybe restore that data. But I can also see the commands that were run, and you can really start to nail down when things happened, and that information can help you better administer your server, better recover data, and hopefully if you have issues with attackers or something like that, this kind of information can help you better secure your SQL Server for the future. Welcome to our lesson on performance tuning and optimizing SQL. Keeping databases online and backed up is only half the battle. To be useful, databases have to be able to provide data to users and applications in a timely fashion. This is where performance tuning plays a huge role. This lesson will provide a look at the performance tools available in SQL Server. We cover understanding isolation levels, using execution plans, configuring clustered indexes as well as non-clustered indexes, and using index statistics. Let's get started. So this lesson, we're going to take a look at how SQL Server manages transactions and how you can set different isolation levels of those transactions. Now, transactions are very important in terms of data management, and I like to give the ATM withdrawal example as why transactions are important. If I get money out of an ATM, several things have to happen. One, I have to put in my card, then I have to enter my PIN, then I have to tell them how much money I want, at which point we go down a series of paths that all have to happen or someone gets angry. So what I mean is the bank has to look up my account. They have to take, say I'm getting $20. They have to take $20 out of my account. Then they have to have the ATM machine physically give me $20. If the power goes out and that ATM machine can't give me my money, but the bank already took the money out of my account, that's a bad thing, and you would want that transaction to be stopped. So essentially, it's all those things had to complete or none of them get to. In other words, if they had already taken my money away, but then the power goes out and the machine can't give me money, they need to realize that and put the money back in my account. Likewise, if something happens and they were unable to electronically move money out of my account, the ATM machine should not give me the $20. Otherwise, the bank has a problem and they've given me money that they haven't accounted for out of my account. So that whole thing is a transaction that has to occur, and all of it needs to succeed or none of it should be allowed. And you can do, in database terms, what's called rolling back. So you can take back something you've already done. So in this case, I could start a transaction and say pull $20 out, now dispense it. Oh, the ATM is broken, it didn't dispense. So you roll back everything else you've done, put the money back in the account, and say, I'm so sorry, we can't do this right now. So that's sort of what a transaction is conceptually, but now we're going to look at how it works inside of SQL Server, and then what the different isolation levels of those transactions are, which dictate how you can read data and when. Okay? So if we look in here, I've got a fairly big setup for some demo I want to do. But the first thing I want to talk about are these transaction isolation levels. And we're going to go through and see how each of these work. And for now, I'll just copy these off into a new query so we can look at them without seeing all that extra sample code. So when I start a transaction as a process, I can set up an isolation level and I can tell SQL how isolated I want to be from other transactional changes. Read committed basically means I can only, and this is the default, it means I can only read data out of the database that has been committed. So if something is in process, in that another transaction has changed something, I won't be able to read into that section of data until they have committed it. And committing it in the transaction is what sends it to the database. So I start a transaction, I do some work, and I either commit it, which means I'm done, save it all, or I roll it back, which means something happened, I take it all back. Okay? And read committed is your default level. So here's how that would work. I'm going to go ahead and create a table called cars. Okay, there we go, easy peasy. And into that table, I'm going to insert a few values. So I'm going to insert, by the way, the table, let's see, we have an ID, we have a model, and we have a color. So I'm going to insert for ID 1, model A4, color white, for 2, Grand Cherokee, silver, for 3, Equinox, black. Okay, 3 different cars, I'm going to pop them into this table. Done. Now, I need to set up 2 separate sessions that are trying to do something with transactions. So what I'm going to do is open up yet another query. In this first one, I'll select star from cars, and back comes my data. But now, what if I want to change something? I want to do a transaction. So what I would do is I would type begin, and you can put tran for short, or you can actually type out transaction. It's up to you. But I'm just going to do tran, begin tran. I'm going to select all from cars, which is fine. And let me just refresh my IntelliSense cache here so it knows I created this table. So I'll select all from cars, but then I want to update something about this, right? So I'm going to update the cars table, and I'm going to set color to blue where the ID equals 1. Right? So I will basically try to update, no, I'm sorry, not 2. I said 2, I meant to type an equal. So I'm going to update this table, and where ID equals 1, which is the A4, I'm going to change the color from white to blue. At the end of this, I have to make a choice. I either have to roll back my transaction, and I'm just going to comment it out here, roll back tran, or I have to commit it. Okay? So I'll have those 2 options available, but I'm going to comment them both out for now. Because what I want to do is I want to show you how a basic read committed transaction works. So if I come over to my other session here, and I do select all from cars, this works no problem, as you would expect it to. But over here, I'm going to begin a transaction in which I'm going to select everything from the cars, and then I'm going to update the cars and set a color to blue. But until I commit this transaction, it hasn't happened in the database. And remember, the default isolation level is this, read committed. So I'll actually put this in here just as a reference, but that is the default. If it didn't say anything, it would be read committed. So I'll run this. And you'll notice what happens is this is done. It says the query has executed successfully. Within this session, I can still go select all from cars, and I can see that my color is blue because it's been changed. But this transaction, because I began it and never committed it or rolled it back, this transaction is still in flight, which means other things can't access the data in the same way. And by default, this is read committed, meaning he can only read data that has been committed. This data is locked up because the transaction's in flight. So if I hit execute, this does not return. That is because this particular transaction, not even a transaction, this particular session is blocked from reading into that other transaction because a change has been made that is not yet committed. So he's just going to wait until that cars table becomes available again. So if I go over here, I can still select from cars because it's my transaction and I'm still in it. And I'm going to go ahead and commit. So I'm just going to uncomment that, and I'm only going to run this commit line. So I'll hit commit, and you'll see my transaction completed, and I can look at cars, and this should be unchanged. I've committed my color to blue. But you'll notice this other session finally got a return back, and it could see that the car had been changed to blue. That's what your isolation level means when it's read committed. It means I don't want this session to be able to read data that isn't committed, so I get blocked if another transaction's in the middle of an update. Now, what if I don't care and I just need to read data and get on with my life? Well, that's the next transaction isolation level called read uncommitted. So uncommitted, I can just change this up here. I'll add UN, done. This now will allow this session to read even if the data is uncommitted. But what I will read is uncommitted data. So let's change this car to pink. And I'll do the same thing. I'm not going to commit the transaction. I'm just going to let it hang here. It's done. If I select all from cars, you'll see it's now pink. Perfect. This other session will not get blocked this time because now I'm telling it it's allowed to read the uncommitted data. So it's going to read the data that has not yet been committed, and it'll see that that A4 is now pink. Reading uncommitted is also called a dirty read. The reason it's called a dirty read is because I just read that this A4 is pink. This would be like reading the balance on my bank account prior to the ATM giving me the money. I see the money out of your account, so I assume that's your balance. I don't know there's something else happening that could put that money back. So I read pink, and I move on with my life having acted on the fact that this car is pink. But let's say over here, this transaction, something bad happens, and I have to roll it back. So if I roll back the transaction, I'm not going to run another update statement, but watch what happens. I'll roll this back. Now, if I select from cars, the car is still blue because when I roll back, any changes that got made as part of this transaction are discarded, and the car never got changed. But remember, this guy went ahead and read uncommitted, got pink, and ran off with that information and did what he had to do. So he had a dirty read, and that can be dangerous because it gets you the wrong information. You'll notice he was never blocked, and if I select again now, the car is back to blue because that is the current state of the data. So reading committed, you have to have the data hardened. Reading uncommitted, you can read into these dirty writes and dirty data as it's in flight. Now, there is another one that's a little bit different. This one's called repeatable read. So with this repeatable read isolation level, what we're saying is that as soon as I read some data in a transaction, that data has to be repeatable and not be changed. So I essentially lock the data up a little sooner in the transaction. Before, it wasn't until I wrote the update that I locked anything. Now it's as soon as I read something. So I'll just do this. I'll set my isolation level to repeatable read, and I'll begin a transaction, and I'll select star from cars. Go. So you'll see I can see all the colors of my cars, pink, silver, and black. If I go over to another query, this one that's still set to read committed, it can still select from cars because at the moment, the cars table isn't locked for reading, right? But this transaction has to be repeatable, meaning I selected from cars now and I got this data. If I select from cars again, I need to keep getting this data, okay? So what that means is nobody else should be able to update my cars table. So if I come over here and I attempt to set a car to green, this should get blocked. And it does, even though my other transaction has not yet written to the table, this one's not allowed to because this isolation level guarantees me that this read is repeatable, meaning the data is not allowed to change. So no matter what, in this transaction, I can come back here. I'm still going to get the colors as they were prior to me changing anything. So repeatable read kind of locks the table for write as soon as I read it. So this guy over here is just waiting. And over here in my transaction, I can still do what I have to do. So now I'll change this to blue and I'll hit execute and I get one row affected. This guy over here, still blocked, can't do anything. He's going to change this to green, even though I just changed it to blue. So what happens when I commit the transaction now is I'll commit, which means I committed my change to blue, And if I select all from cars, you'll see the car color is actually green. Because what happened is this guy was just chilling and waiting for that other guy to finish. And as soon as he did, he ran in and wrote green to that same table. Okay. Now, you can also get into weird states where one table has something locked that the other query needs, and these can create what are called deadlock situations. So when that happens, if I have two processes that are running and I'm trying to update a table reading data from something I've locked, but then you all of a sudden need access to something that I need access to something you've locked and you need access to something I've locked, neither of those queries can continue, and you'll get what's called a deadlock. And one of your queries will receive a message that says, you've been chosen as the deadlock victim. And essentially, SQL tries to decide who spent more time, and that person gets to continue, whereas the person who spent the least amount of time gets kicked out. So you can run into those situations when you're bouncing back and forth with these transactions. So there are two other isolation levels. One is, we're not going to really demo. Serializable is basically one of the tightest locks. So as soon as I start touching anything in a query, in a transaction, I've locked it up. So it's sort of like repeatable read in that I've read something and now I've started to lock it. Serializable is even worse. Like other things can't even read from that. We're not going to demo it because it's similar to what we just looked at. But there is another thing I want to look at called snapshot. Now, snapshot isolation is pretty neat. And here's what we're going to do. I still have this cars table, and that's fine. But now I'm going to set up two sessions, okay? Just like before. Session 1, right here, let me just grab all this, is going, just delete that, to read from a table and attempt to make a change. And session 2 is going to kind of do the same thing. It's going to read from the same table and attempt to make its own little changes, okay? But before I do this, I'm going to enable something else on the database. So here's session 1, there's session 2, and you'll see the transaction isolation level on both of these is snapshot. For this to work, I have to come back up here and I have to, where's my statement? I have to alter my database. There it is. And I have to allow snapshot isolation. So I'm going to do this, alter database HR, which is the one we're working in, and I'm going to set allow snapshot isolation on. There you go. So now I have this snapshot isolation. So how does this work? So over here, I'm going to declare a variable called ID, and I'm going to get the ID from this table where the model equals A4. And in fact, at the moment, that's been changed to A6, so we'll just change that to A6. And then I'm going to attempt to update that table and change that color blue where the ID equals the ID I read up here. Okay? So first of all, I'll just set the transaction isolation level. And actually, I'll do this without even reading that ID for a second. I just want you to see this. So there you go. It's 1 that comes back from this query. So that's what's going to go in this little ID variable. All right. So we'll set the ID variable equal to A6. I'll run that. I'm in a transaction, but so far nothing bad's happened, right? I can still come over here and I can do the same thing. A6. I can begin my transaction. And I selected from the car where the model equals A6. No big deal. I still got it, even though I have a transaction running. But now I want to go ahead and update this car, and I want to set it to blue. So I'll do that. I'm still in the transaction. Oh, I do need my ID, so I got to do this again. So I'll do that. There we go. Oh, yep, sorry, I do need the whole thing because I have to declare the scalar variable. So we're going to run the whole thing again. In fact, let me just roll back the transaction so that I don't have anything running. Roll back tran. There we go. Cool. So now we'll just run this and we'll update that car. And I get 1 row affected. Now, within this transaction, I can select all from cars. And I can see that my car is blue. Okay? I haven't committed this transaction yet. Over here, I can still select where the model equals A6. which I guess is this here, and I can see that it's green. And if I set this transaction isolation level, we'll do this add ID thing, I can still see it's green. But you'll notice over here, I had already run this update, right? It says blue. And previously, if you remember, when I was reading data, I was getting either dirty data or committed data. In this case, what I'm seeing, even though I've updated this, and even though this isn't reading dirty data, this is using transaction isolation level of snapshot, I can still select and I can still see the color is green, even though before I was blocked because the other transaction has made this update and changed it to blue. What happens with with the snapshot transaction isolation is as data is changed, I essentially keep track of what's changed. And when this guy's reading, he's actually reading what used to be there from this special like snapshot file. So I'm still seeing the data here as it existed prior to this update, and I'm not blocked, okay? I could then attempt to update this thing to pink, which of course, now I'm blocked because the other transaction is off doing its thing. So I can't update myself to pink. I'm now waiting until this other transaction's done. This guy though, you can plainly see it still thinks it's blue. I could even change it to green. And right there, oh, sorry, it's going to yell because my ID isn't right, so I'll get that again. Right there, I was able to update it to green. I'm still happy. It's still green. This guy's still blocked because I attempted to update. And eventually, I can commit, and then the same thing will happen, and it'll go ahead and push it through. So that, did I not hit commit? Commit. Oh, there we go. I had several transactions. I had to commit them all. So that finally let it move. Now this, you'll see, it aborted due to an update conflict. Why did this abort? So when I read the data during this snapshot, what I got was data that was partially from the snapshot. So I wasn't reading uncommitted data, certainly, because I didn't see the green or the blue. And I wasn't reading committed data because it was blocking me from seeing that. So what I read was data from the snapshot. So I was able to read data, move on, and do what I needed to do. But you'll see here, it aborted due to an update conflict. I cannot use snapshot isolation to access this table inside of a snapshot because essentially what happened was I attempted to update the table in its snapshot form. And in this case, when this guy finally committed, it realized it was trying to write snapshot data and then disallowed it. So as opposed to this then coming in second and changing the color again, it got disallowed because I was having an update conflict and it knew about that. So essentially, and I'll just share that one more time, let's just change this guy to yellow. And before I do this, take a quick look, it is green. And so I'll run this whole thing here. There we go. If I was reading uncommitted data, this would return yellow, right? Because it would return what's already happened. If I was read committed, it would get blocked. But instead, what I get when I run this here is I see green, which is what it was prior to this transaction. So I'm not blocked from reading. I see the snapshot. So this made the change. It took a little snapshot of how the data used to exist. So I'm actually reading old data, not uncommitted, old data. But again, that allows me to continue reading through and doing things while other transactions are updating data. And then we'll just go ahead and commit this one like so. And now when I read over here, this should have no problem and it should be able to see that new change. So they're both, oh wait, now this is the other thing that's interesting. I forgot to mention this. So see, when I select from cars here, this now sees the change as yellow, right? This whole transaction, because I started it with snapshot isolation level, I'm still in that. So this transaction is still bound to read from the snapshot. So I still see green. And until I get out of this transaction, I still see green, and I didn't change it to green. So if I try to update, I get yelled at because I can't use snapshot data to update. So what I'm going to do is just roll back. And again, this did nothing. I'll roll back. And now when I select, I'm no longer in this snapshot. And so I'll see the new data and I'll get the yellow. Okay, so once I begin a transaction in this snapshot, that's what I'm going to read. But it allows me to continue to read data as it existed prior to another transaction, stepping on my toes. All right, so those are transaction isolation levels in a nutshell. Again, this is one of those topics we could go on and on about. Transactional consistency is very important in SQL Server. And so you'll wrap these large sections of transactions that all have to be committed together with begin and end transaction statements, commits or rollbacks. And you'll set your isolation level to whatever it needs to be to basically get the work done you're trying to get done. So reading uncommitted, I'm not saying is always a bad thing. You're just seeing changes that are in flight that may or may not still be there. So if you're trying to grab some quick and dirty statistical information or some quick and dirty reports, then it might not be bad to read through a transaction that's not complete. But if you're going to rely on it to make changes to, say, bank account information, you should probably have the committed data. So read committed should probably be your isolation level of choice. Again, that one is the default. Repeatable read, things lock up as soon as you start to read, and serializable, things really lock up as soon as you start to touch anything. So pick the right isolation level for what you're trying to do, and in a lot of cases you'll have to kind of mix and match some of these, but there's some great options in there, and you should be able to figure out everything you need to do to write logical transactions to help protect the integrity of your SQL Server data. So behind SQL Server is a thing called the Query Optimizer. And essentially what this is doing is every time you run a query, it's trying to figure out the best way to access the data in the database. And it's making use of things like indexes and statistics. And it's making all these choices to try to figure out a way to execute your query efficiently. You can see the plan that it's putting together using a thing called execution plans. And that information can help you to tune your database and or your queries to get the best performance out of them. So that's what we're going to take a look at here. So I'm just going to fire up a new query in my wide world importers database here. And I'm just going to do a simple select statement. And I will select all from sales.orders copy. Now I'm using this table because it's raw data with no indexes or anything else on it. Before I run this, I want to do a couple things. One, I want to go over to the query menu and I want to check include actual execution plan. And the other thing you can do here is you can say display estimated execution plan. And what that'll do is that just showed me an estimated execution plan. So this is what it thinks this query is going to do when I run it. I haven't actually run it yet, so this is purely an estimation, in this case a pretty good one, but it thinks it's going to select data and most of the work's going to go into a table scan. That's fairly accurate. You'll notice that there's some data here that's all zeros and it can't fully calculate everything because this isn't the actual plan. But if I execute the query, after a second, you'll see this execution plan tab popped back up, and this one should look pretty similar to that estimation you just saw. But what this is telling me is what the query optimizer had to do and how the data had to be retrieved for this query. So this can help you find things in your query that aren't running efficiently or that need to be tuned, or maybe things in your database where you're missing indexes or something of that nature. A good rule of thumb when you're looking at execution plans, scans are bad. So scans basically mean that it had to go through this whole table to find what I needed. And when you select all from a particular table, that's not all that surprising because I said, give me everything from the table. But what if, and just let's take a look at the results so we can pick some dates here. What if I wanted delivery dates? So I had a where clause where expected delivery date is greater than, we'll go with 5/9/2013, and expected delivery date is less than we'll say 5/9/2014. So there are 73,591 rows in this table. I'm going to look for a range of delivery dates over this year. Okay. I'm just going to go ahead and run this query. And it's going to run and it's going to give me my execution plan. And you'll see the results. I got 19,000 rows. So I definitely got fewer rows. About a third of them of the whole table fall within these date ranges. And if you look at the execution plan, it still did a table scan. But you'll see 100% of the cost of this query went into scanning this table. So what that means is to find these 19,000 rows, it actually had to look at almost 80,000 rows. It went through absolutely everything to find those rows. It gets even worse if I say select all where the order ID equals, 1234, 1, 2, 3, 4. That's one row. One row. Now this is a relatively small table, so that's still returned relatively quickly. But if you look at the execution plan, again, it table scanned the entire table. So imagine I had a list of orders written down on a piece of paper and they weren't in any sort of numerical order. And I said, hey, go find order 1, 2, 3, 4. And I handed you 70,000 sheets of paper. And you have to go through all of them. And here's the kicker. You don't know that there aren't two order 1, 2, 3, 4s. So it's not like you can stop as soon as you find the first one. You have to go through all 70,000 to find the orders 1, 2, 3, 4. That would be inefficient and slow. And that's the same thing happening in SQL. This is inefficient and this is slow. So anytime you see a table scan, index scan, anything like that in here, it's woefully slow, and it's something that you want to maybe look at fixing. Now, conversely, if I just select all from sales order, not copy, for both of these queries, each of these tables these versions have the indexes. So if I run this, here's my execution plan. I still got my 19,000 rows out of this other table, but you'll see here, it actually did a clustered index scan, which isn't much better than a table scan, but instead it scanned the clustered index. The clustered index is, and there's a whole lesson on clustered indexes and what they are and how they work, but essentially it is an index that defines the order in which your data in your table is stored. So your data is stored in this order, which means if I'm looking for something that's part of that index, I can find it without having to look at the whole table. I believe on this table that the clustered index is on order ID. So we should see a bit of a difference when I run this query. So I'll hit execute, execution plan. And so you'll see this time, this did a clustered index seek. So rather than scanning, you'll see the number of rows read. I can't point to it, but that right in the middle of that yellow, maybe 6 things down, number of rows read is 1. Meaning it used the clustered index, and think of a clustered index kind of like a dictionary. So if I handed you a dictionary and said, go find this entry, you can pretty much skip right to that entry because you know how the alphabet works. You can jump right to that entry. So that's what this did. Because there's a clustered index on order ID, it jumped right to it. So no scan, no nothing. Read 1 row, okay? Much more efficient. Whereas with this one, you'll see it did the scan, and if I hover over it, it read all 73,595 rows. And the actual number of rows was 19,887 that it returned. So these query plans can sort of help you see how your code is running. Now, if you use something a little more complex, so in Worldwide Importers, I have a view here called Order Sales Customer List. And this actually gets data from the application.person table as well as the sales order table. And I'll just select all from this little view and I'll hit execute. And this does more than just select from one table. It's selecting specific columns and it's doing some joining. And so this execution plan gets more complex. And these execution plans can get very, very complex very fast. And you'll see with this one, you start to see these percentages and where the work was done. So here you see I did a hash match. This is an inner join. So essentially this is how it joined one table to the other. And here, I'm going to script this view as create to my clipboard so I can just pull out the select. So this is the select that I'm running inside that view. So I'm selecting some columns and I'm doing inner joins from sales order to application people. So these hash joins are basically these inner joins happening where I have to say, well, go find the customer ID in my order table and match it to the customer ID in my people table. And I do that twice. So you'll see the hash join here. Then it scans this index, which is a non-clustered index scan. And this is in, you can see down at the bottom where it says object. This is the application people full name with that scanning. And then down here, I do another hash join because I joined this table 2 times. And then I do another index scan to get the person ID, the full name, and the email address from the table for my customer. And then down here, I finally do a clustered index scan to pull out my primary sales, my order ID. Okay, so these are all these scans I'm doing. So again, scans aren't the greatest in the world. So we don't have necessarily a great set of indexes for this particular query to work with. So there's certainly some tuning we can do. Now, we're going to continue to look at execution plans when we do lessons on clustered indexing and on non-clustered indexing. And as I said, these execution plans can get very, very complicated, very, very fast. And I don't want to go into too much more detail in this particular lesson. What I wanted to show you in this lesson is how you can cause these execution plans to run and how you can look and see where the hotspots are. So you look at the cost value. That's 39%, this one's 18%, and this should all add up to 100. So I can find that what I was doing most of the time was these 2 hash joins followed by this index scan here at the end, which was 42% of my total cost. So I can use these execution plans to see all the different things that are happening. And the goal is to find things that are bad. Again, scans are bad. Look for scans. And you want to try to encourage things like parallelism and things like that where you're actually using multiple threads to go fetch data. So for this lesson, go run some queries. You can kind of mess around with it, play with some, look at the execution plans, and it kind of helps give you a sense of where you might have some performance tuning opportunities in your server. In terms of finding data in a SQL Server table or a set of SQL Server tables, the query optimizer uses what are called indexes. And indexes are very, very important in doing just that, indexing into tables to find things. And there are 2 primary kinds of indexes that SQL Server utilizes. And in this lesson, we're going to focus on clustered indexes. Think of a clustered index as a dictionary. All of the data in a dictionary is stored from A to Z. And if I need to find a particular word, panda, I flip to P, PA, PAN, PNDA, and not only have I found the word I need, panda, I found the data, the definition. So that index is inherent in the way the data is stored. Now, if you think of an index in a book, that's more like a non-clustered index. So the way that works is I take, say, an encyclopedia, and I want to find entries in this encyclopedia about pandas. So I go to the back of the book, and I look in what is called an index, and I find panda. I don't find any data about panda there, but it tells me here's the 10 pages where I can find information on pandas. So I go to page 10, I go to page 15, I go to page 200, and on all those pages are the data that I needed about pandas. That is analogous to a SQL Server non-clustered index. So I still have an index that I can find the references to my data in. Then I can jump into my data, in this case my encyclopedia, to find that data. The clustered index is the dictionary, where the data is stored in the order of the index. So there's no other jumping around. In SQL Server, it's much the same. So I'm going to show you a couple of tables and kind of show you the difference between a clustered index and a table with no index. So I'll do a new query, and I will select all the data from sales.orders. And I'll hit F5 and I'll run this. And the data comes back. It's 73,595 rows. And you'll notice it's ordered by the customer ID here. Okay. If I select from sales orders copy and run it, I'm going to get the same 73,595 rows. And on the surface, it's going to look very similar. But you'll notice something very different. If you look at the order ID column, they're sort of in order, 6636, 6637, but what happened to 1 through 6,635? And the answer is it's just somewhere else. So if I start scrolling down, you'll see I get up to 8,000, 30,000. Now I come back down to 17,000, 69,000. And 1's in here somewhere. I mean, I'm probably not going to find it scrolling around, but you can see this data is not in order. I'm in 17,000s now. As I scroll up, I saw 30s and 40s and 50s, now back to 20. The data is sort of all over the place. This is what's known in SQL Server land as a heap. Okay, the data is stored in the table, kind of in the order the data was put into the table or modified in the table. So there's no real order, there's no real rhyme or reason. So at least with this sales order, if I handed you this on a sheet of paper and said, go find order 30,000, you can treat it dictionary style, right? You can scroll around and you can look, and then I can scroll down, and eventually here, I come across 30,000. I'm at 29,700, 800, 900. But you get my point. I can find 30,000. It wasn't super efficient, but I got there, and I got there relatively quickly. Now, if I did the same with sales order copy, all out of order, and I said, go find 30,000, I mean, good luck. You're going to scroll until you find it because there's no order to this data. So I don't know if I need to jump way ahead or just a little bit ahead. I'm never going to find it because it's all out of order. So that's stored in a heap. In order to put a clustered index on a table, you basically, it's usually part of the primary key, but it doesn't have to be. You create an index, and it actually affects the storage of the table. And I'll show you why that's important here in just a second. So I want to go into the sales orders copy table that has no indexes and create a clustered index. So I'll open up my database, and I'll just go to tables. And here's my sales order copy table. Actually, no, that's the DBO version. We want sales.orders.copy, which isn't showing up. So we're going to refresh. Sometimes if you create a table, it doesn't show up right away and you have to refresh it. There she is. So now we have orders copy. So keep that in mind as you're creating tables, especially with scripts. You might not see them. Just refresh your view. I'm going to right click and I'm going to hit design. And you'll see that I don't have a primary key. There's no key icon next to any of these columns. And what's more, if I come over here, there's this little button that sort of looks like some rows with a key on it. And that says Manage Indexes and Keys. And if I click that, it brings up this little dialog box that shows me all the indexes and keys on this database table. There are none. So I'm going to add a primary key to this table. Now, remember, actually, I'm not going to add a primary key because we're going to do this wrong. So a primary key is a piece of data that can uniquely identify an entire row, which means if there's duplicates of it, that's probably not a good primary key. In fact, it's not a primary key at all. It has to be unique data. But clustered indexes have no such restraint. They're just going to store the data in an ordered fashion. So what I'm going to do here is I'm going to create an index, and you'll see I have a few options. What columns do I want in my index? I'm not going to use the order ID column. I'm going to use the customer ID column. Now, anyone out there saying that's a stupid clustered index key, you're right. And I want to do this on purpose because I want to show you what happens if you do this. So I'm going to use customer ID as my clustered index, which means I'm going to store all the data in this order table by customer ID. And customers, you've all shopped online, I'm assuming. You've placed more than one order. So customers can exist more than one time in this table. Me as a customer could have placed hundreds of orders. Each order can only exist one time, but I can have hundreds of them. So this is not a good clustered index because I'm going to store all the data in this table by customer ID. but we're going to do it anyway, just so I can show you the result. Now, is unique, if I say yes to this, as it goes to create the key, if it finds duplicate data, it's going to fail. And in this case, this is definitely not unique. As I just said, I can have multiple orders. So I can exist as a customer more than once. So we'll say it's not unique. We will say type as index. So I get index, unique key, or column store index. Unique key is just sort of forcing uniqueness. I want to stick with indexes for this lesson. So we're just going to pick an index. Now, down here, I can give it a name. I like to name my indexes with the table name underscore the column name. It's sort of just my best practice, but you can sort of do whatever you want. But then I easily can look at this and say, oh, that's an index in my orders copy table on my customer ID column. So I know what it is by looking at it. You can also give it a description if you want. Now down here, there's a whole bunch of options on the index. Most important one for this lesson is it clustered, yes or no? This option here is really the only thing you'll have to change if you're going from a clustered to a non-clustered. However, when I say create as clustered, one thing to keep in mind is you only get one clustered index per table. And again, that's because the data is stored as that order, as that index. I can't have a dictionary that is sorted both by letters for the word and by a number, some random number. I can't sort the dictionary two ways. I only have one way to store the dictionary, right? Same thing here. So I'll just say yes, and there's a bunch of other options and fill factors and data specification stuff. I'm going to leave a lot of this alone for now. The data specification, so this is where it's stored. So you'll see it's in a file group and it's on my user data file group. If you have multiple file groups or multiple files, you can store this someplace else. So you can tell tables to live on different files. And in this case, with a clustered index, telling it to live on a different file is akin to moving the whole table to that other file. So I'll just go ahead, hit close here. And that has now created, well, it hasn't created it yet. It has set up this index. And as soon as I save, it's going to go ahead and do it. So I'll hit save. If your Management Studio yells at you about not being able to drop and recreate a table, there is an option you can turn on and Tools, Options, Designer, Table and Database Designers. You can uncheck this Prevent Saving. Putting a clustered index on requires you to drop the table. Drop means delete. Delete the table, put it back and restore the data because you're literally resorting and restoring how this table exists on disk. Okay, so I've now saved it. And if I come back to my query, you can still see the results of the last time I ran it with the order ID just being kind of all over the place and the order not making a lot of sense. So I'm going to go ahead and run it again. And this time you'll notice everything is sorted by customer ID. So all of customer ID 1's records are first, all 129 of them. And then customer ID 2's records are coming up. And then customer ID 3's records are coming up. This is a terrible clustered index. But I wanted to show you, without any sort of order statement on my select, the data is stored in customer order. So I have essentially created a dictionary, and I have put customer ID 1 as the first 129 pages. Customer ID 2 is the next whatever it is pages. And the entire table is stored in that order. So if I need to find a customer ID, so if I need to say select all from sales order copy where customer ID equals 1, for example, and run this, that comes back fairly quickly. And if you look at the execution plan for that, you'll see it was able to do a clustered index seek. It read 129 rows and it came back right away. But again, I don't want to store my data in that order. It doesn't make a lot of sense. That is not a common way that I will access this data. So more intelligently, if I was going to do this, I would make my clustered index on order ID. Okay, so I'm going to come back over here real quick, and I'm going to go into indexes and keys, and I'm going to delete that crazy clustered index, and I'm going to hit close. And I'm going to go ahead and select the order ID column, and I'm going to click primary key. which makes the order ID column the primary key. Now that actually does a few things under the hood. So I'm going to hit save and just come over to the sales order copy table in the tree here. And if I expand the keys folder, you'll see I in fact have a key called PK orders copy. If I expand the indexes folder, you'll see I also have an index called PK orders copy. So when you create a primary key via the GUI, it also creates a clustered index. And it is the only one. Again, you only get one. So now my data is stored in the order of my primary key. So if I want to look at the details of these keys and indexes, I can go back to my table designer here, and I can go back to that keys and indexes button that we clicked earlier. And you'll see here, I have my PK orders copy. Now, it doesn't show up twice here. It just shows up once. Over here, it shows up twice because it knows it's a key and it knows it's an index. So it's just showing it in both places. But you can see here, columns, order ID, which is the only one I selected, ascending. So I didn't talk about that before. You can sort when you pick your column ascending or descending. So I could have done customer ID descending. So the biggest ones would have been first. But you'll see it is unique and it is primary key and it does not allow null. So an important differentiation between a clustered index and a primary key, it's a very small difference. A clustered index can allow null, but if it's unique, as in this case, is unique, you only get one null because everything has to be unique. But a clustered index can allow nulls. A unique index, you can have nulls, but only one. And a primary key, you cannot allow nulls because, again, this key has to be a piece of data that identifies my row. So it can't be null. It has to be unique. And then I can sort it ascending or descending. Okay. So key difference between a primary key and a clustered index is it does have to be unique and it can't allow null. But it also is your primary key, so it's treated a little bit differently. But you'll see here, this created my clustered index on my primary key, created as clustered yes. You'll see the data specification, it is on user data, which means this entire table lives on user data. So think of the clustered index, I just want to say this one more time. Think of the clustered index as your actual table. Like that whole column and all that data in that clustered index is stored together because your data has now been sorted into that order. Okay. So I'll just hit close here and I'll close this up. And once again, I'll select all from sales order copy. And you'll see now everything is sorted by order ID. This one had a few deleted out of it. So that's fine. And if I now want to select a particular order where order ID ID equals 1, 2, 3, 4, and I run that with the execution plan, you'll see now when I look in here, it actually did go ahead and it used the index, it did a seek, it found the one row, and it returned the data. So this is a proper primary key and a proper clustered index. So we have another lesson where we'll go over non-clustered indexes, and non-clustered indexes are more for speed and performance. You really have to consider your clustered index because it does define your sort order. So I could still have a dictionary that somehow has a index at the back, and I could say, hey, tell me what pages pandas are referenced in other things definitions. So maybe eucalyptus leaves say favorite food of a panda. So in the index, it might say panda is part of eucalyptus. So you can still have these two things exist together. And that's sort of the goal of SQL Server indexing. So for this lesson, we learned how to do clustered indexing and that the table is stored in the order and with the clustered index. The table is a clustered index, essentially, and you only get one of those. Tables without clustered indexes are called heaps, and the data isn't really stored in any particular fashion. So with that, you can start looking at setting up primary keys. You sort of understand how this helps you store your data and put some order to your universe. And it's starting to give you a glimpse into how it makes things a little bit faster. I can find things that are stored in a particular order way quicker than I can find a bunch of random things thrown into the bottom of a box, for example. So take this piece of information, you're going to put it together with the non-clustered index lesson, and then those two things can really allow you to start doing some performance tuning by creating indexes, by doing some query tuning, and you can really start to make your database hum. So this lesson, we're going to take a look at setting up and configuring non-clustered indexes. Now, if you've set up clustered indexes or if you've gone through that lesson, this is going to seem very similar. In a lot of ways it is, but we're also going to talk about some things you can do with non-clustered indexes to help your performance that you wouldn't necessarily do with a clustered index. So let's dive in. In my Wide World Importers database, I have a table here called Sales Orders Copy. It's just a copy of the sales orders table, just without any indexes on it. I stripped it down to bare data. One exception, I do have a primary key on this table. So we're going to run some queries against this thing and see what we can do. New query, here we go. All right, so first I'll just do a select star from it so you can see what's in there. There we go. And it's just a copy. It's missing a few rows. I've deleted some stuff out of here through some other demos I've done, but it's missing a couple of orders, but it has a primary key, and that's about it. So if I start querying on pieces of information in here that aren't in the primary key, which is pretty much everything, you're going to start to see that I'm going to do a lot of scans, and that's bad for performance. And then we're going to make some indexes to sort of make that a little bit better. So let's say I just want to look at a date range. So we're going to take a look where the order date is greater than, and let's take a look and see what we have. We have data in here from 2013, and it looks like it goes out to 2016 or so. So we'll say where it's greater than 1/1 of 2014, and where it's less than 12/31/2014. So we'll kind of take a look at that entire year. Now, before I run this query, I'm going to go to my query menu and I'm going to ask it to include the actual execution plan. You can also do that by hitting Control M. And that'll spit out the execution plan when this is done and let me know what the query optimizer did and how it was able to retrieve my data. So I'll just click Execute here. There we go. So I got that data back, 21,000 rows of data for that year. And if I click into the execution plan, you'll see it basically spent all of its time with this particular operation. And if I hover over that, you'll see that was a clustered index scan. So it basically had to scan through the whole table to find my data. You can see in this readout, about the 5th or 6th option down, it says number of rows read, 73,000, which is the entire table. So it basically read through the whole table, scanned the whole thing in order to find the records I needed where these order dates matched. So what we want to do is create a non-clustered index on that. Non-clustered meaning the data won't be resorted. It'll just stay in the order that it's getting from its clustered index. A non-clustered index in terms of concept is a lot like the index at the back of a book. So in the back of the book, I can say look up all references to order date, and it tells me what pages those are on. And these indexes are made up of just that. They're pages worth of data. So let's go ahead and create one. It's fairly simple. You can do it with script or you can do it with the GUI. Might do a little bit of both during this demo. But I'm just going to right-click on Sales Order Copy here and hit Design. Then there's a little button that has a key and like a little stack of rows here that's Manage Indexes and Keys. I'm going to click that button. And up comes my list of indexes and keys. Right now, the only one here is the primary key, which is on the orders copy table. It's actually on the order ID column, if you're curious. I'm going to go ahead and click Add, and we're going to make a new index. So by default, it wants to call it IX for index, and then the name of the table, orders copy. What I'm going to do, and it's just my best practice, it's a habit I get into, is I name the index after the table, then I add an underscore, and then I add the columns that are part of my index. So for this one, we're going to do order date. Okay. Scroll down just a little bit. Top section, actually let's cover that real fast. It now wants to know what column, so that's important. So we're going to select not order ID. I want this one on order date. Do I want to sort ascending or descending? That varies depending on what you're using the index for. If I'm regularly searching for high ranges versus low ranges, for this purpose, ascending is going to be fine, so we'll leave that alone. we're going to leave is unique to no because multiple orders can come out on the same day. If I say yes, that's sort of a constraint we're putting on the table, and things will error out if you attempt to add a date that's duplicate to one already there. Our data does not support that, so we have to say no there. And then we have a type. We are creating an index. We could also create a unique key, which essentially is forcing uniqueness in this column, or we could create column store indexes if we're using column store columns, but we're not going to do that. We're going to make an index, which is going to be standard non-clustered. Scrolling down just a little bit more, you'll see I have a description, and this right here is what makes it non-clustered. This property, create as clustered, I'm setting it to no. I'm actually forced to set it to no because you can only have one clustered index on your table. So pretty much every index is non-clustered except the one, which is your clustered index. I can specify where this index lives on this data space specification. In user data here is fine for me. If I had other files, I could store the indexes off in those files. And people often do that. It's a slight performance advantage to have your indexes in a different file group than your data, potentially then on different hard drives. Used to be a lot about different spinning disks and different platters moving around. Anymore with solid state drives, that's less of a concern, but still in big servers you have moving platters, and so you can move those around and get a little performance advantage. We're not going to do that here. Fill specification is probably one of the only other things in here that I regularly play with. And what fill factor is it's how big you're going to fill each page of your index. So a database, unlike a book, is a living piece of data. It's a living document, if you will, meaning I can remove things from a database and I can add things to a database. When I do that, the index needs to be updated to know about those things, okay? So imagine if I had a book where I had a bunch of blank pages, or I could insert more pages. And at the end of that book, I have this index that says, hey, these things are on page 58, and these things are on page 72. But then I pop a new page in at page 60, which essentially means 58 is not really affected, but page 72 just became page 73. So not only do I need to account for that new page of data that I just shoved in, the index needs to be updated to point to whatever's there. I also have to go update the index, and everything after that page needs to be updated so that it knows the new page number. These indexes work kind of the same way. These indexes are built with pages, and you can fill each page to a certain percentage. So say 90% is full, 10% is left over for additions. That's important because as soon as I start filling up my pages, I can't insert anything in the middle anymore, and I have to start tacking things on to the end. So imagine if I go to look for information on pandas, and there's one part of the index that says, hey, here's some panda information, and then I've had to tack more onto the end, and now all of a sudden I have to go to the end of the index and look again to find more data about where pandas are. So essentially I've got information in my indexes that are sort of fragmented and out of place. That's slower to search through. It's a performance hit. That said, if I set fill factor here to 0, SQL Server will manage my index for me, and it kind of picks what it thinks is the best fill factor. If you have a very specific type of data, like say it's a lookup table that's never going to change, you could set the fill factor to 100 or pretty close to 100, and once you get your indexes built, you're good because you're never going to add or remove or change the data. But if you have a table that's changing constantly, you're going to want a lower fill factor. So you can start to figure out sort of what is best for you based on some data modeling and running some tests on your systems or just your knowledge of the data. I'm going to leave it at 0 and let SQL Server manage this fill factor for us. So other than that, I'm going to leave everything else alone, and most of it's actually grayed out anyway. And so I'm going to go ahead and you'll see there's no save button here, but everything is configured, so I'm going to hit close. The save button is out here on the actual table designer. So you can see the little star next to my table name, meaning changes have been made. So I'll hit save. And when I do hit save, it takes a little extra time. So I'm not just changing the definition of the table. It just had to go right and create that index. So now if I come down on my Object Explorer and refresh this indexes folder here, you'll see I now have an index called orders copy. So let's close out our designer, go back to our query we ran before, and remember last time it ran this clustered index scan, and that's where it spent most of the time running. and the query, yes, so the query, it was 0.022 seconds of time run in there. And how long it takes is really irrelevant because it's a small table, but just sort of keep that in mind. I'm going to go ahead and click execute one more time. And it spits out my data. Still pretty fast. Again, it's a small table, so we're not going to see massive speed changes here. But now, if I look in here under order date, I still did a clustered index scan because I was still kind of going for this giant range of data. But let's just say I pick an order date. So let's say I pick an order date is equal to that. And then we say or equal to, not plus, equal to that date. And now I run this query. And you'll see slightly different things happened. Since I wasn't looking for such a large range of data, I was looking for 2 specific dates, it was able to use my index. So you'll see here, I did an index seek on my non-clustered index on order date. And it read 174 rows. So it didn't have to read 75,000 rows to find these 2 order dates. It had to read the 174 that actually matched. And you can see down here in our results, if you look in this bottom corner, it returned 174 rows. So it used the index, it found the 174 rows of data that it needed, it then did this, it's called an inner join, but essentially what it's doing here is it's going back and then looking up the key. So in order to get the data, it's kind of a multi-step process. I had to use the non-clustered index to find where the order dates matched what I wanted. Then once I had the order dates, I essentially had to go fetch the primary key, which is this key lookup here in the orders copy table, fetch the primary key so that I could use that to basically grab the entire row of data. Okay, so I had to start with my order date, then jump into my primary key, and then grab the whole set of data. So I've made a performance improvement. And again, you can't really tell based on time, but you can tell very easily based on the number of rows. I only read 174 instead of 75,000. Multiply that by tables that have hundreds of thousands or millions of rows. So that is how a non-clustered index works. Now, if I start expanding my query, you're going to find very quickly that indexes need to potentially exist on multiple columns. And again, it all depends on how you're going to query the data and what you typically do. So if I start adding other things in here and I say, and the contact person ID equals, we'll just pick one here. I can see 1145, or the contact person equals, we'll pick another one, 1055. And do one more here. We'll say is, I thought there was an is, no, last edited by, is under supply backordered. So I think most of these have a 1, so I don't want to use that. That's not very interesting. Backorder ID, we'll do that. And backorder ID is not null. Now, I can't guarantee we're going to find anything with these particular specifications, but let's see what happens. I'm going to execute this query. And we did. So these are the 16 rows where the order date was, here it is, 124, and the person is this. Then I did, or the contact person is this. So the way I wrote this query, you're actually finding things that are slightly different. So you'll notice contact person, 1145. Or 1055. You'll notice I'm getting things in order date that aren't on 1/1/24, and that's because when you and or and stuff all this together, I have an or condition that says where the order date is this, or contact person 1055. So that basically overrode, and I got values that were all from that particular contact person. Okay. So I didn't quite get the narrowed down sort of look that we wanted. To fix that, let's actually pick an order date that does exist in here. So no, 1/1/2014 does. That's good. So what we'll do is we'll say the order date is this, and we're going to put some parentheses around this and say the contact person is that or that. And backorder ID not null. Now, because I put this into parentheses, the only thing that evaluates the OR is inside this parentheses. It's still ANDed with everything else. So now it could only return if the order date is this, and it's one of these two, and backorder ID is not null. So if I run that, I get no rows because they're just not enough. I did not pick a very specific, I picked a very specific query, but it didn't match anything. So we're going to go ahead and just pop these parentheses off so that it can OR it and get us whatever that was, our 15 or so rows, 16 rows. But I want to look at what the execution plan did now. So from here, you can see that even though I have an index on order date, it didn't use that index. It went back and did a clustered index scan. And that's because I just threw too much else at it. And so I also asked for contact person. I also asked for backorder date. And it decided that rather than use the index to find the order date and then scan for contact person and backorder ID, it was going to have to scan anyway. So it went ahead and did the scan. So we're back to reading all of our rows. So we could start creating other indexes, some on contact person ID, some on backorder ID. And if you're going to use these regularly, it's probably a good thing to do. But another thing we can do, it's called creating a covering index. And a covering index means I'm going to create a very specific index that contains all the columns that I regularly use in a specific query, okay? So if I'm often going to run this query where I'm querying on order date, contact person, and backorder ID, I can put all those together in one index, and that one index can serve this one query. Now, I'm not suggesting you should always create covering indexes, but there are going to be times where you regularly query groups of columns at the same time, and those are cases where a non-clustered index containing all those columns can be very helpful. So we're going to do that real quick. I'm just going to go back to our table design and open up our indexes and keys, and we'll make another index. And for this one, I'll call it orders copy. And I'm just going to put covering for now because I don't want to type out all the column names. So when we pick our columns, you'll notice this ellipses allows us to not just select one. Last time we just selected order date. This time we want to get order date. And if I click just below that, I can pick another column. So then I'll take contact person ID. And last but not least, I'll take backorder ID. And I'll sort them all ascending. That's fine for now. I'll click OK. Again, non-unique, and you'll see down here we are creating as clustered. No, so it's a non-clustered index. Close that, hit save, and we'll flip back over to our query and we'll run this again. Shut out the same 16 rows, but again, you'll see now, because of the way we built that index, it was able to scan that particular index. You can see at the bottom there which indexes it used, and under object, it's kind of small, but you can see it says orders copy underscore covering. So there, I did still read 73,000 rows because it still scanned this index. But then it returned the 16, and then it was able to do a lookup over here on the primary key. So I still did scan because this is kind of a crazy set of data. But I was able to force it to use this particular index, okay? Now, how and why you create all these indexes, we've talked a little bit about it, but I don't necessarily want to spend a lot of time about talking through index design and index design considerations because that could go on for days. So this is more rubber meets the road, how do you create these things? But designing them is sort of going to be on you. Now, one thing I do want to show you, if I'm regularly getting certain bits of data with my query, so right now I'm selecting all. I don't have to do that. I could select just say the order ID, the order date, and what else is in here. Let's flip back to our results. And maybe I regularly am grabbing the expected delivery date. That's fine. We'll get that one. Okay. Now, I still have to go and fetch all this information. The order ID from the primary key, basically, I have to go get the expected delivery date, and I say where the sales order date equals that, so we can come back down to just the order date again. And I'll execute this, and you'll see, yep, no problem. I did an index seek. I found what I was looking for. I went and did the key lookup. I got the other things. All right. What if I just want order date and expected delivery date? Same thing. Same query plan. Now you can do what's called included columns. And so on our order date query, we also are pulling expected delivery date. So because I'm often querying order date and expected delivery date together, but I'm not necessarily filtering on expected delivery date, I'm just selecting it as part of my query, I can do a little something to help the performance of this query. So what I'm going to do is come over under my indexes folder and find my orders copy order date index, and I'm just going to double click it. And this brings up an editor where I can edit the index directly. So a little different look than from inside the table designer, but I kind of wanted you to see this. And all the same options are here. They're broken up into pages rather than just one big dialogue. So it's a little easier to move around. But what I want to show you here is a thing called included columns. So I'm going to click on that. I'm going to click add. And as part of this index, I want to include expected delivery date. Okay, so I'm going to check that. And I'm going to hit OK. What that's going to do is it's going to store expected delivery date kind of in the index alongside order date. So theoretically, once I find the order date data I'm looking for, it should be able to grab expected delivery date right out of this index and not necessarily have to go back to the primary key and go back to the table to find what I need. So I'm just going to hit OK. And it says to apply the changes, this index will be recreated, and that's fine. So it basically tears down and recreates the index. So we'll hit OK there. Takes it a second. Bigger tables, that can take a while. So keep that in mind as you're creating indexes. It does have to go through the table and figure out where everything is. So it does take some time to create these. So when you're initially creating them or when you're doing index maintenance, make sure you have the time in order to do it on bigger tables. So now that that's done, let's rerun our query. And there it goes. I got my order date and I got my expected delivery date right there in one big list, 97 rows for the 1/1/2014 date. And if I look at the execution plan here, you'll see all I did was an index seek of 97 rows. I did not, as you saw with the other queries, have to then go back, jump through the primary key, and then grab the rest of the data. I just did one index seek because it was able to get the order date and the expected delivery date all from that one place. Now, if I were to add something else to this, like customer ID, and run it, now we'll go back to where I had to do the seek, and I still then had to do the join and go back out and do my key lookup. Okay, so if, again, you have a very specific need to store certain columns alongside your indexed columns, included columns can allow you to do that. Okay, so again, this was just a quick look at what non-clustered indexes are and sort of a walkthrough of how to create them and a couple little extra features like included columns. But index design and index maintenance is a huge part of doing database administration and database design. And what indexes you create are going to vary widely depending on how the data in your database is set up. And one word of caution I will give you is you can over-index a database. So if I don't have any indexes, I'm constantly looking things up in an entire table. But if I have too many indexes, you've sort of created the opposite problem with the query optimizer is constantly trying to figure out which index to use, and it's looking things up in all these indexes, and you can actually start to slow things down if you over-index. So don't just start throwing indexes at every one of your columns. There's the database tuning advisor, which you can use to trap workloads, and it can give you some recommendations. If you know your data and you know your queries, you can do a pretty good job of making your own index design. But just remember, with indexes, a little goes a long way and too many can be detrimental. So hopefully this has given you enough information on how to use non-clustered indexes, and you can start incorporating this into your design. So in this lesson, we want to take a look at index statistics. Now, indexes, clustered and non-clustered indexes, are used to help improve the performance of your queries in your SQL servers. With statistics, that's information that the index tracks about your tables to help it make decisions about which indexes to use and how to go about getting your data. Now, in general, these are updated automatically and you don't have to worry about them too much, but sometimes they get out of whack and you need to know what they are, how to look at them, and how to rebuild them if need be. So let's take a look at just that. So here I've got just some sample code, and we're going to walk through what all this does. So before we get started, I want to turn off updating statistics for this particular index so that we can kind of mess around with the statistics on our own. So to do that, I'm going to expand the database. I'm going to go down to the orders copy table, which is the table this is in, and we will expand the indexes folder down here, and you'll see our orders copy order date index right here. So I'm just going to double click this, and if I click on the options page, you'll see at the top auto recompute statistics is set to true. This is the default when you create an index. That's why it's true. I'm just going to go ahead and turn this to false. So now my statistics will not be auto recomputed, and we can see what happens when they get kind of out of date. So I'll click OK. All right. Now, if I go up here and I run this select statement, when this runs, you'll see I'm basically doing a clustered index scan, and I'm using the primary key in order to do that scan. And that's perfectly okay. And a lot of what you're seeing here on some of these estimations and some of these numbers, like estimated number of rows to be read was 73,000. And if you look, the actual number of rows read was 73,000. A lot of this information and a lot of the way that this computes and figures out how many rows you have and what index I'm going to use is from looking at the statistics of the index. So it uses that sort of high-level data to see what is in your table, okay? And you can use, I'm going to kind of jump around in this code here, but I'll highlight what I'm running. You can use this dbcc command called show statistics to look at a particular index. Now, in this case, this actually is called ix underscore orders copy underscore order date, so that's in there correctly. And if I run this, and I'm going to leave these two parameters commented out here. I'm just going to run this with stat header. So I'm going to highlight just this piece here and run it. This will show you what it knows about that table and what statistics it's tracking. So here you can see the statistics when they were updated, how many rows sampled, steps is sort of how many chunks of data, your data density, so on and so forth, okay? And this is all about that order date index on the order date column. So you can see I have some information. You don't need to use this information, but the query optimizer does. So because I don't have statistics on, you can see what happens when I start to mess around with this table. So just to grab it, show you, I'm going to select count. It's 73,500, and I'll just put this in here as a commented piece of code, 73,591 rows. This is current. What I'm going to do is I'm going to run this insert statement. This insert statement is going to insert into sales.ordersCopy, select all from sales.ordersCopy. So basically what I'm going to do is I'm going to select the entire table and insert all that data into itself again, effectively doubling the rows. So I'll run this little statement here. And it does say that that's a violation of my primary key because I can't have two of the same primary key. So for this demo, to get around that, what I'm going to do is I'm going to delete my order copies primary key. So we will right click, we will delete. It asks, are you sure? I say yes. And there it goes. Now there's no more primary key. There's just an index, and I can refresh this to show you. There's just an index on order date. And I have a covering index as well, but these are the only indexes left. Primary key is gone. Bye-bye. So back to our select. Let's do this again, and we'll duplicate all the data. And it took it a second, but you'll see 73,501 rows affected. So it actually did copy the entirety of the table. So if I run a count again, after the fact, I now have 147,182 rows. Okay? If I go back and look at my statistics, and again, this is the information it's using when it's trying to figure out how to query, and I hit F5, you'll see it thinks there's still 73,591 rows. So that's the information it's going to use to attempt to make its decision on what to do with my query and how to optimize it. So if I come back up here and I run this and I hit execute, and I look at the execution plan, now I'm doing a table scan because now I don't have the primary key anymore. And that's fine. It didn't have much of a decision to make because the primary key is gone, but it needed the statistics to make this decision. And obviously with this kind of table and this kind of data set, there wasn't much of a decision to make. But as things get larger and as you have bigger result sets, you can see how having this information is going to be important to the query optimizer. So if I had auto update statistics turned on, periodically it updates those things and it typically takes care of it. But occasionally, and I've seen this in servers with very large databases, we'll run update statistics throughout the day, or we'll have jobs that are standing by that we can run it, because you'll just get some weird behavior and it's just not updating statistics enough, or it's not updating them. It's just not updating them fast enough. And so your query starts to slow down. So we would just run update stats occasionally to help fix some performance problems. So to that end, let's do that now. If I scroll down here, you'll see I have an update statistics command. And all I'm going to do is call this command and say update statistics for sales.orders copy. So update the stats on the indexes in that table. And I'll just execute that. And it goes off. This one went relatively quickly. Depending on the size of your data and the size of your indexes, this can take a little bit of time. And now, if I come back up here and run my dbcc show statistics command, you will see it now knows how many rows are in the table. So it has gone through and it has figured out again how many rows are in the table. Okay. The other piece of information you can get from statistics, these other two little bits of information that I left commented out, density vector and histogram, this can be informative for you if you want to kind of see how your data is broken up. So let me just run that. The header is what's at the top. That's the same. This is the density vector. So it tells you, how dense your data is, what's the average length of data. It's all date time data. So it's just dates. So average length 3, which I think that's what they all are. And if you come down here, you can start to see data range rows. So it shows you the key, how many rows are in that range. Okay. So this first one basically says the high key is 1/1/2013. So that defines a row. There's nothing in that range. So 0 rows there. Yep. And then you can kind of see the average range here, 1. But then you can see this guy, the high, again, this is the high key, 1/7. That has a certain number of rows and how many distinct ranges. And so essentially what this is saying is between 1/2, starting on January 2nd, going up to 1/7, here's the data about that range. And I have 4 distinct range rows. So I basically, within that range, have 4 distinct dates. So I probably have a 2nd, 3rd, 4th, 5th, and I guess I don't have a 6th or a 7th, or some combination thereof. So this can kind of start to show you a breakdown of how the data in your table literally exists. And for each of these chunks, it kind of breaks these down into these different ranges. And that's partly how the index optimizer makes decisions. It figures out if you're trying to grab a range of data, if you get too large of a range, so if I were to select an entire year's worth, as it gets big enough, it starts to say, okay, do I need to just fetch everything? Can I grab chunks? What can I do? And that helps the index optimizer look at your data. And it can be informative to you as you're designing indexes, okay? So that's pretty much all there is to it. The statistics are updated and maintained on each of your indexes. They will sort of auto compute and auto rebuild if you let them, but occasionally you might run into issues. And using dbcc show statistics, you can get some great value and great information about what's going on with your indexes and your stats and your data. And if need be, you can use update statistics to go ahead and update those statistics a little more frequently to keep your query analyzer running and keep your queries as efficient as possible. Welcome to our lesson on implementing SQL Server high availability and disaster recovery. If the unthinkable happens and you run into a major disaster, or even if you have a simple power outage, how do you keep your data available to your users? Having backups are important, but they take time to recover and downtime could mean lost revenue. This is where high availability solutions come into play. They help keep your data available even if you lose a system or an entire data center. This lesson covers a review of high availability and disaster recovery technologies, how to set up SQL Server log shipping, and using replication for high availability. We'll also look at how to read secondary database copies. Let's get started. So when it comes to high availability and disaster recovery, SQL Server offers a handful of options to help keep your servers up and running. Now, in this instance, when we say disaster recovery, we're not referring to a database that crashed that we need to recover. What we're talking about is an actual disaster. So a building catches fire, or a hurricane knocks something down, and you have to keep your servers running despite that problem. And so typically large corporations will set up high availability servers where they'll have two servers at different locations that can fail over. So if a hurricane burns down my data center, or a fire burns down your data center, more likely, then you can fail over to another data center where you have another server that has the same information and data available that people can use. Okay. You can also do disaster recovery and high availability solutions in the same building and sometimes even in the same server rack. What you're protecting against there is a failure of a server. So I have two physical servers serving up data, and if one crashes, the second one can come online and continue serving the data. So we're talking about a recovery that is quicker than restoring a database, something where it is as close to seamless as it can be to the user. So as far as they're concerned, nothing happened. So we have several lessons that we're going to take a look at some disaster recovery options in SQL. And in this one, we're going to sort of talk through what's available so you know the entire suite of products that you could use to set up some of these solutions. So I'm just going to kind of talk through these, and I've got two SQL servers here. One's called SQL Inside Out, and one's called SQL Inside Out 2. And we're going to, in a couple of these lessons, set up some high availability solutions between these two. We're going to look at using SQL Server replication as a high availability tool, not necessarily its primary purpose. Replication is all about sending data from one server to another in some fashion. Sometimes it's a subset of data, sometimes it's whole databases, procedures, views, tables, the whole nine yards. And it's about getting data from point A to point B. So we'll look at how to use that for high availability. There's also a feature in SQL Server, and you can see the configuration for that if you were to look at the properties of a database, called database mirroring. And that's basically a configuration where I can mirror a database from one server to another server, okay? And it keeps those two databases in sync. And then if I need to, I can fail over. And because they're mirrored, they're pretty close to the same thing. The other thing that you can use is something called transaction log shipping. And there's a lesson on this where we can set up transaction log shipping from server A to server B. And this essentially utilizes the backup and restore technology that's native to SQL Server. So transaction logs are something that databases use, and they're something that you back up in order to store your data in backups. And we can use them in this kind of funny method where we back up one server and restore it to another over and over and over again. And that's called transaction log shipping. So there's a lesson, we'll dig into that as well. So something else that we could set up for high availability is called always-on high availability groups. Now, this requires different licensing and different SQL servers, so we're not going to dig into that. It's a slightly more advanced topic, but how always-on high availability groups are another way you can set up high availability in SQL Server. It's right in the name. And then beyond that, outside of the scope of necessarily SQL by itself, you can start to do clusters. So you can set up SQL on Windows clusters, which is that example I kind of talked about a little earlier. Two servers, shared storage, one server breaks, the other server takes over, and you have this sort of seamless transition. So you're using Windows clusters, and there's a whole bunch of ways you can configure that. You can have active passive nodes, active where they're both running something and they could each fail over to each other. The options go on, but both of those are more advanced setups. So when it comes to high availability, those are the technologies that are your options, and at least a few of those we're going to touch on in some other lessons. In this lesson, we're going to go ahead and configure SQL Server log shipping. Now, this is something that people have been doing in SQL Server back many versions before it was an official feature, because all we're really doing here is backing up a database from one server and restoring it to another. So when you restore a database, you can leave it in that recovering state so I can continue to apply additional transaction log backups to it and continue to bring it up to date. So all we're doing with log shipping is we're leaving a database on a secondary server in that restoring state, and it's just going to continually get the next transaction log backup from the primary server. So we take a transaction log backup, we ship it over here, and we restore it to that database. Hence, transaction log shipping. So in a version of SQL Server years back, they decided to make this a feature and help you automate it rather than having to have your admin go in and create all the jobs to do all the work and move all the stuff around. So now it's a baked in feature, and we're going to set it up right now. So I have two servers here, SQL Inside Out and SQL Inside Out 2. On SQL Inside Out, I have a couple databases. The Wide World Importers database is the sample database we're going to work with. And over here, I actually do have that database already in place. So for the purposes of this lesson, I am going to go ahead and delete this database just so that it does not exist on our secondary server. So we'll delete the backup and restore history. I'll close any existing connections just so I don't get blocked. I'll hit OK. That database goes away. So now I have a primary server with our, let's call it production database, and we're going to log ship that to our secondary server so that we can have a backup. So to get started, you look at the database properties, and there's a transaction log shipping page. And when I first come here, everything's grayed out until I check this box at the top, which is enable this as a primary database in a log shipping configuration, which is what we want to do. So I'm going to check that. Step one is we have to configure the backup schedule. So if we click on here, you can see it kind of has a default. It needs a few things. It needs a network path to store files on. So both servers need to have access to this path, okay? It doesn't actually have to be a network path. It just needs to be a path that both servers have access to. So in my Inside Out folder here, I'm going to make a new folder called log shipping, okay? And this will be where we store this data. And just for completeness, because you'll see here, it wants to know what the network path is, and if it is on the primary server, what the path to that is as well. So what I'm going to do, just to make this all fine and look like a real setup, I'm going to share this folder. So I'll share this. I'll add administrators as owner. Oh, they already have it, and that's fine. We'll share this out. And now I have a share on my local machine, ericjwork/log shipping. So if I attempt to get there via UNC path, I can go to ericjwork, and then I have log shipping. So there's my network share. So we'll just copy this path here, and we'll put that in for the network share. So both machines have access to that, and since both instances are on my machine, it should not be a problem at all because they have access to the actual folder too. Because it's on the primary server, it asks for the local path, so I'll give it that. There we go. See, Inside Out log shipping. I'll just copy that as well, and I'll paste that here. Okay, so that's step one. We've given it the location where it's going to put these files so they can be shared. Step two, how long do I want to keep files? So this is sort of your first gate. I'm going to keep files for 72 hours. It'll delete them every 72 hours. What that means is if your secondary server were to go offline, it has 72 hours to get back online and still catch up because there will still be 72 hours of files. You can make this longer, you can make this shorter. They start with 72. In a true high availability failover setup, I shouldn't be offline for more than a couple hours. Otherwise, we have a problem because we're not going to be in sync. You'll also see that you can set up an alert, and in this case, it'll alert you if there's no backup within an hour. So you want to know if your log shipping isn't working, and this is the first step of knowing that you haven't had a backup in over an hour, so please tell me about that. Now down here, you'll see it's going to create a backup job. So this is very much the way you would have configured this back in the day. You would have created these jobs on your primary and secondary servers to make backups, copy files, and restore backups. So it's going to do just that. It recommends a job name of ls backup _ wide world importers, which is fine. And you'll see here it will occur every 15 minutes between 12 a.m. and midnight. So essentially every 15 minutes all day. If you want to change that, backup more frequently, less frequently, whatever, you can click this schedule button here and you can modify that schedule. I'm perfectly happy with it being every 15 minutes. For backup compression, just like when taking a backup, you can choose to compress or not, or use the server default. We'll go ahead and use the server default. Okay, now that is ready to roll. So I will hit OK. And you'll notice now that I've set up my backup settings, the rest of this dialog box has become available. So now I can set up my secondaries. And I did say secondaries. You can have more than one instance or server. So this isn't just a primary to secondary solution. This is a primary to possibly multiple secondary solutions. So for this case, we're just going to hit add, and we have to initialize the secondary database. So you'll see this is all grayed out. This sort of like forces me to do things in the right order. Step 1 is hit connect and find your secondary server. In our case, this is correct. It's the inside out 2 instance. So I'll hit connect. It wants to know the name of the secondary database. So you can see here, I can pick a database that already exists on that server, like HR, as you can see over here on the left. That server has that database. So I don't have to ship from the same database name to the same database name on the other side. It can change. In this case, I want to have it be the same because in the event of a failover, I want my clients just to swing over to the other server and not have to worry about changing their database name. So we'll keep it as wide world importers. Then you have some initialization options. You'll notice this is called transaction log shipping. We still have to get the initial data over to the secondary server. So we can do that with a full backup. We could do that manually. I could copy the files and I could attach them. I could use SSIS. I could do whatever I want. But I have to get that other database over there initialized and in a proper state to accept transaction log backups. So you'll see I have a few options. It's asking me here, do I want Management Studio to restore the backup to the secondary? And I can say yes, or I can say no. The first yes is it'll generate a full backup of the primary and restore it to the secondary. That will create the secondary database if it isn't already there. And then you can see I can click Restore Options, and I can tell it where the folders and stuff are on that side, if I have to, okay? If you leave it blank, they use the defaults. The other option for yes is I can restore an existing backup. So I don't have to have you take one. I could say, you know what, give me an existing backup, and you apply that, because I don't want you to take one right now. And if I had one lying around, I could do that. Your last option is, no, I don't need you to do this right now. The secondary database is already set. Well, that's a big lie, so we're not going to do no. We're going to go back to number 1 and say, please generate a backup and restore it for me. Now, I still can't say OK. So let's move on to the next tab, Copy Files. This is the destination folder where the files are copied to. Folder is usually located on the secondary server, okay, and that is true. But again, we are on the same server. So what I'm going to do is in here, in my log shipping folder, I'm going to make another new folder called just copy. That's fine. And this is where we're going to copy the files to. Now, it's a little redundant on the same machine because I have the files already saved from the backup. But in a real world environment across multiple machines, I'm going to take the backup, I'm going to get it copied over to the secondary server, and then I'm going to restore it. So the secondary server needs to know where to copy the files to. So we're going to go ahead and give it its own little folder. Again, how often does it delete the files? Every 72 hours is the recommended time. And you'll see this is going to create another job in this particular case that's called ls copy. And that ls copy job is going to be the thing that every 15 minutes is going to try to copy files from server A to server B. Finally, the last step in the shipping is the restore transaction log. That's the last piece you have to do. And you'll notice I have a couple different options. For database state, I can leave it in no recovery mode. No recovery mode means that the database stays in that recovering state as though I'm restoring backups, because that's what I'm doing. So it'll restore the full, the database is in recovery mode. It restores a log, still in recovery mode. That basically means the database is sitting there useless until I bring it online, okay? Or I can select standby mode. And we will talk about that. We have a whole lesson on how to connect to a secondary database in a high availability solution. And standby mode is how you do that. And we'll talk about that later on. So you can check that lesson out. For now, we're going to say no recovery mode. So it'll just basically stay in this restoring state. You can see delay restoring backups. So I can put a delay in, which means it won't restore backups for a certain amount of time. The default is 0 minutes, and that's fine. And now you can see another alert point, which is one of the things that helps keep me on track with my log shipping setup. It'll alert me if no restore occurs within 45 minutes. So remember earlier we saw alert me if no backup happens in an hour, and here it'll alert me if no restore happens in 45 minutes. Now, assuming you're using all the defaults, which is basically every 15 minutes you're trying to move these parts, then 45 minutes is essentially 3 windows worth of missing backups and restores. So again, we have the restore job name, which will also occur every 15 minutes between noon and midnight. Now, you'll notice that the backup job we configured, the copy job we configured, and the restore job we configured each occur every 15 minutes between midnight and midnight, essentially 12 a.m. to midnight the next day, which means, let's just pick a time. At 1 a.m., a backoff is going to kick off. It won't be done instantly. So at 1:15, a backoff will kick off again, but also now the copy job will run, which will get the backup from 1 a.m. And then at 1:30, all those things are going to happen again. I'm going to do another backup. I'm going to copy the 1:15 file, and I'm going to restore the 1 a.m. file. So it essentially, there's about a 30-minute cycle from when the backup occurs, 15 minutes for it to copy, 15 minutes for it to restore. So that's why the alert is 45 minutes. So 45 minutes isn't really, I've missed 3. It's you sort of missed 1. But as the day starts progressing, you would expect that the first backup is created at midnight. Nothing's there other than that. And this is the first time you set up log shipping. Then at 12:15, I have a file to copy and another one to back up. And then at 12:30, I have 1 to restore, 1 to copy, 1 to back up. So now, once I'm in the cycle, I'll have a restore every 15 minutes, but it'll be delayed, in this case, by about 30 minutes from the primary server. So just keep that in mind, and you can tweak these numbers in little ways, and you can do things to make it a little quicker if you need to, but we're going to accept these defaults, and we're going to be just perfectly happy with it. Okay, so everything is configured. I'm going to click OK to this, and that configures this secondary. Now, the last thing you can do, and we're not going to, but I'll talk about this, you can use a monitor server. And essentially, you point to an instance, and you can see here if I bring up the settings, I can set up a monitor. And this monitor server has to impersonate accounts, and it has access to your servers. And you can see it's this LS alert inside out job. So the LS alert job on your log shipping monitor server can watch your primaries and watch your secondaries. And if it sees any issues or jobs that are failing or things it doesn't like, it can alert you. So in a production environment, it might be a good idea to set up a log shipping monitor. We're not going to do it here because we don't really need this to run unattended for very long. So I'll uncheck that. Just like everything in SQL, I can script this out if I want, or I can hit OK and let this thing go. So we're going to hit OK, and it's going to go off, and it's going to have a problem. So let's see what happened. You'll see that it failed in backing up the primary worldwide importers database. So if we click this message, the backup failed because it cannot open the backup device, see inside out log shipping. This is because I didn't back up to my quote unquote normal backup location. I put it onto a folder on my C drive, a folder that the SQL Server agent service does not have access to. Okay, so your SQL agent service has to have access to these things. If you're not running it as a actual account, you have to just go ahead and grant permissions to the service accounts that are created. So we're going to do that. I'll hit OK here. I will close this, which will blow away my log shipping, and we will reconfigure that here in a second. But what we're going to do is we're going to give access to these folders. So to find out what service I'm running these things under, we can open up the SQL Configuration Manager. So you go to Start, Microsoft SQL Server 2022, SQL Server Configuration Manager. So if you click SQL Server Services, you can see all my services and what they're running as. Now, in a production environment on a domain, I probably have these accounts logging in with domain accounts that I can then provide access to servers, to folders, to shares, to whatever. For the purposes of this demo, what we're going to do is we're just going to change how this service runs. So I'm going to go to my SQL Inside Out service, and I'm going to run it as a built-in account, and I'm going to run it as a local system. And I'll hit apply. That's going to cause the service to be restarted. I'll say yes. And I'm essentially going to repeat that for SQL Inside Out, my agent, and my SQL Inside Out 2, and my SQL Inside Out 2 agent. So as you can see, I now have all those services running as local system. Local system is basically a built-in account that will run as the local system, and it should have access to almost everything on your local machine. So I will restart these agents because you can see my services running, but my agents are not. So I will fire those up, start that one, and I also have this guy. We'll start that one. Okay, so now my services and agents are all running as local system. So we can go back in and we can reconfigure log shipping and get this thing going. So I'll right-click my Worldwide Importers database and go back in. And let me just enable this the exact same way we did before. All right, so I just basically went back through here real quick, and I reconfigured this with all the same settings we did the first time we walked through. So now, as a good practice, I'm actually going to script this to a new query window, just so I have that. So I have all my settings. That way, if something does happen, you don't have to go and reconfigure this entire dialog, because obviously, as you saw, there was no way to just get this back. Once I clicked OK, that ship had kind of sailed. So we'll click OK, and this time, you'll see it goes through the motions. I have access to what I have access to, and the first thing it did was back up the primary database. Then it restored that backup to the secondary, and then it saved the secondary configuration and saved the primary backup setup. So a couple things you'll notice right off the bat. I'm going to close this. You'll notice over here, I now have a Worldwide Importers database running on my secondary machine. So we have successfully initialized log shipping. I have Worldwide Importers on server A, and I have one here waiting for logs on server B. Now I'll show you the component parts, but in general, this is now done, and log shipping will work, and we'll constantly have this backup available on the secondary server. But let's look at all the jobs that got set up. So on our primary server, SQL Server Agent, which is where all the jobs live, should have a job in here that is called LS Backup. This is one that's scheduled to run every 15 minutes, and this will back up logs from this primary to the primary server. So we'll look at that, we'll double click it, and we'll just go to the steps. And here you can just see log shipping backup, log job step. Like, it's not the best named thing in the whole wide world, but if I edit it, you'll see what it's doing is it's actually calling out to this ship log executable. So I said people used to do this back in the day before log shipping was real, and they did, but they would just do backup log to a specific folder. They've actually wrapped some of this up into an executable, but this particular job step goes ahead and ships the log, and it does the backup, and it says, here's the server, here's the database. So that's what creates the log file backup, okay? So I'll run that. So I'll go ahead and just start this job. You pick start job at step, and then if it only has one step, the job just fires right up. And you'll see there it went. It backed up my database. Done. It made a transaction log backup. So if we go look in one of those folders we created out here, in our log shipping folder, here's the full backup, and here's that T-log backup I just created. So that backup has been made on the primary server. Step 2, that backup has to get copied over to the secondary server. That is done on the secondary server. So we'll come down, just minimize a few of these things so we're not taking up so much space. We'll come down to our secondary server. We'll go to SQL Agent. We'll look at the jobs. And here you'll see the ls copy job. So I'll right click and I'll start that job. And that is going to copy the files from the primary to the secondary. That's what it uses the network share for. Okay, so that's now done. And if you'll remember from the setup, we said that the secondary gets to store its files in this copy subfolder. So this file should have been copied to this file. There it is. So every 15 minutes, it's going to grab all those transaction logs and bring them over. So that step has happened. Now again, we're on the same server, so we're duplicating files to some extent. But essentially what happened is, just so we get the flow right, the primary saved to this local path, C inside out log shipping. That's why this is here. The secondary then used the network share log shipping to copy that over to what it has as a local path of C inside out log shipping copy. Okay, so now it's here. It has not yet been restored to the database. And in 15 minutes from now, or whenever the last time this job ran, it will do that. And it will run this job, ls restore. So I can go ahead and start that job. And off it goes. And we're done. It restored that log to this database. So this database, I can't really show you, I didn't change anything, but this database now has everything that's changed in this database, not just since the full backup, but even since then. So if this database would have had changes prior to that T-log shipping, it would have those here. Now, let's assume the worst happens and something fails, okay? We'll do something real quick just to sort of show you how this works. Let me select star from my sales orders. So we'll go back into our wide world importers table, and we'll select all from sales orders copy, which is the table that I have been messing with because it's a copy of the sales table. And let's delete something. Delete from sales.orders copy where, so we're going to delete a few things, where order ID is less than 10. Go. 9 rows affected. And if you look from my select, I now no longer have orders 1 through 9. Okay? Blown away. So we'll go through real quick and just force log shipping to happen one more time. We'll run the backup. We'll come down to our secondary. We'll run the copy. And finally, we'll run the restore. There we go. So these two databases should, again, be in sync. Now, what I'll do is we'll pretend this database up here has gone away, okay? And I now need to bring this guy back online. So what we do is we start up a new query on this side. And before I even type it, I'm going to make sure I have this syntax right. So we have our query. You'll notice when it connected, it switched my context to master. That's because this database is still in restoring state. But I just need to bring it online. So this is like we've restored all of our T-log backups, and I just need to bring the database up. So to do that, you use the restore database command. So we just type restore database, then the database name, which I'll just grab from here. Doesn't matter which one I use. It just sort of helps me fill it in without having to type it. So restore database, worldwide importers, and we have to use a parameter. So it's going to be with recovery. So you'll notice I'm not specifying the rest of the restore command. I'm not giving it files or types or anything like that. I'm just doing the last piece of this, which is restore the database with recovery. And I'll hit execute. And it takes a second because it's got to finish up and kind of process the database. But you'll notice it now says database restored successfully down here. If I refresh over here, my database is now online. And if I go back to the same query window, I'll just delete that statement and we'll switch this now to the wide world importers. The database is online and accessible. And if I select all from sales.orders copy, you'll notice it doesn't have orders 1 through 9. So those two databases were completely in sync and everything is hunky-dory, except for the fact that I've now broken log shipping. So there's that. So essentially, once I've failed over, there's other manual steps you would have to go do at this point. You would have to point clients to the secondary server, and there's some magical things you can kind of do with connection strings to do that. You could just tell people, hey, their backup server's online. Whatever you want to do, that's kind of out of the scope of this. We wanted to look at log shipping. But I did, in fact, break log shipping because now these two databases are, while they are in sync, log shipping will now no longer function because it cannot restore to this database. So in about 15 minutes, I'm going to start getting a ton of alerts saying, couldn't restore your database because you can't restore on top of a database that's been brought online. So that will have to get cleaned up if you want to keep your log shipping going. You kind of have to reconfigure the secondary, resync everything, and get things moving again. But from this, you should see how not terribly difficult, how easy it was to sort of set up log shipping to where now I have a primary server that is constantly staying in sync with the secondary. And in the event of a catastrophe that takes down server A, I don't have to go and restore a bunch of databases like we would have if all I had was backup and restore. I simply ran the restore database with recovery. It came online, and now we're able to keep running and keep functioning. So this is one of the many ways that you can set up high availability disaster recovery using SQL Server. For years, SQL Server has offered a technology called replication. And some people love it, and some people hate it, and some people think it's not a good high availability tool, and other people use it as their exclusive high availability tool. I'm not necessarily here to offer my opinion on what I feel works well with replication and what doesn't, but what I do want to show you is how it could be used as a high availability tool. And then whether or not that fits your environment is entirely up to you. So I'm not saying, yes, this is the best, but I am saying this is one of the options and people use it, so you should be familiar with how this works. Now, replication in SQL Server goes back to magazine days, and it has a lot of that nomenclature. So it talks about publications and subscriptions and things like that. And there are a couple flavors of replication. There's merge, where you can have two sources that each merge data back and forth, so you keep two copies in sync and you're pushing things two directions. And there's like a one-time, like snapshot replication, where it's push the whole database at once or push sections of the database at once. And then there's transactional replication, which is push transactions from one server to the other as they occur. So essentially those transactions occur on both sides, database A and database B. Now that's the one we're going to use in this high availability setup. And let's just take a look at it. There's a couple moving parts, so I'll kind of talk through them here real quick. So first of all, in order to use replication, you had to install it as one of the database features. So if you don't have this replication folder, you'll need to go back into the SQL Server setup, and you'll have to check SQL replication underneath database services. So I did that for both these instances, so I have SQL replication installed. You'll notice under my local publications folder, I don't have any. So that's where you want to start. So again, think magazines. For those of you that are younger, those were the little foldable paper books that we don't really get anymore. They're still out there a little bit, but they were published by companies, they still are, and you subscribe to them and they send them to your house every week or every month. That's the nomenclature we're going to use here. So the publication is the first piece, the data that you want to share. So we're just going to right click on this publication folder here, and I can pick Launch Replication Monitor, Configure Distribution, Reports, New Publication. There's a setup that has to go in to replication, but they've done a pretty good job of knowing what you need and sort of forcing you down the right path. So we'll see if this works as expected. So we'll say new publication. So the new publication wizard pops up in my face. It tells me that this is the wizard and this is what it's going to do. If you don't want to see this again, you can check that box and skip this page forever. I'll do that because we don't need to see this every time we bring up this wizard. I'll click next. So the first thing, you'll notice it pops up and it says distributor. I don't know what that is, but we have to set it up. No, I do know what it is. But this pops up in your face and you're like, well, I was trying to make a publication. I don't get it. This is the first step of things that need to be set up so that this works. So again, in talking about the magazine nomenclature, the publisher creates the content, prints the magazine, gives it to the distributors who either send it to stores or send it to you. Same thing here. The publisher has the data you want. The distributor helps facilitate getting that data out to your people, in this case, your subscribers, which are other SQL servers. So we have to set up the distributor. First time we set up a publication, this has to be done. In the future, you skip right into the publication. So you'll see here, it's basically saying it's the server responsible for storing the information used during synchronization. And I have two choices. I can either act as my own distributor, or I can use another server as my distributor. How you set this up is entirely dependent on your environment and your needs. If you have the publisher and the distributor on the same server, and there's models and they're out there in books online, they talk about these models, but this is called a publisher-distributor model. So I have a publisher-distributor on one server. Then I can have many subscribers. I can also have a publisher on a server or multiple servers that goes to another distributor, and that distributor can be the distributor for multiple publishers. Or I can have a one-to-one relationship. But what it lets me do is it breaks up some of this workload. So if I have a busy environment, I'm doing a lot of replication, I might want a distributor that's separate from my publisher, that's also separate from my subscribers. So in this case, we're going to make what's called a publishing distributor or a distributing publisher, however you want to look at it. So we're going to say it's going to act as its own distributor, which is the top and default option, and we're going to go ahead and click next. SQL Server agent start. This is warning me that it is not set to start automatically. Replication is dependent upon SQL Server agent jobs. And if your SQL Server agent doesn't start automatically, all these jobs won't be able to run. For the record, log shipping needs SQL Server agent. Backup jobs need SQL Server agent. So typically in an environment where you have a production SQL Server, this would be set to start automatically. Because I'm running this on my local machine, I don't want a bunch of servers firing up every time I boot my laptop up to do regular work. So I'm just going to say no, but typically you would say yes and have your agents start automatically. There we go. Clicking next. The snapshot folder. So this is the folder where you want to store snapshots. And you'll notice here it has this little warning that it does not support pool subscriptions because this is not a network path. So once we get there, there are two types of subscriptions. There's a push, meaning the distributor knows how to connect to the subscriber and push data. There's also a pull, meaning the subscriber can connect to the distributor and ask for data. But for that to work, the subscriber has to be able to get to these files. So over a network, I can't just have it be a local share. I would have to make this a network share so the subscribers can get to it as well, if I want to do pull subscriptions. Since we're all on the same machine, it doesn't matter for this particular demo, so I'm going to leave this as the default. Okay, which database do I want to publish? Now we're into, this is how you would set up a publication. You can pick any database. There's very little restrictions. The big thing here is, unlike something like log shipping or database mirroring or any of these other technologies that let me move data for high availability, with replication, I don't have to publish the whole database. So you'll see that here in just one second. I'm going to take the worldwide importers database and say that is my publication database and hit next. Now I need to choose my type. As I said at the beginning, there are several types. They're described here, but essentially snapshot is it takes a snapshot of the database, the whole thing, or the things that you're telling it to publish, the tables you want to publish. It takes a snapshot, a copy, moves it over to the other server and puts the entire copy there. It's analogous to a full backup in our store. right? It takes everything, moves it over, restores it. Now, again, it's not always the full database. It depends on the tables you choose, but a snapshot is everything go. You have transactional, which is as transactions occur on my primary, ship them over and apply those transactions on the secondary. This is the one we're going to use because it's the most efficient for high availability because I'm constantly shipping these transactions over and I'm keeping everything in sync. You have peer-to-peer replication, which is multi-master replication is what they call it. Essentially what it is let's pretend I have 3 servers and I want to keep all 3 in sync with each other. Essentially with peer-to-peer, I'm using transactional replication, but I'm using it 3 times. So each of those servers is a publisher and each of those servers subscribes to the other 2. So server A, B, and C all publish, B subscribes to A and C, A subscribes to C and B, and so on. And a change on any server gets pushed out to both the other servers. So with peer-to-peer, I can have a group of servers that's all up to date at the same time. You can use that for high availability, or as with transactional or snapshot, you could use them for multiple reporting servers, for example. So maybe I want 3 different servers because one's like my primary production server and the other 2 I report off of, something along those lines. And you're keeping all this data in sync across all 3. Or 4 or 5, or however many you set up in your peer-to-peer. Finally, you have merge. Merge is a little different. It's a publisher and then multiple subscribers, but there's still a single publisher. The difference with merge is you can update data on a subscriber and it'll push back to the primary. Then that primary will push out to all the subscribers. So yes, you can have multiple databases that all stay in sync now, but I have a single primary. So unlike peer-to-peer, if in peer-to-peer, since everyone's a publisher and everyone's a subscriber, I could take one of the peers away and the other, in the case of 3, the other 2 still talk to each other and stay in sync. With merge, I can take away clients, but I can't take away the publisher. That publisher has to stay there. So this is more appropriate for something where you say have a sales database at a central office, and you need to download client data to remote offices all over the country during the day, and then they process sales, and at night you have that data merge back up, and then by the next day that data is pushed back down to all the subscribers so everyone can see what happened. So merge is more for non-real-time subscriptions. Okay, so keep that in mind. We're going to use transactional for this demo. And next. So it now pops up and asks me when I want to publish. Now you'll notice I can publish tables, stored procedures, views, user-defined functions. I can publish most of the stuff in my database. Can't publish users. I can't publish logins. So those sorts of things you'll need to do manual work on if you really want to have a high availability server. You'll have to manually sync users and logins from server A to server B. That won't happen as part of replication. So just FYI, that's sort of on you to take care of. Now, if I was doing a real high availability solution, I really wanted this database to be a secondary standby, I would select everything. I would select all my tables, all my stored procedures, everything, okay? But I don't want to do that because that's just a lot of data to move back and forth for this demo. So all I'm going to do is grab orders and order lines, just those 2 tables. But just, if you squint just right and look at my screen, pretend I checked everything, because that's what we would be doing for a high availability solution. Now, when you replicate stored procedures, you're replicating the definition of the stored procedure and the definition of the view. So those stored procedures will also exist on the other server. Those views also exist on the other server. You're not replicating calls to them in this instance. Now, you have article properties over here where I can set up different things. And if I drop this down, you can see I can set properties of the highlighted table article or all. And that goes for all these things. And this gets into a little bit more complexity, but you can see here I can choose what to copy. So for high availability, again, you probably would be copying a lot of this, your foreign keys, your check constraints, your clustered indexes, everything, because you want that database to be the same on that side as it is on this side. For this demo, I'm going to leave these as the default. Now you'll also notice down here, I have some options for the destination object. Again, this is very configurable. So the destination object owner, in this case, is going to be the same as the source. The destination object name is default, is based on the table name. So here I can't change it, but I could go to an individual table and say, you're actually going to replicate from orders on this side to a different table over here. So you have that flexibility. So just keep in mind that's there. And there's all kinds of stuff about how you want to convert file stream data and timestamp data, and there's all kinds of stuff. We're not going to mess with any of this in this demo. We're going to leave most of this to default. But I also want you to see here that the insert delivery format, update, and delete delivery formats are call stored procedure, okay? I could also set that to don't replicate certain things, like don't replicate insert statements. I don't want you to do that. Or do an insert statement. So basically, when I insert, to replicate those transactions over, it just calls similar inserts. So if I insert on server A, it calls a stored procedure and says, here's all the data I need you to insert on server B. And it does it again. So it literally takes whatever you did on A and it does it again on server B. So it's not like log shipping where it's copying logs over, and it's not doing some behind the scenes backup and restore. It's not doing any of that. It's literally running the code again. So I can have that be a stored procedure where all the parameters it needs to pass in and say, insert this into my table, or I could say make it an actual insert statement, call the insert statement again. Same with update. I could say call the actual update statement. And there's a couple different kinds of calls you can make. Again, a lot of this is pretty advanced. We're not going to go into most of it, but I'm just going to leave this as the default. So the other thing to keep in mind is because each table has an insert, update, and delete stored procedure, you're going to see those in your database. Those procedures are going to start to exist as we get through this. So I'm going to click OK. Stored procedures, I just want to talk about this real quick because this is interesting. Let me just pick this change password stored procedure, and I'll check it. We're not actually going to replicate it, but I'll look at the article properties, and I'll set the properties of the highlighted stored procedure. Here I have choices. So I talked about earlier how I'm replicating the stored procedure definition, right? And for high availability, I would want to do that. I'd want this password procedure to be on my secondary server, so when I fail over, I can change my password. That's the whole idea. However, you can see here that replicate stored procedure definition only is selected, and that's the default. I can also replicate the execution of the stored procedure or the execution in a serialized transaction, which is just a higher isolation level. But essentially what this means is, in this case, I might not want to replicate the change password procedure to the machine, but I might want to replicate the execution of what it does. So if I call change password on my primary, I need you to then call it again and basically call the execution again. So in that case, I have options for how I kind of keep my database up to sync, right? So I could tell my tables, you know what, don't replicate insert or updates because they're all done through stored procedures. I'm going to replicate the call to the stored procedure, okay? Again, for high availability, this is something you wouldn't do. You'd want a copy of the procedure over there. You wouldn't want a copy of the execution. But again, just sort of giving you a little insight into what you can do with replication for needs beyond high availability. If you're talking reporting servers, things of that nature, okay? So I'm just going to hit cancel on that and cancel, not take this password. And again, pretend I'm checking everything because we're making a high availability solution. All right, I'll click next. I've chosen my articles. Oh, and by the way, the tables, the stored procedures, the functions are called articles. So you can see the magazine subscription thing going even further. There's articles in publications distributed to subscribers. It's all very, very magazine-y. Finally, I can filter table rows. I don't even have to send the whole table. So I can choose which tables I want, and I could trim out things from that table. Again, high availability, we want it all. So I'm not going to do this. Click next. Now we have the snapshot agent. In order for this transactional replication to work, I have to get database A in sync with database B. And that's what the snapshot agent is going to do. So we talked about the snapshot replication, which was take a snapshot, move it over. As part of starting transactional application, you can do that as well. So I can create a snapshot to take my initial data, make a copy, move it over. So we can do that. I can create it immediately, and then I can keep the snapshot lying around if I do more subscriptions. I could schedule the snapshot agent to run at some time in the future, or I could not, and I could just manually get my databases in sync. Sometimes you do that if you're replicating over a slow link, because it might be faster in some cases to back up a database to some sort of media, say a thumb drive, encrypt it, of course, and then mail it to someone, and then they can restore that database, and then you can start transaction shipping between the two. But it's tricky because you have to make sure the databases are in sync, and there's some issues with that. But there's other options, but you do have to get the databases in sync. So they offer you the snapshot agent. So we're going to take that and we're going to say, yes, create a snapshot immediately. Let's get these things in sync. Then I click next, and now we're on to agent security. So it's a lot, I said, the first time you set up. After this first time you make a new publication, all this other stuff's done. So forgive me, there's a lot we're talking through. You have snapshot agents, which is what does the snapshot replication. That has to have an account that it runs on that can talk to both servers. So typically in a domain, this is a domain account. The log reader agent is the thing that reads the log on your publisher to look for changes. That only really needs access to your publisher. But right here, you can use whatever accounts you want. And I'll start by specifying one for the snapshot agent. I'll hit security settings. And you can run under a Windows account, which is what they recommend. And if you're using replication in a proper environment, that you should absolutely have a Windows account set up. It's the easiest way to do all this. But I'm going to go ahead and run it under the same account as my SQL agent service. So what that means is whatever service account my agent runs under is what this will run under. It recommends having a separate account for this, but I'm going to mimic my agent, which is currently running as a local system, so it should have access to everything it needs. In a network environment, you probably wouldn't want to do that. Now, how do I connect to my publisher? I can either do that by impersonating the account or by using the following SQL Server login. So if I need to use SQL Server authentication, I can, and this agent will connect to the publisher using that account. Or I can just impersonate. So essentially, he's going to borrow the SQL Server agent credentials and then impersonate those credentials when he talks to my publisher. That's for my snapshot agent. I hit OK. Now you'll see that also populated my log reader agent. And that's because of this checkbox. Use the security settings from the snapshot agent. By checking this, I'm saying same account for both, right? Use my billing address as my shipping address. Same kind of thing. If I clear this, I then have to go specify a different account. I'm okay with this for this demo. We're going to let this all just sort of run and impersonate the SQL Server agent. You'll notice now I'm getting close because I can click Finish, but I'm going to go ahead and click Next. And that's because it wants to know what you want to do at the end of this. Like everything else we've seen, at the end of this wizard, I can either generate a script that I can use to do this, or I can do it. And I want to go ahead and do the work. So we're going to click Next. It then gets me to the completion screen where it shows my summary of everything that I've set up. The publisher will be configured with the following options. It acts as its own distributor. Here's my agent account stuff. Here's the things I'm publishing. Everything is ready to go. And then you give this publication a name. So for this, I'm just going to call it the WWI DB. And again, if this was high availability, we'd be publishing the whole thing. So that name makes sense from that standpoint. And I'll click Finish, and this should kick off a flurry of activity. Step one is it has to go configure the distributor, which is the thing that moves stuff back and forth. Second, it creates the publication on the publisher server. Then it adds all the articles to that publication, and then it starts the snapshot agent. So it has left me kind of in limbo. Everything is set up, and it says, and your snapshot agent's going. Okay, so I click Close, and let's go look at what it did. So there's a few things that got configured, and if I refresh this local publications folder here, you'll see I now have this local publication, and I can expand that or not. And typically you can see the clients, but let's come down to this machine, go to replication, and look at local subscriptions. And you'd expect to see something here, right? But you don't because I haven't set anything up. So unlike log shipping and some other technologies where you kind of do all this at once, I've not set up any actual subscriptions. All I have is a publication. That's it. And at the moment, snapshot agent, that kicked off. So a couple things you can do. One, if I right-click replication, I can launch the replication monitor. This shows me all the pieces and moving parts of my publication. This is my publisher. If I expand it, this is my publication. If I look, I have no subscriptions, but I do have agents, and you can see the snapshot agent's done. It took 19 seconds. So this snapshot is ready to go to another server. It hasn't yet, but it's ready to go. And I have this log reader agent that's running and watching my publisher for changes. You'll see it says no replicated transactions are available. Now we're on to step 2. I know it feels like we've done more than that, but we've created a publication and we have configured all of replication. So that's pretty good. We've done a few things. But now we need to do a subscription. So we're going to go back to our publication. We're going to right click and we're going to say new subscription. This pops up. Again, I can say, don't show me that first page ever again. And it wants to know what publisher. And for some reason, the GUI is really kind of cramped. I don't know why it's doing that. But what's your publisher? By default, it's the thing from where you just clicked new subscription. So that's fine. And what publication? So you can see I can expand my worldwide importers database and I can see this WWIDB publication. That's the one we have. So that's what we're going to set up a subscription for. So I click next. I have two choices. I can run all the agents as part of the subscription at the distributor. That's the push subscription we talked about. So again, I can move where the agents run to offset load. So I'm going to run at the distributor. You can alternatively run it from the subscriber, which reduces the processing on your distributor because it puts it on your subscriber. But again, your subscriber has to have access to the file location. So you have to have everything on a network share for that to work. In this case, they would have access because we were on the same machine, but I'm just going to run it as a push subscription. Click next. Then it wants to know what database over here is my subscription. So what we're going to do is we're going to say my subscriber is not SQL Inside Out. That's the publisher. I could, by the way, subscribe to another database on the publisher if I wanted to. But we're doing high availability. We want to go to another server, even though it's an instance on the same machine. So I'll click Add Subscriber. And it's a SQL subscriber. And it's Inside Out too. That's perfect. We'll click Connect. Now it comes up and says, well, what database do you want this data to be in? And I can either use an existing database. I can make a new database. So what we're actually going to do is create a new database. And again, if you were trying to replicate the same database from point A to point B, you would probably use the same database name in a failover instance. But we're going to do worldwide importers REPL just for REPL so we know it's there. Default, default, default. That's all fine. I'll click OK. Okay, so now we have this new database. That's the one we're going to use. I'll click Next. It wants to know, just like before, what security accounts do I use to connect to the distributor and how do I connect to the subscriber? So you can click the little ellipses over here. This pops up. Same warnings about you should have a Windows account. I'm going to do the same thing and impersonate my agent account. I'm going to impersonate the process of that account for both connecting to my distributor and connecting to my subscriber. Done. Next, it wants to know how often do I want to run this? Run continuously is the default. Otherwise, I could run on demand only, which means unless I do it, it's not replicating, or I could choose a different schedule. So because I'm trying to do high availability, I want to run continuously. As soon as you get something on the primary, I want to know about it on the secondary. So we're going to say run continuously. Next. Here we have a couple options to initialize the subscription at the subscriber. So it needs to be initialized. So you can see here, when do you want to initialize it? And I don't have to initialize. I can say, nope, I'm going to deal with that myself. Or I can say immediately or at first synchronization or whatever. This is going to use that snapshot to synchronize. So that's fine. We're going to go ahead and say immediately, and we're going to hit next. Again, do I want to script it or do the work? I want to do the work. Here's my summary, finish. So now what it should do is create the subscription, and then kind of be done. And then what we'll see in the background is all these tasks and jobs are going to start doing their thing. So it created the subscription over here. Let's look at our replication monitor again. So we right click, replication, launch our monitor. Here it is. I have an error, which is fantastic. And you'll see it's this publication, it's this subscription. It threw an error. Let's see what it did. The process could not access the database worldwide importers on this other machine. And it says, can open the database requested by the login. The login failed. So it attempted to use our SQL Server agent account, and for whatever reason, that SQL Server account doesn't have access to this SQL Server. And that is probably very true. So what we're going to do, just to sort of facilitate this demo, is I'm going to have the accounts run as a different service. So we'll come out here and we'll go to our Microsoft SQL Server 2022 configuration right here. And you'll see my SQL agents are running as local system. So we'll double click this and we'll run it as a network service. We'll restart it. That should be enough to get things moving again. Where's the agent? There it is. Do the same thing for this one. Good. Make sure they're both running. They are. All right. So we'll flip back over to our replication monitor. Here we go. And you can see I've now got a performance critical warning. The latency is 9 minutes and 27 seconds. And that starts to warn you when the databases are getting off from each other. But it's because the snapshot isn't done. So we'll right click this. We'll look at the details. And you can see we've gotten through our errors and now it's been running. And you'll see it actually finished. So you can see here it started the agent and initialized it. It applied the scripts it needed for orders and order lines. And you can see here it's giving you a row count. And then at the very top, it says 4 transactions, 96 commands are committed. So now that's your distributor to subscriber history. So you have these 3 tabs so you can kind of track all this. And what you'll see is here, anytime transactions are available at the publisher to get pushed to the distributor, you'll see them come up here. Whenever there's stuff on the distributor that has to go to the subscriber, you'll see stuff here. So at the moment, these 2 databases are in sync. And I can show you that by starting a new query. And this is on, check our connection. This is on SQL Server Inside Out. This is on our publisher. So from here, I will select star from sales.order, orders, F5, have to be in the correct database. So never forget that. Wired World Importers. Boom, there's all our order data. That's not surprising. Guess you guys were expecting that to work. I'll go over here and I'll start a new query. In this REPL database, new query. We'll run the same query, and there's all the same data. Now, for the real magic of replication, let me see if I can get, there we go. 2 windows side by side. So this is my publisher here on the right, SQL Server Inside Out. This is my subscriber on the left, SQL Server Inside Out 2. So what we're going to do is we're going to change something on the primary. Now, one advantage if you've looked at log shipping or mirroring or other high availability technologies, you'll notice I can select from both sides. I'm not blocked like I would be with some of the other texts. So what we're going to do is we're going to update sales.order. And we're going to set, I don't know, ordered expected delivery date equal to, and so basically what we're going to do is let's pretend we had a shipping issue, and let's also pretend it's 2015. So we're going to set expected delivery date equal to 6/28, where the expected delivery date is 6/26. So essentially what we're saying is, yeah, everything that was going to ship out on the 26th isn't. It's going to ship out on the 28th instead. So we're going to update our sales table with that particular piece of info. So if I come over here, before I do this, if I query this table where the expected delivery date equals 6/26, you will see that I have 91 rows, okay? And if I query where the expected delivery date is 6/28, you'll see I have no rows, okay? So essentially, this data is in the state that it is in this first server. But now we're going to move all these from 28th to the 26th, and so we should see that change appear both on the primary and on the secondary machine. So I'll do this update. It should affect 91 rows, and it did. And then I'll go over to my secondary, and I'll just hit execute a couple times, and we'll see after a few seconds here, everything should, there it went, have replicated over. So now I don't see orders on the 26th anymore. They're all on the 28th. So that took a few seconds to get from the primary to the secondary server. So these two servers are pretty much in lockstep. And just to look at what happened in the replication monitor here, if I look at the details of this subscription, you'll see from the publisher to the distributor, there was my transaction with 91 commands, those rows that I updated. Then from the distributor to the subscriber, you can see there it delivered the one transaction with 91 commands. So that was everything sort of being pushed over from the publisher to the distributor to the subscriber. And so you can see how if I did this for an entire database, any changes I made on my primary would immediately get made on my secondary as well. So you could set this up as a high availability solution. Now, I mentioned earlier in this lesson that it doesn't replicate users and it doesn't replicate logins and it doesn't replicate like SQL Server agent jobs. It only replicates databases. So if you wanted to use this as a true high availability solution, you're going to have to do something to regularly script, transfer, and load your logins, your jobs, any other settings on the server, anything like that. And in the event of a failover, you're going to have to manually point your clients to another server. But you can use it as a high availability solution. And I think you can probably also think of about 100 other ways you could use replication for reporting services, moving lookup tables around. It has a lot of utility, and there's a lot more to it and a lot more detail you can get in than we went through in this lesson. But hopefully this is enough to not only get you into replication as a high availability solution, but just to give you a primer on what SQL Server replication is, and maybe there's some other areas you can use it in your environment. So depending on which high availability solution you're using for your Microsoft SQL Server databases, there's various ways that you can read the secondary data. If you're using replication, and if you go look at the replication lesson, you'll know that in transactional replication, I can read from my secondary copy. In fact, my secondary copy is a full-blown database, and I can write to that database. Now, I wouldn't recommend that because you can cause problems with your replication. So replication is all about moving data across the wire, and in order to do that, part of what it needs is a primary key. So if I update a row, it needs to know that I can go to the secondary server and update the same row by passing in the same data and referencing the primary key. If I delete a row from my primary, it needs to go find that row in the secondary and delete it based on its primary key. So a couple things can happen if I start writing to that secondary database. One, if I mess with the primary key, replication is going to straight up fail because now I can't delete it, I can't update it because I can't find the record, okay? Two, if I modify data on my secondary, the next time replication comes in and says, hey, I have all this new data, it's going to overwrite your changes because it's going to just fill in whatever happened on the primary. And if I start doing things like changing column names or removing or adding columns, you're just asking for all kinds of trouble. So typically in a high availability or a reporting server or any sort of secondary, you don't want to write to it. Replication, you can. Now, if you're using a technology like mirroring or log shipping, there are ways to make those secondary databases read-only. And I'm going to show you an example of how to do that with log shipping real quick. And that sort of helps soften the blow sometimes of having a secondary server. So a lot of times financially, people don't want to pay for a second server that just sits there with a copy of the data because that costs money. I presumably have to have a server that's as expensive, as big, as strong as my production. So when the failover happens, I can still do work. So a lot of times people get pushback from executives and from managers that say, I'm sorry, we can't spend another $100,000 on a server just to sit there and do nothing. So by being able to read that secondary server, either for reporting or for whatever else, you can make a better case of, well, it's not just doing nothing. We're using it for reporting. So sometimes you have to do it for that kind of a reason. And sometimes it's just nice to be able to have another copy of the data you can read to lessen the load on your production server. So we'll take a look real quick at a log shipping example where you're allowed to read the secondary. All right. So I'm going to fly through setting up log shipping on this worldwide importers database. If you need a refresher, there's a lesson on log shipping. So I'm just going to go to properties here, down to the transaction log shipping tab. I will enable it. In the backup settings, I need to tell it where the paths are. So this is my local folder here. This is my networking folder. Every 72 hours, fine. I'm using all the defaults as I come through here. I'm going to add a secondary. That's going to be my Inside Out 2 instance. I will initialize it. Its folder is going to be this local copy folder and restore every 15 minutes, just like a standard thing. So you're going to do all the defaults every 15 minutes, and that's fine. Now here's where the change comes in. Right here, database state when restoring backups. If I leave the default, which is no recovery mode, that database stays in recovery and is useless. I can't read it. I can't do anything to it. All it's waiting for is additional backups to be restored. If I want to be able to read from it, you can choose standby mode, which is this one here. What this will do is leave the database in a state where it can be read, okay? However, every time it needs to apply a new transaction log backup, people need to get out of the database so that can happen. So it can't apply a transaction log backup while the database is in use. So you have two choices for that. One, I can leave it alone and tell users, I need you to be out of here every now and again because it has to restore transaction logs. But if someone's logged in, it could actually block a transaction log from being restored. Now, that's not necessarily the end of the world. These transaction logs are being copied and stored locally, so they will eventually catch up once the database is in a mode where they can restore, and it'll eventually apply all the transaction logs. Now, after 45 minutes, if you have the default setting here, you will get an alert saying we weren't able to restore. Your other option is you can disconnect users in the database when restoring backups. So if you're going to set something like this up for high availability, you probably want to reduce the frequency with which you restore your transaction log files. Now, nothing says you can't take your backups. So over here in your copy files, I can still copy files every 15 minutes. And up here in the settings for your backup on your primary, I can still back up every 15 minutes. But what's going to happen is those transaction logs are going to get backed up. They're going to get copied, so they'll be on your secondary server, but maybe you only restore every once an hour or once every 2 hours or once every 4 hours. The bottom line is then you can leave this offline copy available for a longer period of time, okay? And then when you need to, you can restore those transaction logs every hour, every 4 hours, whatever it happens to be. That could potentially slow you down in the event of an emergency because now I have to switch over, but real quick first I have to restore these transaction logs. Now, depending on the state of your server and how much data you're moving through it, a couple hours worth of transaction logs should restore relatively quickly, but that would still require you as an administrator to intervene and go in and say, everybody out of the pool, I got to restore these transaction logs and bring this thing up as the primary. Okay, but you can do it. You can tweak the settings, have these things restore less frequently, and therefore are kicking people out less frequently. So we're going to go ahead and do standby mode, and we're going to say disconnect when restoring. I'm going to click OK. I'm not going to do a monitor instance, and I'm going to script this to my clipboard just in case. So we'll just go ahead and click OK. and this will go ahead and set up our log shipping. So just like we did in the log shipping lesson, we're going to configure it to run from server A to server B. It's all set up. It's restoring to the secondary server now, and every 15 minutes, logs will go from server A to server B. One big difference this time as opposed to last time. You'll see here the worldwide importers database is in standby/read-only mode. So I can click, select new query, and I can go in here and I can select all from sales.orders, for example. And it works. I have read-only access to this database. I can't write, I can't insert, I can't update, I can't delete, which is fine. But I can read. So I could run reports off this server. I could do what I need to do when this server is just sitting here waiting to have transaction logs restored. Okay? So it's a good way to sort of make use of a secondary database. Again, with replication, you have it. Some other technologies, you do have options to do this as well, to have a standby read-only, but occasionally it does have to boot people out. And I'll show you. So if I come back to my primary server here and I go to my agent, we will run the backup. So I'll start that job. Done. And then we'll come to our secondary and we'll run its transaction log shipping jobs. We'll copy. There we go. Copy's done. And let's run the restore. So a couple things happen when I run the restore. Just like before, I should be restoring these transaction logs to my secondary database, but it's also kicking out my connections. So everyone that was in that database gets booted out. Now you have to reestablish a new query, and you can go in, and now that the restore is done, you can go in and you can run another query, and everybody's happy. I didn't change anything in that database, so there's nothing that has really been modified. Oop, here we go, back to our correct database, and orders, and go. So there you go, I'm back in and reading. So every time those restores happen, people get kicked out. So this is where, as I said, you might want to stretch out the restore time a little bit. So the logs are still over there, and they're still ready in case of emergency, but you could stretch out the restore to allow people to stay in the database. So that's just a quick glimpse at how you can have your secondary server still maintain a read-only copy of the database. And just keep in mind, with certain technologies, such as log shipping, it's truly read-only. So it's a little more foolproof. With replication, you can still write, you can still delete, because it's just a regular database. So you have to be a little more careful with what you allow people to do in there so it doesn't screw up the syncing. But this should help you out and give you a little bit more computing power, because now you'll have a secondary read-only copy on another server that you can use instead of your production server. Managing, monitoring, and automating SQL Server are key aspects of your day-to-day. Here, I'll show you how to manage databases and monitor activity to keep your servers performing in peak condition. Then we'll look at ways to automate certain aspects of SQL Server administration so that you understand the components you need and the tools that can help you. Tools like PowerShell. Welcome to our lesson on managing and monitoring SQL Server databases. This lesson will help you to understand how you can monitor your environment for potential issues and use this information to make proactive decisions so things keep running smoothly. This lesson covers how to schedule and monitor database backups, dealing with database corruption, how to set up index maintenance, cleaning up your job history, shrinking databases, how to monitor database activity, using the performance monitor, and monitoring database logs. In addition, we'll take a peek at the resource governor in SQL Server. Let's get started. In this lesson, we're going to take a look at using SQL Server Agent to set up jobs to automate your backup processes. Now, you can use SQL Server Agent jobs to automate a lot of pieces of SQL Server, but we're just going to look at setting up some backups, and you can use this knowledge for other things. We'll also touch briefly about how you can monitor those jobs to make sure that they're executing as expected. So in SQL Server here, if you go down toward the bottom of your Object Explorer, there's a node called SQL Server Agent. So I'll just expand that. And there's a jobs node. I'll expand that. And what we want to do is set up a job to back up our user databases. And the jobs you set up and the number you set up are going to depend on your backup strategy. If you want fulls, say once a week, and differentials throughout the week, I'll set up a basic scheme here, and then you can expand this to meet your own needs. Now, I'm not going to jump right into creating a job because we can cheat a little bit using the GUI, and I'm going to go ahead and take advantage of that. I'm going to right-click on my wide world importers database, go to tasks, and go to backup. Once this opens up, I can set up a backup just like I would if I was about to execute it live. So I'm going to go through that process real quick. I'll remove that file. I have a backup device here called WWI full backup that I want to back up to. So I'll save that. I'm going to do a standard full backup. And in this case, I'll go ahead and append to the backup set. If you were doing this regularly, you'd probably want to have a backup maybe once a week or so that overwrites, or maybe 2 backup files. That way you don't have to keep years and years of backups in one file. But for now, I'm going to go ahead and append. So rather than clicking OK, we've seen in several of the other lessons that you can hit this script button and it'll script out to your clipboard, it'll script out to your new query editor window, whatever. But there's another option here. If I drop this down, if I hit the little arrow next to script, I can pick script action to job. So that's what I'm going to do here. And you'll notice as soon as I did that, it brought up a new job step. My backup database window is still there, but it brought up a new job step. So what it's done for me is it's created, or it started to create, a new job for my SQL Server agent. And if I look at it, the name is backup database and the database we're backing up. I own it because I'm the one that did it. It doesn't have a category. You can drop this down and you can pick one. And in this case, I will just pick database maintenance. And you can see you can pick, there's different replication categories. And if I click this little triple ellipses here, you can see the category and other jobs that might exist in this category. So for this job, I'm just going to go ahead and pick database maintenance because that's what a backup is. And you could type a description if you want. Now, we're going to go over to the steps page, and you'll see here it has added a step. And it's a transact SQL step. You can see by this type. I'm just going to go ahead and double click it, and we can take a look at what it actually created for me. So you'll see down here, it does a transact SQL script, a T-SQL script, and it's in the master database because that's where you do backups. And it just took the script for the backup database, worldwide importers to this backup device. That's everything we expected it to do. So I like what I'm seeing here. This is my full database backup. And now I can schedule this to run whenever I need. Now, if I wanted to schedule backups for more databases, I could expand this script and I could add additional backup database commands in here, or I could add additional job steps. So if you look out here, this is job step 1. I could add a second job step to back up another database and another database, or however I wanted to set it up. For now, I'm just going to back up the wide world importers, and you can then see how you could apply this to all your databases and all your backup types. So I'll just click the schedules page and I'll hit new. This will pop up and allow me to define a schedule for how often I want this to run. So I'm going to have this run daily. Full backup is what I'll call the schedule. And I don't necessarily need to call the schedule full backup because the job is, but I like being overly redundant. I'll set it to be recurring, and I'll have this occur daily, and it'll be every day at 12 a.m. is actually perfect. I'll have it run with no end date, so this will occur every day starting at 12 a.m. So I'll just hit OK on the job schedule there, and then I can hit OK on the job. And now I've still got my backup window up. I'll just cancel out of that because I don't need it anymore. And if I come over here to jobs and refresh this, you should now see my backup job in here to do my weekly backup right there. Backup database, wide world importers. So that'll run every night at midnight to back up my database. Now, if I wanted to do differential backups at noon, I could add another job that does that. If I wanted to do transaction log backups every 15 minutes, I could add another job that does that. Now, you can also automate database backups through SQL Server maintenance plans, and there's a whole lesson on that if you want to check that out. It's actually a little bit easier because it allows you to back things up in groups. So I can actually say back up all my user databases or all my system databases, and gives you a little more flexibility. But I wanted to walk through how to do it with jobs. Now, the other thing you can do with your jobs is you can monitor them to see if they've failed or succeeded or whatever it is you need to audit. A couple different ways you can do that. One, every job has a history. So if I right-click a job and hit View History, this history log will come up. And you can see this job has never run, so there's no data filled out in this particular pane. So just so we can see something here, I'm going to close this out and run this job real fast. I'll just select Start Job at Step. Because it's only a one-step job, it doesn't ask me which step to start at. It just understands to start at step 1. And you can see it started the job executed successfully. No errors, no warnings. So now if I go back into history, you can see here's all the details about that job. What server it ran on, the job name, and if I scroll over, there's all kinds of other things. The steps, the messages that were invoked, anything like that, the duration. And you can expand this and essentially see all the steps. Now again, this is a one-step job, so you only see what happened on step 1. So I can look at this history, and that's one way I can kind of keep tabs on my database backups. But what if I want to be notified in the event that this fails? SQL Server has some built-in operator and alert functionality that we'll look at. It's fairly basic, and there are third-party monitoring tools available, but if you want to use the built-in stuff, here's how you do it. Come down to this operators folder in your SQL Server agent. And you'll say I don't have any operators, so we're going to go ahead and create one. I'll right click here and select new operator. This pops up. You give your operator a name. You can see you can give it emails. It says pager, but really if you look at it, it's pager email. So essentially I can set up email accounts to send notifications to in the event of a failure. So you would type in your email, Eric at contoso.com, and your pager would be whatever it is, Eric Pager at contoso.com. These are obviously not real emails, so they're not going to go anywhere. And then you can select the on-duty schedule. So if you do that, this person, this operator, will only receive emails during their on-duty schedule. So you can check all the days of the week they work, and you can check the weekends, and you'll see I get schedules. It's a little bit weird because I basically get a workday start and end time, and it applies to all the work days. So if I work from 8 to 6, that's when I would get notifications. On the weekends, you can then specify times for both Saturday and for Sunday. Now, if you don't work on a weekday, you can uncheck that weekday. But if you work different hours on a Monday versus a Tuesday, it's not quite that flexible. But within these hours, I would get notifications. Potentially, if this is a serious job, you might have to set up an operator that gets notifications around the clock, 24/7. You can manipulate this as you see fit. You can change it up. There are workarounds if you do work different times in the weekdays. It's basically create 2 operators. So one would be your Eric Monday, Tuesday operator, and one would be your Thursday, Friday operator, for example. Same emails, everything else would be then able to be configured, and then I can send notifications to both those operators. And that would allow you to get notifications at times that are slightly different. So it's kind of, like I said, it's not a fully featured monitoring solution, but it's not bad. So I'll set that up here. So if I click on this notifications tab, you'll see it shows me a list of alerts that are set up on my server. And alerts are a little out of the scope of what we're talking about, but essentially these are set up that can be raised by the server in the event something happens. And you can see log shipping and replication has put several of these alerts in there. So if I want this operator to be notified of any of these issues, I can just check email or pager over here. And when that alert occurs, this operator will be notified. What we want to do is get notified if our backup job fails. So to do that, we're just going to go ahead and make sure everything's right and click OK to create this operator. Then we're going to go back to our backup database job. I'll double click it, and you'll see down here there's an alerts page and there's a notifications page. So the alerts page allows me to add an alert that I could raise at different times from this job. The notifications tab lets me directly email or write to an application log when I have issues. So you'll see I can check email, and I can pick myself, and then I can say when the job fails. You can also say succeeds or completes. So completes means success or fail, let me know. obviously fail and succeed are when it fails or succeeds. So I can email or I can page, and essentially remember all this is 2 different emails is what you're getting. My other option here is I can write to the Windows application log when the job fails. So now if I were to click OK on this, and I will, if this job were to fail and you have everything set up and you're ready to go, when your job fails, it can shoot me an email and I can then know about it. Now, this is beyond the scope of this particular lesson, but in order for SQL Server to be able to email, you have to go under this management folder, and there's a node here called database mail, and you kind of have to go through and set that up. So we're not going to set up database mail here. It's beyond the scope of the lesson, as I said, but with database mail set up, that means your server can send email, and therefore your operators can receive email from job failures. So again, we just set up one job to do a full backup of one database every day. You can do multiple jobs to set up multiple databases. There are other potential avenues for doing database maintenance. And as I said, one of those are database maintenance plans, which there's a lesson on, so you can check that out. And hopefully by just taking this little glimpse into the SQL Server job agent, you now know how to set up jobs and set up operators so you can automate just about any task that you can think of where you can write a T-SQL step into a job, and there's actually other options that we'll cover in some other lessons. So hopefully this gives you enough to start automating and monitoring your database backups. So in this lesson, I want to take a quick look at a common tool that DBAs use if they have an issue with potential database corruption. There's a whole suite of these tools. They're called Database Consistency Checker Tools, DBCC for short. And the one we're going to look at today is called DBCC Check DB. So I've got a script open here, and it's literally just that. It's DBCC Check DB. And I don't have any databases that are in a bad state. So nothing's in recovery, nothing's having a problem. But if you get bad pages in a database, they can go into like this weird offline state where SQL Server can't bring them online, or you might just have errors trying to access the data. A first level tool to sort of help prevent you having to go all the way to a restore is DBCC CheckDB. And what I'm going to do here is just change my context to the Wide World Importers database, and I'm going to run DBCC CheckDB. Just this top line, these are some of the options I'm going to talk through in a moment, so ignore those. Now, depending on the size of your database, this can take a little while. But you can see this finished relatively quickly for me. And if I scroll down here, you'll see what it did. It basically went through all the different columns and row sets and files and properties. And the big thing, so this is just all the things it scanned. If I scroll all the way down to the bottom, you'll see the DBCC results. And then down at the very bottom, you'll see CheckDB found 0 allocation errors, 0 consistency errors within worldwide importers. So that's a good thing, and that's what I would expect from a healthy database. Now, some people will run this occasionally just to get this report to see if they can find anything about their database having a potential issue prior to one happening. So it's not uncommon to schedule this as a task in your SQL Server agent to run occasionally. If it does find a problem, that's when you can kick in these parameters here that I've commented out. So I'll just remove the comment so we can see them and talk through them all. This first one, repair allow data loss. What that will do is it'll run the DBCC checker and it'll attempt to repair your database. So if there's something wrong, it'll attempt to repair it. However, this is like the least gentle version of the CheckDB repair because it'll allow data loss. So if you have a bad page and that bad page is preventing your database from coming online, it might just delete that page. Okay, so repair allow data loss can help you fix your database, but you might lose data. Repair fast is kind of just what it sounds like. It attempts to repair your database, and it attempts to do it quickly, and it attempts to do it without data loss. So that's something you can run as well. And finally, if you need to try to rebuild pages on your database, sort of a middle tier between repair fast and repair allow data loss, you have repair rebuild. So you can run DBCC CheckDB with repair rebuild, and it'll attempt to repair and rebuild the parts of your database that are having issues. Okay. Now, unfortunately, I didn't have a corrupt database that I could walk through the process of actually seeing a repair for this demo. But I did want to show you the execution of DBCC CheckDB and at least talk through these options. So as I said, you can go ahead and schedule CheckDB to run regularly, and you can get kind of crafty with the results, and you can say, hey, if it's finding errors, if I see that in the output, notify me that you found some issues. And that way you can kind of stay on top of possible corruption issues. And if you do have a database that gets stuck in recovery or can't come online, then this is a good first step to try to repair those corruption issues before you have to resort to a full database backup restore situation. So as data in your database changes, your indexes also have to change to keep track of what's new, different, deleted. All that has to be tracked and accounted for in your index. So indexes over time have a thing called fill factor, where it's how much data can fit on a page of an index. But over time, what happens is a page fills up, and then you get things called page splits, where your index will add another page, and sometimes it starts to fragment the data. So your index data gets fragmented, meaning it's not stored in a very good order. And in order to fix that, we can repair, we can rebuild indexes, and it's something you should do regularly, especially against tables where the data changes. If you have static tables that never change, like lookup tables, the indexes on those will probably never really need to be rebuilt. But bigger tables, OLTP, transaction processing type tables are going to have their indexes rebuilt. So you want to build that into your database maintenance. I'm going to show you a script that can help you figure out which indexes need to be rebuilt, and then you could apply that to automate some of this task so that you don't have to just rebuild all the indexes, nor do you have to monitor this yourself. So here's a little script that's going to give us our index fragmentation. Now this looks like a pretty big, hairy script, but what you really care about in this script, the meat and potatoes of this script, I'll just separate it from the rest, is this function right here. It's a system database management function called sysdmdb index physical stats. And what this is a dynamic function where you can pass in parameters and it will return you statistics about your index. So think of what this returns as just a result. It's a table, right? It's a table result that I can then join with other things. And then you'll see here, all the script is doing is joining systables, sysschema, and sysindexes so that it can provide you some human readable information about which indexes on which table have issues. Now you'll see anywhere this is referenced, DDIPS, which is DMDB index physical stats, any place that's referenced is data it's pulling from this function. So here, that average fragmentation in percentage, that's going to tell me how fragmented my indexes are, and this is going to give me my page count. All the other stuff here is just to sort of narrow down schema, table, and the index name so that I can see which ones are fragmented. So I'm going to run this real quick, and what you'll see is this is going to go out to the whole database, and it's going to return every schema, table, and index, and its fragmentation, okay? Now, I could start to narrow this down, and I could say, you can see here, average fragmentation is above 0%. That's probably a pretty low bar. So if I was going to do this for regular maintenance, I would maybe set this to, I don't know, 20, 25. I guess it sort of depends on your environment and how often you want to keep your indexes cleaned up. Now, how does it know to only get this database? So there's a couple functions that T-SQL provides, and we're using them here, where you can get the database ID of the current database or of any database. That function is called DBID, and it's right here. What this does, if you don't pass a parameter in, is it returns the database ID of the database you're in. So in this case, that would be the ID of worldwide importers. I can also pass a parameter into this to say, get the database ID of HR if I wanted to. So because this is dynamic, whatever database I'm in, I'll get the data from. So if I go over to my HR database here and hit execute, you'll see I get one index that has fragmentation because there's only one index in that entire database. It's just a pretty empty little sample. Now, you can further filter down the information you're getting out of this by using these other parameters of the physical stats function. So each of these helps you narrow further the information you're returning in this function. So if you click on this function, and you can do this with anything in T-SQL, and hit F1, it's going to bring up the Windows help file from Microsoft's Books Online database. And here's the help file for DB index physical stats. So what you care about, I'll scroll down just a little bit, is right here, all the parameters. So we're passing in the database ID. That's already being done. The next one is the object ID, then the index, then the partition number, and then what mode do you want to run this in. So I'm only passing in database ID, but I'm going to further filter it by passing in the object ID, in this case, the table whose indexes I want to see. So we'll flip back over to our script. And right here, the second parameter, rather than saying null, I'm going to pass in the ID of a table. So the table I care about in this case is sales.orders. Okay, sales.orders. Now, you noticed that the function help file said this is expecting the database ID and then the object ID, not the name of the table. So if I try to run this like this is going to cause an error because I'm passing in the name of the table. There's another helper function similar to DBID, which gets the database ID, and it's called object_ID. And then I can pass in a parameter that is the object name of the object that I want to get the ID for. So essentially what this is going to do is pass the object ID of the sales order table into this function. And now I will only get information about the sales order table and its indexes. So when I execute that, you'll see that is the case. Now, you'll see it has several indexes, 6 to be exact, and of those 6, 4 of them are 97% and higher fragmented. That means that those particular indexes are in pretty bad shape, and they're going to be slow and not as efficient for use in your query optimization. So I'm going to make a little more space here, and we're going to take a look at the picked by person index. And I'm going to go ahead and just copy this row because I want to hang on to this data so we can see it change as we go through the rest of this. So it was the sales order table. This is the foreign key index that we care about that's fragmented. And then this is the fragmentation level and the number of pages. So we're going to show you how to rebuild this index and try to make it a little bit better. Again, give a little more space there. What I'm going to do is go open up the database, open up tables, and I'm going to scroll down to my sales order table. In that, I can expand it again and expand indexes. And now you can see the 6 indexes here that we're looking at in our statistics. So again, we're looking at this picked by person index. So if I right-click this, I can select rebuild or reorganize. Those are functions that help you rebuild the index or reorganize the index, which is a little less invasive. I can just click this right here and it'll rebuild or reorganize the index. So what I'm actually going to do here is click reorganize. That's going to bring up the dialog for reorganizing the index, and there's no options to this at all. It's just here's the index you selected, and I click OK to reorganize this. But what I'm actually going to do is just script this out to the clipboard so we can just take the script over here and have a look at it. Okay? So there it is. Using the wide world importers database, alter index this on sales.order, reorganize with lob compaction on, fine. If I run this, this is going to do a reorganize of the index. So what that attempts to do is it attempts to move data around, especially if you've got room left on some pages, like the fill factor is such that you have some space. It attempts to move things around and get the index less fragmented without completely tearing the index down and rebuilding it. This is an online operation. So I can do this and it will not affect people in my database. They don't get blocked out of my tables. Things can continue on and everybody's happy. So we'll try this and we'll see how much better the index gets. So I'll just highlight this row, these rows, and I'll hit execute. And it came up and said command completed successfully. So let's see how much difference this made in our index. I'll rerun our select up here to get our statistics, and we can compare it to this number I saved earlier. So you can see the picked by person index is now 0.7825% fragmented, and it now only has 128 pages. So it was very, very fragmented, and it was taking up 100 some odd more pages than it needed to after this reorganization. So again, I went from 99% fragmented, which is basically as fragmented as you can get, down to 0.78125. So in this case, the reorganize did a pretty fantastic job of fixing this index. Could it get better with a rebuild? In a production environment, I probably wouldn't even bother if I got it down below a percent fragmentation. However, let's give it a shot and just see if a rebuild would have done a better job. So I'll right-click and select Rebuild. And again, I'll script this off so we can take a look at it. And we'll just scroll down to the bottom, and I'll paste that in. And you'll see the command is fairly similar. It's still alter index, and instead of reorganize, it's rebuild. So rebuild partition, and you can rebuild, in this case, all. And then there's a few more options for a rebuild. I can pad the index, I can turn off recompute, I can sort in tempdb, I can do a lot of this stuff. You'll see here, there's an online option. Now this online option means it attempts to rebuild the index online, which again is a little less impactful to your users, but not as efficient. So we're going to turn online off, meaning it's going to try to do a full offline rebuild of this index, which is the most efficient way to get your index rebuilt, but it does block users from getting into this table. So this is not something you would run middle of the day. Index maintenance like this, where you're going to rebuild, need to be run off hours when people aren't on the systems. All right, so let's just highlight these rows and execute it. And off it goes. It's rebuilt that index. Now these are both very quick commands because this is a small table and these are small indexes. For large tables and large indexes, these can take a while. So be aware of that as you start to plan index maintenance, that sometimes these rebuilds and reorganizes can take some time. So more important if you're doing the rebuild because you're potentially blocking users. And let's just have a look and see if the rebuild made any difference at all to our index. So you'll see the index has dropped off my list. It still exists in the database, but the index is no longer showing up on this fragmentation report. And the reason for that is if you look at the where clause, it only shows me indexes where the fragmentation's over 0. So this doesn't even bother to show me indexes that have 0 fragmentation. So I'm going to delete this AND statement from our where clause, and I assume now when I run this, the index is going to show back up with a 0 fragmentation. So it did, the rebuild did in fact get us this last 0.7125%. So that's not too shabby. That index is now basically in perfect shape. It didn't reduce the page count any further. I wouldn't have expected it to with that little fragmentation, but the rebuild did do a better job. So, thinking in terms of how you can use this for ongoing maintenance, and I've done this kind of stuff in the past, you can create SQL jobs that essentially run a query similar to this, dump that information into a temp table, or you just write some code, right? And again, that's a little bit on the scope of this lesson, but you can write code to look at the results of this query. You can then automate through scripting. This is why I wanted you to see the scripts of these. Basically, if you want to just do a reorganize on the index, all you have to do is take a look at these results right here, and then essentially you're going to build alter index commands in your own code. That would say alter index, fill in the index name from this column. On sales.orders, you can fill that in with the schema and the table name from these two columns, and then you can add the reorganize command right after that. So with a little bit of T-SQL and a little bit of elbow grease, you can essentially adapt this function that we wrote here into a job that dynamically looks at fragmentation and dynamically reorganizes. You could also do it for rebuild. So you could have it run for in the middle of the night and rebuild indexes. Again, knowing how long that's going to take on each index is important. So you probably want to at least check that out before you start automating the rebuilds, because again, you can knock people offline with that. So the big thing here, just remember the important function in this whole thing is this one here. It's the sysdm db index physical stats. That's where you're going to get all your fragmentation information, all your index page count information, and then everything else was just a join to sys schema tables, sys tables and sys indexes to get the information about the tables and the objects that you needed to go along with it. So hopefully you can take this script, adapt it to your environment, and index maintenance will be something that you can pretty much automate and not have to worry about as an ongoing concern. So as you automate more and more of your SQL Server administration responsibilities by creating jobs in SQL Server Agent, you're going to notice that you could have an issue with your MSDB database starting to get bigger and bigger. And that's because the history of all those jobs gets logged into your MSDB database. So just like managing your user databases, you have to take a few steps to make sure you're culling that data, because let's face it, you don't care if a backup job succeeded 3 years ago, right? You need relevant information that you can act upon. So we're going to look at how you can make sure you're trimming that down and getting rid of irrelevant history entries. So the first place you're going to look to see how often you're trimming your history is in your job itself. So I'm going to look at this backup database job and just double click it here. And you'll see that this is sort of the typical backup job. It's got one step, it does a backup, it's running once a day, so nothing too crazy. But this is going to run once a day, which isn't going to put a lot of history in our system. So to see the history on this, I'm just going to go ahead and run it quickly, just so we have a little more than one entry. Shouldn't take very long. And we are done. So I'll close this out, I'll right click, and I'll select View History. Now when you go here, you can see this is the history for just this job. On the left, I'm able to actually check any other job that I want to see history for. So this is a history viewer. It's not just tied to the one job. So I'll do that, check all my jobs. There we go. And you can even see the SQL Server agent log and the database mail log from here if you need to. But what I care about right now is the job history. So you'll see here, and I still don't have a ton, but that's a decent amount of history for a machine that's really just sitting here as a demo. So I'm getting a lot of things from some of my agent history cleanups because replication's running. I have some log shipping stuff that's running occasionally. And this history builds up. I mean, you can see some of this, it's running every minute, some of these jobs. So this can build up pretty fast over the course of days, months, and years. So you want to make sure you're getting rid of this stuff. So to that end, let me go ahead and hit close. And I'll right click on my SQL Server agent and hit properties. Now, when this comes up, you can see it has a few different things, but what we care about here is history. So the current job history log. This is the size of the job history log, the whole thing. So the maximum job history log size in rows is 1,000, and the maximum job history rows per job is 100. And then I can actually go ahead and check this if I want and say remove agent history older than 4 weeks, 5 weeks, whatever. Now, on a busy system, I might want to keep more than 1,000 or 100 log entries per total and per job. But if you look at this and you start to kind of think about what we're saying with these two numbers, you realize that there's potentially a problem here. So the maximum job history per job is 100. That means 10 jobs that all hit 100 have hit my 1,000 history limit, right? And if you look over here, I have more than 10 jobs. Some systems have 20, 30, hundreds of jobs that run. Some of those jobs, depending on your system, run every 15 minutes or every minute. So imagine a job that runs every minute, and maybe you have a couple of those. It's not going to take long before you have several jobs that have 100 log entries. And what ends up happening, because you're limiting the whole log to 1,000 and you're limiting individual jobs to 100, if I have 10 really busy jobs, they're going to basically be the ones that all have 100 rows per job, and that's going to basically be my 1,000. So I'm going to start overwriting and hiding important log entries potentially from jobs that run less frequently, because these jobs that run more often are overwriting and counting towards my 1,000. Okay, so this is step one. You want to limit the size of your log, and you want to limit how many you can have per job. Step two, you check this remove agent history. That's important. So now I can clean out agent history. And so maybe I'm okay with 10,000 entries or 100,000 entries. It all depends on how much size I want to devote to my MSDB database. Remove agent history older than 4 weeks sort of helps you clean up. And how that happens is it runs a job called purge history. Okay. And that goes through and it can help purge out your agent history. And it's one of the ways you can clean up your history. You can do it manually, and I'll show you that here in a second. So I'll just click OK to that. So I'm cleaning up every 4 weeks. Now you'll notice I already have an agent history cleanup job in here for distribution. This goes in with replication. So if we just look at this, it says it removes the replication agent history. So this is sort of in place. I'll double click this to show you what it's doing. This is in place to help clean up the history of just that particular job. And you can see it runs this SPMS history cleanup with a retention of 48. Okay, so that's kind of in place. Replication took care of that, and that's fine. Now, if you want to start cleaning up your own jobs at a more regular frequency, you can create a job that runs a command to help you do that. And that command, I'll look at a query here and show you, is in your MSDB database. So it's this procedure in your MSDB database called SP purge job history. And if I run this, you'll see it went and 440 history entries were purged. So now if I go look at my job history from my backup database, all gone. And in fact, if I check my job history in general, the only two here are jobs that literally just ran. Okay, so purge job history, it went ahead and it wiped out all of my job history. So that's a great thing if you have like an emergency and you need to really purge the job history. But if we take a look at this procedure, I'll just drill into our system database, MSDB, we'll go to programmability, stored procedures, and you can see some of these stored procedures. Now, some of these are user procedures, and these are not the ones that we really care about. These are DTA, permissions, things, and session reports. Not going to worry about that. I care about system stored procedures for this. So if I go in there, you can see all the system stored procedures that exist in MSDB for managing MSDB. One of them, if I scroll down here, is going to be called SP. There we go. Purge job history. And you'll see it takes parameters of job name, job ID, and oldest date. And I'm just going to drag the parameters folder up here, which will just kind of bring those parameters up so we can take a look at them. So I can write a script using SP purge job history to only purge the history of a particular job by name or by ID. And what's more, I can pick the oldest date that I want to keep. Okay, so I could then script this, and if I have jobs that I know are going to put in many, many log entries, I can put jobs in place that just basically run once a day or whatever it is and purge history from certain jobs back to certain dates. All right, so that's something that you should probably include in your ongoing maintenance, because letting these histories grow too big can certainly fill up your MSDB database. And that's really it. That's what I wanted to kind of talk through in this lesson so you can understand managing these job histories, because again, if you let them get out of control, your MSDB database can start growing, or worse, fill up, and now your SQL Server agent goes offline and your jobs stop working. So staying on top of stuff like this before it becomes a problem is certainly a priority for any good DBA. So the cost of disk space has come down substantially over the past few decades in IT, but part of your job as a DBA is still to manage that space. And databases can be configured to auto grow and take up more space as they have data added to them. You can configure them to auto shrink. And you should, at least occasionally, go in, check your databases, and see if you do need to shrink them. So this lesson, I'm going to show you how you can shrink your databases, and I'm going to talk about the auto shrink option and why I think it's evil. So let's dive right in. Here's the Wild World Importers database, which is the sample with SQL. And if I look at the properties of this, you'll see on options that it is set to false for auto shrink. This is how I recommend you treat your database. Do not use auto shrink. And the reason for that is because, and I'm not a huge fan of auto grow either, but I get it in an event of an emergency. The database is filling up. You need to have it grow so things keep working. Generally, I like to monitor my database sizes and grow them as needed. Also, shrink them as needed. If you have auto grow and auto shrink on and someone deletes some data, now your database shrinks a little bit, and then someone adds some data, maybe your database has to grow again. And it's this never-ending cycle, and shrinking and growing databases, it does cost resources. It takes time, and it's something that you want to monitor and you want to do kind of on your own terms. Now, why do databases grow and shrink? If you look at the files for a database, you'll see the size here in megabytes, right? And my primary data file is at 1024 meg, which is a gig, and my user data is at 2 gig, okay? When I establish a database and I set up a new database and give it a file and say you're 2 gigs, it goes out and it drops a 2 gig file on my hard drive. Whether there's any data in the database yet or not, it drops a 2 gig file on the hard drive. So it is taking up 2 gigs and it might not be using all that data. So as the data now fills that file, as it gets close, you'll see here's where the auto grow kicks in. So once I've used up this 2 gig, we expand the file, which gives us more room to work with. And that can keep happening. You can do that manually. You can do it with these auto grow settings. But the reverse is also true. Sometimes you size a database larger than it ends up needing to be, or maybe you've just run a big purge and gotten rid of 10 years of data from your database. And now what you'll end up with, potentially, is a large file on the hard drive, say 8, 9, 10 gigs, or I mean, it can be terabytes, right? But a huge file on the hard drive, or relatively big, and you're not using all that space, and you don't plan on using any of that space. So that's where you would want to maybe shrink your databases. Take out some of that used space and return it to the disk subsystem so other things can utilize it. So to do database shrinking, we're going to come to the database shrink command. And there's actually 2 ways to do it. I can shrink a database or I can shrink a file. If I just go right-click, select tasks, and go down to shrink, if I pick database here, a dialog box comes up and I can basically click OK on it and say, reclaim space out of my database. And it'll try to reclaim space from all the different files to get the thing smaller. If I want a little more granular control over it, I go to files. So I can say shrink files. And again, you can script this stuff. You don't have to do it manually, but we're going to look at the manual way to do it for this particular lesson. So you'll see here, it knows the database I'm in, and then it shows me the different file types. So if I click data, I see my different file groups in data, primary, user data, and the in-memory data. If I click log, I'll see my tlog files, and if I click file stream, I'll see my file stream data. Okay. File stream data, you'll notice, doesn't give me anything because file stream data isn't managed in a file like data files are. It's files on the hard drive. So I can't shrink this because it isn't a file. It's pointing to files on the hard drive. Those files take up the space they're going to take up. So what I want to do is look at data. And you'll see here that this particular primary file is a gig, and I'm using almost none of that. This is available free space. So of that gig, we're using just over like 11 megs worth of data. So I'm not using very much of it at all. And if I look at the other one, the user data file, that is a 2 gig file, and we are using a bit more there. That one's using about 400 or so meg, and it has 1600 free. So if I make the decision that, you know what, I don't have this much user data, I'm never going to have this much user data, let's reclaim some of this, I can do that. And so for this 2 gig file, we're going to shrink it down, and we have a couple of options on this, okay? option number 1, released unused space. So if I do that, it'll basically give me back 1600 meg, give or take, depends on sort of the state of your database and how fragmented things are. But in general, it's going to give me back all the space it's not using. Okay. The other option, I can reorganize the pages before releasing and then shrink the file. So with that, the top one is going to release space as it currently stands. Okay, so there might be some fragmentation. I might have some pages that aren't full, and therefore it's going to get close to giving me all my space back. But depending on my data, I could have a situation where I don't get it all back. The second option here will reorganize those pages. So it tries to make everything reorganized and put in a better order and cleaned up so I don't have sort of half full pages, and it'll get me closer to getting all my data back. But the other thing this option does is it lets me pick how much I want to shrink the file. So rather than just release my unused space, I can say, hey, reorganize it and then give me some unused space, but shrink it to a particular level. So let's do that one. And I'm going to decide that we need to shrink it to 1028. And you'll see over here, it tells you the minimum. This isn't a default or anything. This is literally looking at your database saying you have 444 meg of data in here. So you can't go smaller than that because then you're talking about deleting data. So that's your minimum for this particular file in this particular database. So I'm going to do the reorganize and release unused space, 1028, and I'll talk about this one here in just a second. And I'll just hit OK. And you'll see it just kind of goes gray and it goes off and executes. Now, depending on, again, this happens with a lot of these things we do in SQL, depending on how big your database is, how much data you're trying to get back, how much it has to reorganize, these can take different amounts of time. This one wasn't bad because we were just kind of getting a gig back and it's a small database to reorganize. So now if I look at the properties of this database and go to the files group, you'll see my user data is now down to 1028. I did 1028 instead of 1024, not a big deal, okay? So that's good. I shrunk that down. Now, there was one other option in there that I do want to talk about real quick. And so we'll go back to tasks, back to shrink, and back to files. This guy here, empty the file by migrating data to other files in the same file group. So imagine a situation where I have this file group. And remember, when I establish things like tables or indexes, I can put them on file groups. So I can tell a table, you're on the primary file group, or I can tell an index, you're on the primary file group. I can't tell the data or the table which file in that file group they belong to. So if I have more than one file in my primary file group, it's sort of a dealer's choice, right? The index of the table is going to go to that file group, but I don't know which file. And let's just assume that that file group has two files, and one's on a hard drive that's getting full. And I want to move that file. So there's some things that I can do. I can start disconnecting databases and taking things offline and moving files and then reconnecting the databases. And I can get, kind of crazy with it. I could back it up and restore it. I mean, a couple different ways I could skin this cat. But one of the ways you can do it is using this shrink. So I could go into the primary file group here and I could pick the file. Right now there's only the one. So pretend with me that there's more than one. So what I could do is take all the data in file A, that's part of this file group, and this is the one that's on the mythical filling up hard drive. I could then select this option to empty the file by migrating it to the other. And when I hit OK, what it's going to do is it's going to take all the data off that file and move it over to, say, file B in the same file group. File B, potentially on a different hard drive now, will have all the data moved over to it, and my first file is now emptied out. So essentially what I've done is I've moved the data from one file to another within the same file group. That doesn't disrupt the structure of my database. The indexes and tables that exist on this primary group still do. They've just been swung over to a different file. So that's how you can use shrink file to also empty out a file for potentially decommissioning it, taking it out of the database and no longer putting anything on it, okay? And you can see if I did that, I would get pretty much the whole file back, and then I could stop using it and therefore free up that particular hard drive that was filling up. Now, just like everything, you can script this. Again, I don't recommend scripting this to run automatically. But if I script this to a new query editor window, you can see this isn't a very complicated command. It uses a dbcc command called shrink file. You give it the name of the file, the size you're shooting for, and off it goes. So it's good to know the script, because often, especially if you're used to writing T-SQL, you can just write yourself a script and shrink your files. But you can do it through the GUI just as easily. And it's not a real common thing. Typically, your databases grow over time, but there will be situations that you'll run into occasionally where they lose data. You purge a bunch of data, or maybe you have a data warehouse, and once you've transitioned so much data into that for reporting, you get rid of the production data. But size management, both growing and shrinking, is important. So hopefully this gives you a little insight into how you can shrink a database. And also, I hope that I explained the dangers of using auto shrink well enough that you leave that alone and you just focus on managing your own file sizes. If you need to get a live look at things that are going on in your SQL Server, there's a great little tool that's included in SQL Server Management Studio called the Activity Monitor. And we're going to take a brief look at that and show you how you can use it not only to monitor activity, but to potentially solve some common user database blocking issues. So to launch the Activity Monitor, you just right-click the server that you want to look at and select Activity Monitor. And up pops an activity monitor here that looks a lot like stuff that you've encountered in Windows over the years, the task managers in Windows. And at the top, it tells you the processor time, how many waiting tasks, your I/O, and your batch requests per second. But you can see down here, I can drill in and I can get information about active expensive queries, recently run expensive queries. I can look at my data file I/O, my resource weights, and my processes. So I can get kind of a picture as to what's happening on my system. And actually, I really like the recent expensive queries. So if I scroll down, this kind of gives me an idea of things that have run. And you can see some of these columns are a little small. You can definitely size all these. But you can see like what database things ran against, what the query was that ran. And you can filter some of this stuff. So I could actually drop this down and say, well, I only care about that database. Show me my expensive queries there. And then I can look into these queries and partly, why were they expensive? Did I not have the indexes I needed to have, or users writing bad code, what have you? So I'm not going to drill into everything you can get out of this, but suffice it to say, you can get some pretty good information. Okay, disk file I/O, expensive query I/Os, the kind of weights you're experiencing. And it gives you a real-time look at what's going on. Now, the other thing you can do is you can manage certain things from in here. So you'll notice under my user processes, not only can I filter, I can right-click and kill processes, or I can trace this process with Profiler. So if I need to know what this process is doing, I can hit Trace and Profiler. That will bring up the SQL Server Profiler configured to watch this particular process and start tracing everything it does. There's a lesson on SQL Server Profiler. If you want to go check that out, that'll help you get started with that. But a common thing that happens in databases is occasionally people will write queries that get blocked, or they lock up, or they don't do transaction management the way that they were supposed to, and it starts causing an issue for other users. And so I'm going to simulate that situation and show you how you can use this tool to identify it. So I'm just going to go ahead and fire up a new query in my Wide World Importers database. And for this particular query, I'm going to begin a transaction, and I'm going to update sales.orders, and I will set the order date equal to 1/1/2022, where the order ID equals 89. Doesn't really matter. But what I'm essentially going to do is start a transaction, do an update, and then you'll notice I'm not going to commit or roll back that transaction. So what I've essentially done now is I've created an open transaction. If anybody else attempts to access this sales table, they're not going to be able to, because I have this table locked up as part of a transaction. So we're going to do just that. I'm going to kick up another query, and I'm going to select all from that table, sales.orders. Okay, and I hit F5. And as we expect, I'm blocked. Okay, now a couple pieces of information that we're going to use here when we go back over to the profile. I just want to show you real quick. In the name of the query tab, you'll see that not only does it say my username, right after that there's a little number. In this case, 117 is my session that's blocked. And over here, 110 is my session with that open transaction. Those are the session IDs, okay? Those tell us when I look at this from the server side, which session is trying to run this code. So now if I go back to Activity Monitor, you're going to see over here in my processes, I can find those particular process IDs. So here's our session IDs, and here's my 110, and here's my 117 session right here, okay? And you can clearly see that this guy, 110, which is the transaction that I left open, is running, and it is this little flag here. You can't see the full column. Sorry, these columns are a little bit crushed. Head blocker. So what that's saying, 110 is a head blocker, meaning he is at the start of a chain of events that has caused a block, okay? And he has this open transaction that's causing a block. If you look, this session, 117, is currently suspended, and it's waiting on a page lock because it needs to lock the data to start to read it, right? It's blocked by 110. That's telling me what session is blocking this guy's session. So you might imagine this user here who is trying to run this select statement calls you and says, hey, my query's hanging, I can't get anything out of the system. If they're in Management Studio, you can have them give you this little ID up here, this 117, and I can go find their process. If they're not, you can filter by like maybe their username or the database they're in or any of those other options. So if they say, oh yeah, I was working in the Wide World Importers database, you can drop this down. There you go. And then my username is this. There you go. And now I can see everything that user's doing. If they happen to know the 117, I could have filtered to that. And I can look across this row and I can see, yep, you're blocked by 110. So now I can go over to 110 and I can take a look at the details and I can see what he did. And you can see very clearly here, he began a transaction, he did an update, and he never closed his transaction. So from the administrative standpoint, if I come across this particular issue, I would have a couple of options. One, I could attempt to get a hold of this particular user, and if it's a system account, maybe it's get a hold of the person that runs that system. And this one's fairly blatantly obvious. I could say, hey, you did an update and you haven't committed or rolled it back, so you're blocking everything. Please fix it. But if it's a longer query or it's doing something, I would want to get in touch with them to make sure that they can either finish it up or do it at an off hour if it's really that expensive and it's causing all this blocking. So the other thing I can do as an administrator, I can make the decision that, no, this guy's process has been blocking for too long. I need to get the system moving again. And these things can stack up. In this case, I have one update blocking one select. But in a real production system, this kind of stuff can stack up and start causing timeouts on queries and all kinds of stuff. So from this dialog here, there's a kill process button. Or from here, I can right click and hit kill process. And I'm going to do that. And it says, are you sure? And I'm yes, I'm positive. And it'll take it a second here. And if I refresh this, eventually what you should see is this guy goes away. There it went. And this other guy no longer is blocked. So 117 no longer has a block. So let's go look at what happened to our two processes. One, you'll notice that 110, it still just says one row affected and begin tran. So me sitting in front of this, I don't really know anything happened. Now, I still look connected. I could potentially, let's see what happens if I try to run another query. That's where all of a sudden they're going to get a notification. So I tried to run a query and it actually came up and said that the connection is broken and you can't recover. So basically it now understands that it's been disconnected. So when I click OK here, you'll see my status changes to not connected. And then if I need to, I can come back over here and I can reconnect my query. Okay. Now, 117, the guy who was getting blocked, if we come over here, you'll see he finally was able to get his results back. All right. So we were able to sort of use Activity Monitor to figure out what the problem was and make a decision to kill another process. And again, that's not the only thing you can use this for. If things are getting busy, I can look at which files I have that are really hitting hard. Like, am I running up disk IO? Do I have active expensive queries? Do I have waits? So you can get a lot of good real-time information out of this Activity Monitor. How you use that information is really up to you and up to what you're trying to do in your systems. But hopefully you can see that the Activity Monitor is a decent little tool for getting quick information and possibly helping you resolve some data contention issues within your SQL Server databases. So if you've worked with Windows for a while or done any Windows administration, you're probably familiar with the performance monitor tools that are built into the Windows system. Specifically, the performance monitor, which we're going to look at because it can be utilized not only to watch Windows resources, but also to look at SQL Server resources to get an idea of how things are operating inside your SQL servers. So for this lesson, I'm actually going to fire up perfmon, which is the performance monitor. Okay. And up this comes, and again, if you've worked with Windows, you've probably at least been in here. And if I click on Performance Monitor, I get this graph. And this is real-time information showing me these counters that are configured down below. Now, I can put in things that are pertinent to Windows. In this case, this is showing me my processor time. But alongside of Windows counters, you can also put SQL Server counters in here. Okay, so once you install SQL and install the counters, those things become available. So if I click Add up here, it'll go out and look at the computer and it'll give me all the things that I can monitor. And again, this is a lot of things for memory and Windows processors and all this other stuff. But if you look, there, and I even have SQL Set 2017 counters on here, but under SQL Server 2022, there is just a ton of things that I can monitor. So I could pick transaction log here, and then you can see I can look at specific instances of SQL and look at their transaction logs. So I'll just click all instances and then click add, and now I get to add that to my trace. And maybe I want to look at something else specific, so I can go down here to a specific SQL server, such as my inside out SQL Server, and this is the agent you can see here, and I can look at jobs. So I could expand this jobs node, right? And I'll click this so you can kind of see. And I can look at active jobs, failed jobs, a job success rate, queued jobs, whatever I want to do. So we'll just click failed, and we'll add all instances of that to the list and put it over here. And again, the list goes on and on. I can look at SQL Server availability groups. I can look at replication. I can look at IO stats. I mean, there are literally hundreds of counters. I can look at mirroring, all kinds of stuff in here. So I'm obviously not going to dig through them all. I just wanted to give you an idea of how you can start to look at these. But if you have specific things you're worried about, locks, latches, blocking, your procedure cache, any of that kind of stuff, you can use these counters and you can look at them alongside Windows. So to that end, I'll also just take a quick look. Let's pull up our, not SQL agent, but our SQL Server 2022. Here we go. So anyway, there's a lot of these different things you can add, and we're not going to do them all. So we're just going to look at the ones we've put over here in our added counters window, and I'll hit OK. And now you can see that has come up and it's put some more data into my log reader, and it's starting to chart that data for me. I know my processor time, that's a Windows counter. But then for my SQL Server inside out instance, this line is giving me my log records written per second in my log and my log bytes written per second. So I know how many bytes and how many records are going into my log. So I can sort of monitor overall activity, right? How much stuff is going on and into my logs in my SQL Server. Down here, you'll see the breakout for 2. And then down here, you'll see the breakout for total, which is sort of everything added together. I also added some job stuff. And so you can see here, failed jobs is an option that I'm now tracking. Alerts, schedules, and then obviously the total. Now, if you've worked with this in the past, I don't know if you know this tip or not. So if you pick a particular thing in addition to the color coding and hit Control H, I can highlight that particular line. So this one wasn't very exciting. It's the one that's bottomed out. But I could click processor time, and now that the highlighter's on, you can see just that line in a very dark, bold way. And this is really helpful. Like, for example, I personally am colorblind, and so for me to look at this line up here, to me looks orangey yellow. I can't really match that. But with my highlighter on, I can kind of click through here, and then there we go. Eventually, I come across a job, it's failed job schedules that has a highlight. So I now know what that is. Now, this course is not about how to use the Windows Performance Monitor tools. It's really just to show you that we can add SQL Server Performance Monitor tools into this. And there's a lot more that goes into this tool, and there's a lot of other ways you can leverage it. And something that starts to become pretty helpful is if you can compare things like memory usage in SQL to memory usage in Windows, and processor usage in SQL to processor usage in Windows, and really start seeing those, how they compare to one another and how much percentage your SQL Server is using. Again, you can also monitor I/O, so you can look for hotspots on your disk. You can monitor your plan cache, so you know if you're having a lot of issues with your procedures. You can monitor sizes of things using these tools. It's pretty cool that you can get in here and do this kind of stuff. And again, this was just a real quick view. I wasn't intending to teach you how to use Performance Monitor, but I did just want to make you aware that all these counters do exist from SQL Server that you can put into your Performance Monitor, and hopefully that can help you get more insight into what's going on in your systems. Database logs play a very important role in keeping your SQL servers up and running. The log files in databases, they're not logs like a Windows log. They are temporary storage sort of for processing transactions. Okay, transactions get processed through the log, and eventually they get checkpointed and moved down into the database. It's a way for us to do recovery because we can back up these logs, but they're vital to the function of the system. If the log fills up, the database will stop functioning, okay? And a lot of times people will turn on autogrow to help prevent that from occurring, but autogrow can be kind of a pain because let's say your backup jobs go offline and now your log file grows until it fills the hard drive. Or even worse, maybe you have a database that you set the recovery mode to full, which means use the log, but you didn't set up a backup job. So again, this log could auto-grow until it fills up the hard drive. Now, logs are definitely something you want to keep an eye on. You want to monitor their size, and they're something that you tend to size for potential need. So with a database, you're usually pretty good about saying, okay, I get 20% growth in this database every year. So I'm going to make sure I have 20% of headspace and I can grow into that headspace over time. But a transaction log and how much space it needs is sort of dependent on what's your largest transaction, right? Or what's your largest batch that can occur within a period of, say, 15 minutes or 30 minutes or however long between your backups. So there might be times when your log is at 0% for hours, and then one big transaction runs and it fills up the entire gig, 2 gig, 3 gig, 8 gig, however big your log is. So you want to make sure you're sizing for that potential max growth. Now, you also do want to keep an eye on these sizes regularly and manage them by growing them if you need to, possibly shrinking them, maybe adding additional ones. And there's a few tools in SQL that let you manage your log file. And I'm going to show you a couple real quick. So the first way I can check my log file size and usage is if I just go to my database and hit Properties. Here on the Files tab, I can see how big my log is, right? 164 meg. I can't see how much is being used in that particular file, but I can see the overall size. You can, if you really want to backdoor it, you can go into the shrink command, which again, I don't recommend doing this, but I just want to show you that that information is available. I could pick my log in here and it tells me that I have 57% free. That's not very helpful either. And there's a couple ways you can do this through T-SQL. I'm going to show you the cleanest one in my opinion, and then you can kind of adapt this for whatever you need. So I'll start up a new query. and I'll stay in my wide world importers database, and I'm going to run a DBCC tool, DBCC, and I'm going to run one called SQL Perf. Okay. Now this needs a parameter to know what I want, and what I'm looking for here, and you pass this in as a string, is log space. Okay. So DBCC SQL Perf log space, and when I run this, this kicks out a complete list of all my databases, all my log sizes, and all my log percentage used. So I can just go run this on my server, or I could run this in an automated fashion through a job that then looks at these percentages and notifies me if I have an issue or if I have a log file that's getting too full. Okay, so you can utilize this information to help you sort of keep an automated eye on your logs. And if you're using AutoGrow, at least you can keep an eye on how big your logs are getting. So you could have this sent to you in a report once a day, so you know your logs are growing. And if you're not using AutoGrow, then you would definitely want to keep a close eye on log space used, right? Log space percentage used here. Because without AutoGrow, if this number hits 100, your database is going to go offline. Okay. Now there's a couple other stored procedures out there. SP space used. There's some system tables you can query. There's a lot of other ways that you can actually get at this information, but I'm not going to go into all of them. Those are real quick internet searches away, and you can find all those other options. I just want to show you DBCC SQL Perf log space as a quick, easy, efficient way to be able to capture your current log space sizes, log space utilization, and then you could then massage this into a report that runs via a job or some other method. So hopefully this will help you keep an eye on your log space utilization. Sometimes in the course of managing your SQL servers, you're going to have to make some decisions as to when you can allow the server to run at basically full speed. So there's times where maybe I want to run maintenance and I need to limit the amount of resources that users can use, or just sort of slow the server down for whatever reason. I mean, it's not super common, but SQL Server provides a way to do just that, and you can govern resources using the resource governor. So the resource governor is what we're going to take a look at in this lesson. So to find it, I'll just come over to my SQL Server instance here, and under management, there is a node called resource governor. I'll expand that, and underneath there is a node called resource pools. And this is what we're going to look at setting up in this lesson. I'm just going to right click and select new resource pool, and then I'll just make this all gigantic so we can see it. And you'll see here what I can set up is I can set up various pools and work groups and external resource pools, right? But what this does is, let me expand these columns so you can see it. This allows me to tell SQL Server what the minimum and maximum CPU and what the minimum and maximum memory it's allowed to use during certain times. So if I need to slow this thing down, like again, SQL Server is kind of a resource hog, right? It'll take as much memory and it'll take as much processing power as it can. So if I need to slow this down at certain times so that I can do system maintenance, I'm able to do that using resource pools in the resource governor. So step one for this is I have to click Enable Resources. And you'll see here that there's a default and an internal, and then I can start adding pools, okay? And what I want to do is I want to add a pool here called After Hours. And essentially, what I want to happen is I want the SQL Server to be limited in the resources it can use at certain times, okay? So we're going to go over here and say the min CPU is 0, that's fine, but the max is 50. And then same for memory, the max is 50, all right? So what we're going to do next is we're going to define how we define these pools. To do that, you need a classifier function, which is up here. You'll notice that when I drop this down, I don't have any classifier functions. So I have to go create one. And what a classifier function does is it's called, and it's the thing that tells resource governor which resource pool I'm using right now, okay? And it doesn't know that otherwise. So I've made this after hours pool, but now we need to tell it when to use this, all right? So what I'm going to do here is just click OK so that this is saved. And then I'm going to flip over to an article from MSDN that I recommend you look at if you start playing with Resource Governor. And it's this article here, and it tells you the benefits and it tells you some of the things you can do. But what this article also has, it's very helpful. If you scroll down toward the bottom here, in these tasks, you will see links to other resources. But right down here under recommended content, this is really what we want. Create and test classifier user-defined function. So this particular article here will help you create a classifier function. And the way they do it in this article, here's the script to set up their resource pooling. Okay, we did that through the GUI, so I'm not going to worry about that. Then here they set up a table. And what they did is they set this table up to have a group name and a start and an end time. And then into that table, they can insert values and then give it a time range. So in this case, 6:30 to 6:15. Okay, we're not going to do the table because I just don't want to go through the process of setting all that up right now. But they also put this classifier function in place. And this I am going to steal. Okay, so I'm going to copy this particular code and paste that into a new query. Okay. So I'll paste that in here. I'm also going to steal this code, which registers the classifier function. All right, copy. And I'll just paste that down below. So let's look at what this does, and then let's steal it kind of for our use. So you'll see here, all this has to do is return a string, which is the group name, okay, of the thing that you want to use. So when we looked at our resource governor, if I look at this resource pool, so if you look at our resource pools, you have to just click the little black arrow until the whole row is highlighted. It's a little fiddly, but that's how you can delete one that you don't need. So we have after hours, and then we have default. So these are the two that I really care about. This classifier function needs to return me after hours or default to let me know that that's the resource pool I should be using. So I'll minimize this, and we'll look at their function. And you'll see all it does here is return a string. It goes through all the work of getting the data from the table and everything else. We're not going to do any of that. What we're going to do is we are going to look at the logon time. That's fine. Okay. And then what we will say, and this is at the logon time of the session, we'll just write our own little code. And we'll say if the logon time is greater than 6:15 a.m. and the logon time, I forgot to close my string there, and the logon time is less than 6:30 p.m., so similar to what they were inserting in that table, then begin, and we will return, so just like this, where they return their string group, we will return default. Okay? And actually, I need a single tick. There we go. So we'll return default. So that will tell it to use this default resource pool. Okay? Now, if the time is not between 6:15 and 6:30, right? So outside of these hours, that's when we're going to return after hours. So I'll just do else. I always do the begin end. You don't have to, depending on how you're writing your code, but I like the begin end. It helps me bracket my if then statements. I will return, or after hours, right? Okay. Then I'll get rid of their select because we don't care about that. And good. Now, I'm going to leave this return here. And the reason I'm going to leave this here, if I take this out and I attempt to create this function, actually, it's not even going to let me create it. You can see here, the last statement included within a function must be a return. Okay. Even though, if you look at the logic of this function, if the logon time is greater than 6:15 or less than 6:30, I go here. Otherwise, I go here. So there's no way this can ever get down to this particular line. I will shortcut it with one of these returns. However, the compiler needs to see the last line of a function being a return. So we'll return this string, and that string will never actually get hit, so you'll always return either default or after hours. So we'll highlight this and we'll create the function. And it's done. Okay. Now we will go down here and we will alter our resource governor and we will make this the classifier function. Okay. So we'll do that. I'll hit execute. Oh, yep. And so this is something I missed and I forgot to mention, and I actually left it in the wrong thing. Any of your classifier functions have to be in the master database, right? When I created this, we were still in the worldwide importers, because that's where I started my query. So I'll switch this over to master, and then I'll rerun this to put my function in master. Okay, so all classifier functions must exist in master. And then here I'll go ahead and register it. Completed successfully. So now and I'll close this and reopen it. Now you'll see at the top of my resource pool for my resource governor, I have that time classifier function. So that time classifier function will be called. It'll know whether you're coming in default or after hours. And if you're after hours, you'll get a maximum CPU and a maximum memory load of 50%. Okay? So that is just sort of a quick dip into this. That MSDN article out there, just called Resource Governor, is a good resource if you want to start looking at maybe doing some internal or external pools. You can do some max degree of parallelism limitations and stuff down here. So there's some other stuff you can govern, and there's some other stuff you can manage with the Resource Governor. But I just wanted to show you, A, some of the things you can do and how you can set up these resource pools, and B, how you create that time classifier function. So you can either do what we did here and have if-then statements, or if you want to go with the full-fledged table like they did in the article, it's not a bad way to go if you're going to be adding or changing those times, for example. Because now I could say maybe after hours shifts on the weekends. And so when I look at the login time, I might look at the date and I might look at the time. So it can get as complex as you want, as long as your classifier function ultimately returns one of the names of these resource pools. You should be good to go. So again, if you have a need to use Resource Governor, hopefully this gets you started down the right path. Welcome to our lesson on automating SQL Server administration. Some parts of SQL Server administration are pretty mundane and repetitive. That doesn't mean you can ignore these tasks, nor does it mean you should sink hours every day into doing the same thing over and over. Being a good administrator means looking for opportunities to automate any tasks that you can. This lesson covers understanding the components of SQL Server automated administration, setting up database maintenance plans, and using PowerShell to automate SQL Server administration. Let's get started. So obviously there are a lot of moving parts in SQL Server, and there are a lot of things that you as a database administrator have to do to keep your servers functioning and healthy and happy and making sure they don't crash and making sure they run efficiently. So index maintenance, database backups, statistics updating, all this stuff that has to be done. And I know that you don't want to sit around all day and monitor the stuff with scripts or monitor it manually or do backups manually. Obviously, that's out of the question. And so as with any sort of administration, be it Windows, SQL, networking, what have you, you want to do as much automation as you possibly can. So we're going to look at the built-in engine in SQL Server for automation. And again, by no means will this be your only possible avenue to automating SQL Server. You can write your own stuff. There are third-party tools galore that can help you with this. But we're going to look at what's built into SQL and then show you how you can leverage that to automate your administrative tasks. So right here is the SQL agent. And we did a lesson on automating backup jobs, and I'm sort of going to pull from that a little bit because those jobs are still here, but talk through what the SQL Server agent is. So essentially with the SQL agent, it's another service that runs aside from your SQL Server. And it uses the MSDB system database. So when you see the MSDB database, that's mostly your SQL Server agent stuff. But underneath here, you can see I have jobs, I have alerts, I have operators, I have proxies, and then I have logs. These error logs are just basically the SQL Server agent error logs. So if you need to look at something happening with your agent, you can look at these logs. But this is the basis of the built-in administration automation engine. And it's not just administration, to be fair. You could use it for automated data imports or automated whatever, right? It's just jobs that you can run that can do things. So let's just take a look at one, and then I'll show you some of the options available. And we'll start with jobs, and I'll talk briefly about alerts, operators, and proxies. So I'm just going to open up this backup database job, which is a full backup job that does a backup for the Wide World Importers database. On the general page, I can provide some basic information about the job, the name, the owner, the category, give it a description, and then you can see when it was created, modified, and at last ran. I can also disable the job from here. I can do that by right-clicking it as well. So if I want this job not to run for a particular period of time, I can disable it, and I can still leave all the other settings alone. The job just will no longer run. So that's the overview of the job itself. But what is this actually doing? So there are steps in a job, and this is the meat and potatoes of a SQL Server agent job. You have these various steps. So this one you'll see is just a one-step job, and it's called step 1. That's the name of it. And the type over here you can see is transact SQL script. Okay. I can edit I can add steps, I can edit steps, I can skip around what's the start step, and I can do all this other stuff in here. I don't have a whole lot of multi step jobs, so we're going to kind of create one here just to look at how this works. So this first step here, if I double click it, it comes up and you see it has a name and it has a script, and it executes, in this case, in the context of a database. But I want to give this a name that makes a little bit more sense. So I'm going to call it backup DB. Okay. Now you'll see there is a type here. So SQL Server agent jobs can run one of several different things. In this case, it's T-SQL, but I can also run stuff on the operating system through like a command line. I can do PowerShell, and then some of these are set up to be able to set up replication jobs. I can do analysis services commands, analysis services queries, and I can run SSIS packages right from these jobs. Okay, so lots of different options. And I mean, and if you go down to running an operating system command, that could be calling a custom executable that you wrote in C#, and it can go off and do stuff. So you really can do a lot of things with a SQL Server agent job step. So for this job, I'll have this do backup database. All right, and I'll just click OK. And then I'll add a new step, and I don't know, for this other step, we'll do update stats. And this isn't necessarily a real routine that you would put together, but you know, it's something that we can set up just to sort of show how this works. So say I have a table that is sort of finicky with stats, and I just also want to update the stats on that table every time I do my backup. So here you'll see I can run another T-SQL command. I'm going to run update statistics on sales.orders. And this could be multiple tables. You can write a whole script in here. This whole window is available. You can hit parse to make sure that the command is good. And you can write anything in here that you could write in like a T-SQL query window. Okay. Now for this one, I want this to run against my worldwide importers database and update the stats of that table. And again, this is not necessarily something you'd set up, but it's just how I'm going to show you this multi-step thing. Okay. Now every job step also has this advanced tab. This advanced tab controls how the job step interacts within the greater scope of the job. Okay. So you can see on success and on failure, what does it do? And I can also set up retries. And then what's more, I can output and log stuff from this job down here. So for now, I'm just going to click OK, and I have two jobs. But you'll notice this first step, which was already here, on success is set to quit the job and report success, and on failure is to quit the job and report failure. So if this step is the one that starts the job, so if you start the job at step 1, which is currently how it's set up, step 1 will finish, and it'll either quit the job, success, or failure. okay? And in fact, if I click OK, it's going to yell at me and say, by the way, you have this job step that can't be reached. Is that what you meant to do? So there's a nice little check here, just in case this is not what you meant to do. And in this case, I did not. I want to hit this job step. So I'll say, no, this was not my intended behavior. It takes me back to my job. All right. So I can double click this job step, this first one, and I can go to advanced. And what I can do is I can say on success, I can say either quit reporting success, or you can actually quit reporting failure. You can say go to step 2, or you can say go to the next step. Now, in this case, go to step 2 and go to the next step are functionally the same. The difference is if I say go to the next step, and then I add a new step between step 1 and 2, this one will still go to whatever immediately follows it, okay? If I say go to step 2, update stats, then no matter where I move that update stats step, that'll still be the thing that gets called after step 1. So you use 1 if you just want to execute everything linearly, and you use the other selection of update or go to a particular step if you possibly need to jump around. Like maybe you're making an if-then sort of logic situation where after step 1, if it succeeds, go to step 4. But if it fails, I actually want you to run step 2. So you can kind of build that in. So for the case of this demo, I'm just going to say go on to the next step. Now, the other thing I could do is I could say, hey, if this step fails, I need you to retry it. So if you couldn't back up the database for whatever reason, go ahead and retry it. I'll say retry once, and your retry interval 10 minutes. I'm sorry, 1 minute. So it'll wait a minute, and then it'll retry. Or I could leave this at 0, and it'll just retry. If it fails, it'll just retry. Now, if it fails this step, what do I want it to do? So again, I could report success or failure, or I could go to another step. So if the job is built in such a way that if any step fails, you need to quit and report failure, you can go ahead and leave this the default, which is quit job, report failure. If, however, you have another job step maybe that could potentially correct your failure, you could say, well, don't quit reporting failure, go over to this other step. And that other step could be running an external process. It could be doing anything. So I'm going to leave it quit job, reporting failure. And I'll hit OK. Now you'll see that my job has on success for the first step, go to the next step, on failure, quit, and my second step has that exact same thing, okay? So now when I hit OK, it goes ahead and yells at me again. And this time, it's because on my last step in my job, it's going to change go to next step to quit with success. And that's sort of a default behavior. I don't have to do that. But what's asking here is this the intended behavior? And it's saying this will change it. So if I say no, I'll go back and get to edit it. If I say yes, then it's happy and it saves my job, but it did make that change. So if I go back in and look, you'll see my last step on success actually quits with success. So I can edit these different steps. I can move them up and down using these move buttons down here. I can insert steps in between these. I can basically create this whole tree of different steps that have to run in order to do whatever it is I'm trying to do for my administration or my imports or whatever. And that's basically a job. Now, the other thing you obviously have to do is schedule it. So if I come to the scheduling tab, you'll see I can add schedules. You can pick from your shared schedules from other jobs, right? Or you can add your own, and you can have more than one. So in this case, I have a schedule called Daily Full Backup, which when I open, basically recurs every day at midnight, okay? I can enable or disable this schedule. So that's the job can stay enabled, but I can disable the schedule. And why would I do that? Well, if I hit cancel, you'll notice here I can add new schedules. So I can have multiple schedules that this job runs under. So I might say, hey, there's a Daily Full Backup, but I also want to do one at noon on the first day of the month. So I can add another schedule for that, okay? So you can add different schedules to have this job run at different times. And then if I disable one schedule, the others can still run. If I want the whole job to be disabled, I can disable the job, okay? So you make your job, you make all your steps, you schedule it to run, and you're off and running. Now, two other things. You can have this job raise alerts. So here's this alerts tab. And you'll see there's an alert list. I can click add. and then I can create an alert. Okay. Now alerts are another thing you can do with your SQL Server agent over here. There is a folder for these. So I can create a SQL Server alert event, a SQL Server performance condition alert, or a WMI alert. And essentially what I can do is I can say, here's the name of my alert, here's the error number, here's the severity, here's the database I want you to pass in as part of the information. And I can say, if something happens with my job, I can raise an alert and I can say, hey, this happened. I don't know what it is. Database backups are failing. I could raise that alert. That goes into the SQL Server system, and then you can respond and react to those alerts. Okay. So this first page just lets you set it up. You can give it a name, a type, and specify severity. This response page is what happens when this alert gets raised. Okay. So you can see it's grayed out here to execute a job, because what this is doing is saying, if this alert occurs, run this job. So because I came into it from this job, that's what it's assuming I want to do. So it's basically going to execute this database backup. So I could, for example, have a job that monitors my log space. And if my log space is getting too full, I could raise an alert saying my log space is getting full. That alert could then run a job that backs up the log. So you can start chaining these things together through alerts and notifications. Speaking of notifications, I'm also able to notify operators when this alert occurs. And I'll come back to operators and alerts in just operators and notifications in just 1 second. Options here, I can include the alert error text if I email or page somebody. So that's if I notify. And I can also add a little additional message. So in addition to saying, hey, this alert occurred and here was the error, I can add another little message in there, okay, for the notification. So I'm going to cancel that because I don't want to set up any alerts and run this job when an alert occurs, but you can do that. I just want to make you aware of what those alerts are. And then finally, notifications. With notifications, I can send something out to people if the job fails, succeeds, or completes. And right now, this one is set to email me when the job fails, succeeds, or completes. Okay. In addition, I can write to the Windows application event log, or I could automatically delete a job. So sometimes you have a temporary job that you're like on the 13th of next month, I need to go do this thing, but I'm never going to do it again. So when it succeeds, delete yourself or delete another job. Okay. So that way you don't have to worry about going in and cleaning it up later. Now, targets is part of multi-server administration. There is a lesson on that. So if you're curious about how that works, come back and check out the multi-server administration lesson we're going to do. So I'm just going to close this job out. And I just real briefly want to talk about the last couple pieces of SQL Server Agent. You have alerts, which we talked about. So alerts can be raised. And in this case, there are some that are already configured, like I had a problem with my log shipping or my replication got slow. You can create your own alerts and you can raise them at different times. And then those alerts can trigger jobs, as we saw before. Operators are essentially a collection of people that you can notify. And you can see they get a name, an email, and a pager email. So really what they get is 2 emails. And then they get a pager on duty schedule. So what days do you want them to be notified? And if you attempt to notify this user and they're not inside these windows, they won't get notified. So you can set the times they work on the weekdays, and Saturday and Sunday you can set independently. And if they're inside these times or on these days, they'll get notified. And if they're not, they won't. Okay. You can also click the notifications tab and you can see what things, alerts, and jobs this particular person is set to be notified on. You can see, just like when we looked at the job, this shows that my operator is set to be notified for that backup job. So on the backup job, we saw my operator. Here we see it the other way. And then last but not least, history. So you can see the last time they were emailed or their pager was emailed. All right. So that's how you send notifications out to your people. The last little bit here, proxies. So with proxies, these are accounts that you can set up to run jobs under a particular context. So say I have to go out to a share on a network and grab some files. Well, the agent account either has to have access to that share, the account running your SQL Server agent. But if it doesn't, a better practice is you have a proxy account that you can set up and configure, and the job can run as that proxy account. Okay. So You'll see I don't have any unassigned proxies. So I'm just going to show you real fast. I'm not going to type all this in, but you can see I can just set up a proxy and I name it. So I give it whatever name I need to give it, file, share, access account. And then the credential here, if I click it, you can go select, say, a Windows account, for example, and that can be stored as a proxy. So now my Windows account is here, built into the system. So say I added my personal Windows account. I'm not going to put that in, but say I did that. Now you can activate it in certain subsystems. So I can say it's allowed to be used for operating system commands or for PowerShell or for whatever it needs to be used for. And then that account can be assigned to jobs. And I'll share that real fast. So if I come back to my job activities, here we go, my backup database job. Right here under steps, if I go to backup DB, you'll see I can pick run as. And here I would be able to pick any proxy account that I had set up that's assigned to being able to run T-SQL scripts. Now there's some here already for like replication distributors and replication merges. And so you can see if I tell it I'm running a replication distributor job, I can run as the SQL Server agent service account. So that's running it as that account. So that proxy is sort of already in place, okay? I didn't have any for the T-SQL, so those weren't showing up. But that's how proxies work. They let you run steps as another account, and just the context of this step runs as that account, not the whole job. So you can do things to get to secured items by setting up proxy accounts, okay? So the sky's the limit as to what you can put in here and what kind of jobs you can automate and tasks you can automate. And the only other thing that you'll probably spend some time in if you're using SQL Server Agent is your job activity monitor. So I'll just double click that, and you can see here, this has the status of all the jobs that I have configured on this machine, whether they're enabled or not, what is their current status, and most of these are idle. And you can see what was the last run outcome. So this one succeeded. When was it last run? When will it next be run? And what category is it in? So then I could filter these jobs by category, by enabled, by last outcome, if I have a lot of them. And I can start looking for problems. So I could see here, for example, these jobs failed the last time they ran. So that's something I might want to go look into and figure out why these jobs are failing. These jobs are executing. Are they supposed to be always running? And in this case, these are replication agents, log readers, distribution agents. So yes, those are supposed to be running, so that's just fine. But the job monitor, job activity monitor, is where you can go to see all the history about your jobs at a high-level overview. And then individual histories of jobs you can get on the job itself. So I could look at my backup database here, and if I right-click, I can get history, and that would now show me, and I've deleted it, but that would now show me the entire history of this job. Every time it's ran, at least until the history gets purged, every time it's ran and what was the outcome. Whereas this here just gives you sort of the last run and the next run, okay? So the job activity monitor is how you can keep an eye on that. So again, there's a lot you can do with a SQL Server agent, and I'm not gonna just sit here and start creating jobs, but within those categories we saw, T-SQL, PowerShell, command line stuff, you can automate a lot. And if you start using some of the functionality of alerts to trigger jobs and get your job step ordering in the right way, you can really build a fairly robust system using just the built-in administrative tools that are provided for free-ish, as part of your license to SQL Server. So a few of the lessons that we've gone through have looked at how to set up automation, backups, do index maintenance, and all that kind of stuff. And while you can set all this up with SQL Server agent jobs to do like your routine maintenance, Microsoft provides a little tool called Database Maintenance Plans that is actually sort of piggybacked on SQL Server integration services that allows you to really do some custom maintenance in a very clean way without having to write a bunch of your own scripts. So we're going to take a look at that because I think they're very powerful and very useful for DBAs. So to find them, if you go into the Management folder, you'll see there's a Maintenance Plan folder. And if I expand that, you'll see I don't have anything underneath it because I have not created any maintenance plans. So we're going to create our first maintenance plan now. So to create your first maintenance plan, right-click, and you can either go through the plan wizard, which will ask you a bunch of questions about the kind of maintenance you want to do, or you can just create one from scratch. We're going to create one from scratch just so I can show you some of the options and show you how it all fits together. So this comes up and it wants to know the name of this plan. So I can name this like this is my database backups, or this is my database integrity checks, or whatever I'm trying to do. For now, I'm going to leave it just generic and call it maintenance plan. And I'll click OK. So then this designer comes up, and essentially what we have here at the top, you'll see I'm in my maintenance plan and I'm in the design view. I can add subplans, and the subplans are here, and they can have different schedules. And this whole gray area down here is a canvas. And on this canvas, I can drop tasks that I want this maintenance plan to perform. So over here in the toolbox, I open this up, and I'll just pin it. And I'll unpin Object Explorer just so we have the whole screen. Here are the things I can do in a maintenance plan. I can back up databases, check integrity, execute jobs or T-SQL statements, clean up history, clean up my maintenance history, notify an operator, rebuild, reorganize indexes, shrink databases, and update stats. Okay, so those are the things I can do. All very common administrative tasks. So let's start by saying I want to check my database integrity. So I grab check database integrity and I drag it over here. You can see my icon is turned to a little plus. When I let go, this box drops on. Now, you'll see it has a big red X on it because that means it hasn't been configured. Also, I want you to notice that I'm only using one subplan right here. So it's subplan 1. You can create multiple subplans. So for this, what I actually want to do is let's double click this subplan and change it to check DB integ. Okay, and it's just our check DB integrity subplan. And I can schedule this to run whenever I want. Okay, now we'll configure it. So we'll double click it. And essentially, for this particular task, what I have to tell it is which databases I want to check. You'll notice I can do it on my local server, or I could connect to another server. So you can do database and integrity checks and some of these maintenance tasks across multiple servers by connecting to them here. So I'm going to select one or more databases, and in this case, I'm going to say all. So just run integrity checks, which is like a DBCC check DB, run that on all my databases. Alternatively, I can say all system, all user, or these specific, okay? I can also say ignore databases where the state is not online, and I will do that because if I have a database that's in recovering mode, I don't want it to try to do this because it could cause the whole plan to fail, and then I won't be able to check the rest of my databases. So I'll say, okay. Now you can say, what am I checking? Am I going to look at indexes, just physical, and then I can set max degrees of parallelism to try to limit this to how many threads or how many degrees of parallelism are allowed to run for this process. And I can do a table lock, which as it's checking things will actually lock things up. I don't want to do that. I just want to let it be. And if you're curious what this is going to do, you can hit View T-SQL, and you can see here it's going to do DBC check DB master physical only, model physical only, and it'll go through and run that DBCC check command on all those databases. So I'll hit OK. And that's all there is to it. Now, in this case, on demand, but if I were to set up a schedule here, this subplan will run on that schedule. Okay? So now I can add another subplan, and I'll call this one backup. And we'll actually call it backup full. And again, I'm not going to schedule it right now. It'll run as the SQL Server service account because that's the default. You can add other proxies here. I just don't have any, so we're going to run it as a SQL Server agent account. And I'll hit OK. And now you'll notice I'm in another subplan. I have a nice new canvas. So now I can drag in the backup database task. I can double click it to configure its settings. And it's similar. It wants to know what databases and what backup type, right? So I can say do full database backups on all my databases. I hit OK. And backup to disk or tape or URL, kind of like configuring a backup. And then destination. So where are these things going to go? So right down here, you'll see that by default, they want to go to my backup folder. But unlike a standard backup where I would say to this file, what I can do here is say create a subdirectory for each database, for example, and the backup extension is back. So what it'll do is in this file, it'll create a folder called master. It'll create another folder called MSDB. It'll create another folder called wide world importers. And inside of that, you'll get backup files for each of those databases. So it kind of manages the name of those files in those subfolders for you. Alternatively, I don't have to make the subdirectory. I could just dump them all into this high-level folder. Also, if I wanted to, I could come up here and say backup my databases across files. So I could actually say, here's 6 or 7 backup files, stripe them out to these different files. So I have a little bit of control if I want to go directly to files. Typically, I use this option and throw them into a subdirectory. Now, options over here, this is like the media set options that you can set on a backup. So you have control of all that stuff. I'm going to leave expiration and all the checksums and everything else alone. And I'm just going to hit OK. And then there's my database backup task. So this is going to do backup full. That can run, and again, I'm not going to schedule these. I'm just going to let them stay on demand. But I could have that run, every night at midnight or something along those lines, okay? Now, what if I also want to do transaction log backups? Well, I can add another plan, and I could do T-log backups. And I could add another plan, and I could do whatever. But the other thing you can do, and if they're diverse tasks like a backup full, you usually don't do a backup full followed by a T-log. So you would probably separate those into different subplans, so I could schedule them differently. And you'll notice that I'm in one maintenance plan here, yet I can have multiple schedules. Unlike a job where one job runs at a particular time and does its thing, I can have the backup task in this subplan. This subplan almost becomes like its own job, right? It does backup database at this time. I can link these together, however, in a single subplan. So what I can do, so I'm going to come back up to this first subplan, and instead of just CheckDB integrity, I'm going to call it CheckDB, just CheckDB stuff. And after checking the database integrity, I also want you to go ahead and clean up some history. So I can drag this onto here, right? And I can take, if I click on my integrity, you'll see this arrow pops out the bottom. Got covered up, there it is. I can grab that arrow, if the little thing would stop popping up, there we go. I can grab that arrow and drag it to the history cleanup task and let go. And now I've created a flow. So it'll check the database integrity, then it'll come over here and do history cleanup. So you could double click this, you can see what it's going to do. It's going to remove backup and restore history, agent job history, and maintenance plan history, anything older than 4 weeks. So this is a good thing to do. It keeps your logs cleaned up and you're not just storing a bunch of old information about job histories. So I'll hit OK on that. And then after that, I might decide that if my integrity is good and you've cleaned up my history, let's go ahead and reorganize some indexes. So this could be something you run, I don't know, once a week or whatever. And then I drag into the reorganize task. I double click, and this one, just similar to the others, which databases. So I could just do, say, the wide world importers database. I hit OK. What I want to do is it tables and views, or views. I'll do tables. And then here I can select one or more. So I can just say, you know what, do all tables, and I can hit OK. Then I can choose a few other options. We had a lesson out there, and if you go check that one out, about index maintenance. And one of the things we did there was we wrote a query that went and looked at your index fragmentation, and then you could make decisions based on that to go rebuild your indexes. Well, that's the manual way to do it. This is the automated way. So I can come down here and I can say, look, we're going to do a reorganize index, but only if the fragmentation is over 15%. And in this case, they have another option, only if the page count's over a certain amount. So basically, only if it's a big index, because we don't really care as much about small indexes. And finally, only if it's been used. So why waste time on an index that's fragmented that I haven't used in the last 7 days? You know what I mean? So you can really limit this down to say, rebuild or reorganize my regularly used indexes that are over a certain fragmentation level and over a certain size. So I can click OK on that. And again, if you want to see the T-SQL on this, it will come up, and this one is going to generate it. And there it is. So it's going to alter index, and it does each index throughout the entire database. What you don't see in here, obviously, is it's not saying checking the fragmentation level and everything else. And it even says here, this T-SQL may not necessarily be what it's going to do because of conditional logic. okay? So there is some conditional logic that it does that you don't see as part of the T-SQL. What you see there is the result of it running the reorganize. So I'll click OK. And there you go. I've now made a check database subplan that I could go ahead and I could click this little guy right here, this little teeny schedule button, and I could make this run weekly on Sundays at midnight, and I hit OK. And then this full backup, maybe this runs, I'll click the schedule, maybe this runs daily and I don't want to do it at midnight, right? I don't want to do it at the same time as my other tasks, so maybe I do this at 4 a.m. I hit OK. And so now I've made a maintenance plan. It has 2 subtasks. And again, you can go as deep as you want in running all these other tasks. You can link them together in one subplan as I did here, or you can create separate subplans for separate pieces. So maybe I also implement my backup strategy by putting in T-log backups and differential backups. And it's all saved in this particular maintenance plan. Then I hit save up here, and the maintenance plan is all saved, and it's all scheduled, and it's ready to rock and roll. So I close this. Let's go back to our Object Explorer. And now if I refresh my maintenance plan folder and expand it, you'll see I have maintenance plan, and I can always double click it to get back in here and make changes to it. Okay. You'll also notice in my SQL Server agent, those schedules actually created jobs. So maintenance plan, which is the name of it, dot backup full got a SQL Server agent job, and so did checkDB. And so if I look at that, we'll go into backup full, you'll see what this does is it's in database maintenance. That makes sense as a category. But the step here is called backup full, and if I double click it, you'll see instead of running T-SQL, like some other jobs we've set up, this is running a SQL Server Integration Services package. So I mentioned at the beginning of this that maintenance plans are sort of built on the SQL Server Integration Services engine. And this is how that works. So these tasks are also available in SSIS packages, as are a host of others for extract, transform, and loading of data. But you'll see here the package that I'm going to run is maintenance plan. Right there. And then if you look at some of these configurations and command line stuff, there's all these different execution options you can set up for SSIS packages, not necessarily all things that have to get set up for this particular package because it's just a maintenance plan. But that's how you can go see what it's running, and it is just scheduling an integration services package. And it's scheduling it, on our schedule. So if I go back here and look, that is the schedule we set up to run every day at 4 a.m. So you sort of get this linkage between jobs and maintenance plans, but modifying your maintenance plan will take care of updating those jobs for you. Okay. So that was kind of a quick look at SQL Server database maintenance plans. I think they're fairly useful little tools. They're easy to build. It's easy to put some checks together, and you can manage them all in one place. You can copy them to other servers. You can actually talk to other servers with them. It's a pretty powerful tool. And if you even want more than that, you could actually go up to a full-blown SSIS package. You can install SSIS. You have access to all those maintenance tasks just like you do in here, but then you have access to all of SSIS. And there's some power there if you need to do maintenance around extract, transform, and load packages that you're running. And obviously that's well outside the scope of this lesson, but I just wanted you to be aware that that does exist and it's something you can look into. So hopefully this lesson sort of allows you to take all the different administrative tasks that we've touched on in all these other lessons and give you a really great way to automate them and manage them on your servers. So if you've done any sort of system administration recently, you've probably discovered PowerShell. PowerShell runs, it's a scripting language that runs on Windows, and you can do just all kinds of stuff with it. I mean, it's darn near a full-fledged programming language. And you can access components of Windows, components of SQL, and it's a great tool for helping you automate some of your administrative tasks. So I want to show you 2 quick ways that you can use PowerShell in SQL Server. Now, this isn't a PowerShell lesson, so I'm not going to go deep into writing PowerShell code, but I'm just going to show you where you can access them, the areas to run PowerShell against your server. So the first place you can do it is in SQL Server Agent Jobs. And I'll just pick one here, this backup database job, and open it up. and I'll go to steps and I'll hit new step. And one of the step types you can put together is PowerShell. So as soon as I do this, I then have access to this little window here, and I can paste a PowerShell script in here. And that PowerShell script is going to run as whatever account is specified here, in this case, my SQL Server agent account. This PowerShell script, though, is not limited to SQL. It could go do other things. It could look at Windows. It can connect to other resources. So you can write anything you want with this PowerShell. You can even have PowerShell has a lot of plugins and ways you can query SQL. So you can actually ask SQL for your list of tables or lists of indexes or lists of users. It's all pretty powerful. And again, I'm not going to explain a lot of PowerShell, but you can go ahead and write your PowerShell scripts and run them as SQL Server agent job steps. So that's one way. Second way, you can just use PowerShell in a script to talk to SQL as long as you know how to set up the connection. But SQL Server also gives you like a launch PowerShell option. So I'll show you that too. So I can just right click a database here and I can hit Start PowerShell. And this will fire up a SQL Server PowerShell command line. And you can see here that I'm connected to my SQL Server, and then it browses. Like PowerShell uses a lot of what looks like browsing folders, but what I'm really doing is browsing resources here. So you can see I'm connected to my machine, SQL Inside Out, databases, worldwide importers. So I'm in that database. And now from here, I could start writing PowerShell scripts that talk to the objects in my database. Again, I'm not going to really go into a ton of PowerShell, but I'll show you one little thing here real quick. So if I type invoke-SQL command, and you can get like some autofill, it's helping me out there. I'll pick this one, invoke SQL command. Then I give it a string that is a SQL command. So I could do something like select @ version, which essentially just selects the version of that SQL Server. And then I hit enter, and you'll see that kicked back a result with one column and told me Microsoft SQL Server 2022. Likewise, I could run select statements, select star from, and this is we are inside the Wide World Importers database. So I can select star from sales.orders. That's fine. I'll just do that and I'll hit enter. And you'll see it's just going to start dumping data to the screen. And that's basically because it doesn't kick it out in like a nice little table format. When you do that, the invoke command just starts throwing out information. So here it actually gives the breakdown of one order, and it gives the column name and the value. So I can use I could narrow that down. So I could just say, let's just do where order ID equals 4, 10, just to be safe that I have it. Then I'll just get that one command, okay? So again, I'm not going to dive into writing PowerShell, but I did want to show you that if you have SQL Server installed and you have all the PowerShell stuff ready to rock and roll, you can come in here and you can start writing PowerShell against your SQL Server. And again, PowerShell's fairly, I mean, it's in the name, very powerful, and it allows you to do a lot of things in that automation realm. So two main ways, obviously we talked about them, PowerShell's command prompt like this, or a PowerShell job step in a SQL Server agent job. And again, you can, from your external PowerShells, connect to SQL Server and essentially get to this same place that we just showed in this PowerShell script. And then you can start running PowerShell to administer, query, whatever you need to do, and just really help you automate all of your SQL Server tasks. Thanks for following along with me through these SQL Server 2022 Administration Inside Out lessons. I hope you found this to be an educational and worthwhile experience. Let's recap what we looked at. We started by looking at how to install SQL Server administration and development tools, and took a closer look at several of the more important tools. We looked at the various components of database servers and some common configuration options for the database engine. We covered how to provision SQL Server databases and how to configure databases on your SQL servers. We talked a bit about provisioning Azure SQL databases and servers and the basics of working with Microsoft Azure. We covered implementing and managing SQL Server user security and permissions. We looked at steps you can take to further secure your data and looked a little closer at Azure security. We covered basic database design by talking about SQL Server tables and looked at some special table types. We also covered views and discussed change data capture. Performance tuning and optimization is important, so we covered indexes and statistics as well as isolation levels and execution plans. We looked at options for developing, deploying, and managing data recovery, specifically looking at how you can plan for and recover from the unexpected. We covered high availability and disaster recovery, talking about the technologies available to keep your systems running in the event of a disaster. We talked about managing and monitoring SQL Server databases and covered some tasks you should perform regularly to keep things performing in peak condition. Finally, we talked about strategies for automating SQL Server administration. We talked about what is available for SQL Server automation, and we looked at maintenance plans and how you can use PowerShell to automate some of that administration. Now we've covered quite a lot of material in these lessons. And now that you have this knowledge, go back and look at your own environment. Are there things you can do better or differently? Are there things that aren't being done that really should be? Maybe this was your first exposure to SQL Server, and in that case, I hope you now have enough of a foundation to begin administering servers in a real environment. In any event, I hope that you've gained the knowledge you need to do your job and keep SQL servers under control. Thanks again for spending some time with me and these lessons. Take care.